Hello kids, welcome to yet another wonderful session by Physics Wala. This is Sriraj, your physics tutor for the day. How are you all doing? It's been exam time and you all have been super excited for the exams, and we have brought you marathon sessions. To make your lives easy, we've got like one shot marathon. It's like what happens? All the subjects will be streamed live for you exclusively for 9 CBSE boards, where you will be having complete access to all the chapters in a comprehensive manner. How are you all doing today? Well, if my audio and video are really super clear, you can just give me a thumbs up in the live chat. So how are you all? Hi there. A very good morning from Kolkata, West Bengal. Yes, thanks a lot. A very good morning from my side as well. How are you doing? Are you super excited? Hi, sir. So we have got Harshpal saying hi. Hello, Harshpal. How are you? I'm super excited to teach you physics in such a easy, comprehensive manner. So, are you all ready? Well, you know what? Usually, what happens in marathon is the session goes very, very, very long. But you should also have energy, right? So, what I do is that let's start slowly. So what happens here is that we will be taking the thing so slowly so that by the end of the session, you'll be still having enough energy to, have enough energy to complete it. Sir, I don't understand any other language except English and Bengali. No worries. This is an exclusive what? English channel where we will be teaching entire thing in only English. So no need to worry about that. Sir, where are you from? Well, can you guess? I'll tell you what are languages I know and you can guess where I might be from. I know English, I know Hindi, I know Kannada, I know Telugu, and these are the four languages what I know. Can you guess where I might be from? Alright, so yeah, without any further ado, let's get started. So the first thing is that you all know that what kind of session is this? This is going to be a marathon session. So what happens in marathon? In marathon, usually you start and there will be a really long run, and well, you guessed it right. Okay, so let's come back from where I am from, but still listen, let's talk about marathon. Okay, I mean, it will be a really super long run where you should have enough energy, right? You'll start slow, you'll run in a strategic way, and by the end you will be completing the race with super high momentum. So the same thing is going to happen today as well. You'll be relaxing, listening to my class, where of course I know you'll be having lots of assignment notes to do. It's exam time, you're almost exhausted. So what I tell you is that look into this live, sit back and relax. Wherever you've got important stuff to note down, I'll be there to help you out. So shall we get started? So hi, you said it right, Ghosh. So I'm from Bangalore. You said it absolutely great. Hi sir, study with Aditya says, sir, I'm from PW. He sir, hello there. Welcome to the class. A very good morning to all of you here. So let's get started. Well, you all know what chapters we do have in physics, right? So what are the chapters we do have in physics? The first one is motion. You all know, such an easy topic. We have got like 3 derivation for equation of motion, got some numericals, and understanding the basic terms, right sir? What's the second chapter? Laws of motion, force and laws of motion. That's our second chapter, right? What's our third chapter? We've got the third chapter to be, can you guess what's our third chapter? It's you can either take work and energy, we've got gravitation, and then we've got sound. So these are all the topics what you have in your 9 CBSE. So let's get started with first ever chapter of today, that's motion. All right, so I hope you're all super excited. Usually what happens in marathon is you should be having so much energy, and how much ever energy you have, I'll be kind of resonating with you, and my energy will be almost kind of twice of what you have. So let's get started. So first ever thing what you kind of learn in motion is understanding the basic terms. What's rest, what's motion, and how can we relate both of them, right? So can we easily say rest means any object which is not moving, that's rest. Any objects that's moving, that's in motion. Is it done? Is it completely done? Or do we have something else to add? Do we have something called as perspective as well? Well, we are going to see now. Hello Krish, how are you? Hi there, welcome to the session. NSJR, welcome to the session as well. Hello there, good morning. I hope you're all super energetic, had a good lunch. Hello Samriddhi. Yeah, Gosh, yeah, definitely. We are absolutely going to take the equations of motion, solve that, numericals. Hello Krish, Adarshi, hello there. Did I say your name properly? Krish, hi there, welcome to the session. Right, Samriddhi, hi once again. So let's get started with understanding the basic terms related to motion. The basic terms are rest and motion itself. So when do we say anything is in rest and motion? Well, if it is not moving, we call it as rest. If it's moving, we call it as motion, right? Sir, take Ladakh name, hi there. Distance displacement is also there. Definitely it's there. Definitely that is also covered. Well, we've got two scenarios. The one is people are inside the bus. So you can see, I guess this is a train, right? So people are inside the train. Now what is happening over here? So here we have got a view outside the train, okay? So now, if you see whether the train is moving or not, well, of course, you can see the train is approaching to the station and we see the train is moving, right? So what is happening is that we say the train is in motion. Why? Because it's like the train is kind of approaching into the station. So we call train is in motion. But what's happening over here? To try to explain you regarding rest, my dear students. See what all we have got inside the train. You've got like us, if it's a metro, it'll be having the digital panels, okay? And you have got like poles, like you can see we have some handles and we have some poles over here. We have seats, we have doors. So what happens is that as the train moves, do you think they also move? Yes or no? The train is going. Do you think the handles inside the train, the windows, the doors will just go in the front and you'll be sitting wherever you are sitting? No, right? That happens in cartoon, right? So this will be moving along with you. So there is a thing where we talk about perspective. We cannot absolutely say anything is in rest or anything is moving because see, let's say this guy is sitting over here and when the train started, this window is over here. Next station comes, another station comes, another station comes. This window will be wherever it is, right? This pole will be wherever it is. So the pole, window and the entire train is moving along with this guy. So train is it rest for the people who are inside. But the same train seen from outside, what's gonna happen? So there will be a train that has been seen from outside. So what is happening? People can see the train has shifted its position as the time goes. So the train is at a motion for the people who is outside. So Krish says, please reply. So what's your question, my dear? What's your question? I'm going to definitely help you out. Alright, so outside what is happening? The train is in motion, right? The train is in motion. But what happens for the people inside the same train? Seen from inside, okay? Absolutely great, Ghosh. Very good. Rest for the people from inside and for outside its motion. You cracked the code. Hats off to you. Well, that's right. From inside, the train appears to be at rest. Clear? So I hope this is clear. What is this? I do not understand. Ujjwal, we were talking about rest and motion. Okay. Well, I will be explaining. I've got another slide just for you because there will be having a bit of confusion while understanding this. Rest and motion. Ujjwal, we were talking about rest and motion, okay? So rest is when we say the objects are not moving, okay? Motion is when we say the objects are moving. I'm repeating for you, Ujjwal, I'm repeating for you, all right? So let's say you can see, this is a park, right? This is a park and we've got like many buildings all around. You've got a building, and you've got a skyscraper and all. When you see this building inside the earth, okay, listen, I'm explaining. When you see the building inside the earth, the building will be wherever it is. You come tomorrow, again the building will be at the same place. You come day after tomorrow, the building will be at the same place. But imagine you have got an opportunity to go into the space. Like you're watching the same building, okay? You've got, let's say we have got a, skyscraper. Skyscraper is a big building, okay? Now, if you watch that building from the space, what's happening? The building is over here. The earth rotates. As the earth rotates, the building moves. But earth has also got the capacity to revolute, right? So earth will be what? It will be revoluting around the sun, right? Sir, okay, Srishti says hi. Hi, Srishti. How are you? Welcome to the session. So whenever we say an object is moving with respect to an observer, then only we can say the object is in motion. Got it? So here the skyscraper looks at rest, okay? Looks at rest when seen from where? Seen from Earth, okay? Now, if you kind of observe it from the space, okay? So what's gonna happen? The skyscraper looks kind of, changing its position, okay? So understanding rest and motion is very important because rest and motion is a relatable term, all right? Hi Sunita, welcome to the class. Welcome to the class. Well, over, I just gave you a shout out. I just said hi to you. All right. Now here, the same building as seen from where? Space. Okay. What's gonna happen? This looks not stationary. So I hope you understood. Rest and motion are relatable terms. We cannot absolutely say whether the thing is in rest or a thing is in motion. There has to be an observer who can say whether it's rest or in motion. Sir, what's your name? My name is Sriraj. I just introduced myself during the starting of the class. I am Sriraj. Got it? Right, so we just got to know about rest and motion, sir. Do we have something else? So these are so pretty basic, sir. Shall we go to another higher level where we will be learning about many other concepts of physics of the chapter motion? Absolutely, why not? Let's go ahead and talk about distance and displacement. So, hi Aditya, hi there. Krish, you said you have a doubt. What's your doubt? You can go ahead and type your doubt in your chat forum. I'll be here to help you out. Okay, talking about distance and displacement. See, rest and motions are the basic terms. You might expect a question on distance and displacement whenever you are attending your 9 CBSE exams. Okay, understanding distance and displacement. Imagine a scenario. You have been told two cases. I've got like two cases, okay? First case is that your mom or dad tells you to go and buy some, fresh milk from nearby parlor. What are you gonna do? You're kind of cozy and playing games on your couch. Even though it's exams, you're kind of trying to play games, all right? So what's gonna happen? So here, what is happening is that you do not want to actually go, and after coming, your parents will be telling after coming from the milk. So it's like kind of study. So what you do, you wanna kind of enjoy, right? Because you have lots of pressure. You will be going from your house. Let's say this is your house, okay? You start from here, and then you'll be like, let's say this is the store where you have to reach, okay? So you'll go here. You take here, you have a bicycle with you. Instead of directly going, you go to your friend's house. This is your friend's house, okay? And then you have some chat, go turn around, and then you come here again and go like this. So this path which you took, because you do not want to kind of come home and do the other chores, so you took the longest route, right? So the actual path covered by you is what we're going to call it as distance. Got it? Sir, please, important questions करवा दो science का. Definitely those will also be covered. Sir, can we speak? Right, yeah, of course you can. Sir, can we say tree and... Alright, this let's keep the topics very focused to physics, alright? Okay. What's your question? Tree and human are interdependent to each other. Well, yeah, of course we can say that. Sure. Let's come back. When in the first case, when your dad said or your mom said, go out, buy something, as soon as you come to the house, you have to do so and so chores. Yashaswini asking about 10th. Yeah, 10th marathon is also planned. We will be, kind of saying that as well. So just keep exploring the channel, go through the community posts where you will be seeing everything. Prabhat, yes, 10th marathon kab hogi? Well, we are planning somewhere, okay? The dates are not so sure. Before the exams, marathon will be happening. No need to worry, we have got you covered, all right? Coming back to distance and displacement. Distance is the actual path, all right? So what is distance? It's the actual path covered, okay, by an object, okay? Path covered by an object. So what's that? That's distance, right? That's distance. Now, talking about displacement. Second scenario where what's going to happen is that you will be told, come quickly, we are going for a movie, all right? So what happens in that is that, so in movie, you will be kind of super hurried. So this is the store, this is your house. Even though you have to go to, movie, you'll go to the store quickly and come back quickly, right? Poll, yeah, poll will be given, not to worry. Polls are also included in the session of body polls, okay? So this is your, house, okay? You're gonna call it as home sweet home, right? This is your house. Now, how are you going to go? Even though there are no paths, you'll be just kind of jumping all the obstacles in the middle and you will be reaching. You'll be making your own path, right? You're going to kind of make your own path. And what are you going to do? You'll be like kind of traveling there, jumping there and going, because of course it does not have to make you late for the movie. You have to watch all the scenes, right? So that's what we're going to do. So displacement is the shortest path between starting and last point. See, this is your house, okay? You somewhere start from your house or you were playing over here and you take a shortest route, jumping the walls, going on the lawn and all, okay? Great. Aditya, you've got a poll. Okay, thanks for the compliments. I really appreciate your gesture, okay? So displacement, let's gonna talk about displacement, okay? Displacement is like, it's the shortest path between 2 points. We've got point A over here and we've got point B over here. The shortest path between 2 points is what we're gonna call it as displacement. Got it? So we can actually define displacement this way, okay? It's the shortest path. Shortest path between where and where? Between 2 points is what we call it as what? Displacement. Clear? A poll is up for grab and you will be just kind of, answering this poll. Well, before that, let me tell you the SI unit of both. SI unit of both distance and displacement is meters, alright? SI unit is meters. Whenever you have got this numerical, do not forget to write the SI unit, because the SI unit also carries marks, okay? Right, so let me give a small poll, a warm-up. I hope you all know how to attend the poll. Whenever the poll pops up, you will be giving your answers in the chat forum, in the sense A, B, C or D. Distance is 0, but displacement is 0. What about notes, sir? Well, Ghosh, notes will also be available. See, if we go ahead, we have this. What's the distance? What's the difference between distance and displacement itself? We're going to talk about it. Shall we go talk about the different points about distance and displacement? Are you all ready? Let's see. Well, before that, you know what? Let's take a case where a person starts from home, okay? He starts from his house, okay? So let's say this is his house, okay? And then you start from your home, and whenever I say your home, it's called as house, okay? And you reach, let's say, a shop, okay? You're gonna reach a shop. After that, you have to come back to your house, right? So you're gonna come back over here. So displacement, what did I say? Displacement is the shortest part between 2 points, right? So in this case, the starting point is home and the ending point is also home. When the point is same, the distance between them is what? It's 0, right? So that's why we say displacement is 0. Hats off to you. Very good, Ghosh. You said it right, okay? So you can just kind of make a note of it. When the starting point, okay, starting point and ending point are same, and ending point are same, what's going to happen? Are same. The distance between starting and ending, it's the same point. We don't have any distance. That's what we call it as displacement is to be 0. Then what happens? Then our displacement would be 0. Okay, displacement is said to be 0. Remember this. Okay, we have another scenario where displacement can be 0. Can I give you an example for that? Can you think of a geometrical shape where the shape ends whenever you kind of reach to the same point? Well, all closed shapes, right? So imagine you've got a circle, okay? So imagine you've got a circle. So what's happening in the circle is you start from here. Let's say you start from here, and after one lap, when do we say one lap is covered? When you kind of end at the same place, right? Great, Aditya, you said it right, circle, okay? So this is start, okay? After one lap is like one round of it, right? So this will be stop. This itself will be stop, okay? Even though you have covered like 20, 40, 50 meters running around a circle, we say displacement is 0, okay? It can be any geometrical shape, of course, because even in triangle, what happens? If you want to run in a triangular path, what's going to happen? You're going to end up in the same place where you have started, right? So that's about displacement can be 0. We'll also talk about when it's negative, when it's positive, all those things. Just wait and watch. All right. So here we are going to talk about distance and displacement. Distance is, I just gave you the definition of it, okay? You can write this for first point, okay? For first point, you can write what distance and displacement is, and then you know what we're going to write. Distance is always positive, okay? Always positive. Why is that, sir? Of course, you cannot, you may run backward, but backward is also covered as you ran backward 4 meters, right? So distance will be like positive. Displacement can be, it can be positive or it can be 0. We just saw how it can be 0, right? Or it can be negative. How it can be negative, sir? Pretty simple. Let's say you go from point A to point B, okay? And this is the path of point A to B. And after coming back, what you do is that you reach point C in this direction. So if in this case, point A to B is 5 meters, okay? Okay, and then you come back to A to C, that is another 5 meters, okay? In this case, what is happening? What's going to happen with displacement, okay? I hope that's not visible, is it? Sure. That's not visible. I'm going to redraw, okay? Imagine you have a case, point A, point B, and you've got point C. From A to B, you go, that's 5 meters. And from A to C, you come back another 1 meter. So what's the displacement in this case, you might ask, right? So displacement is, what's the, shortest path between starting and ending? You started at A, you ended at C. So A to C. So what's the distance? Of course, you can take going in this direction to be positive, going in opposite direction to be negative, all right? So in this case, it's like technically if they ask you to calculate, you should do A to B plus he comes back from B to A minus, right? Minus 5. So it's like B to A to B, it's done. It's B to A plus again he comes from A to back where? To C, right? Conventions are used, correct, Aditya? It's A to C. Now, if you can consider any direction to be positive or negative, but you have to clearly mention what direction is positive, what direction is negative, okay? So starting from here, if you go in this direction, so we are considering it to be positive. So A to B is 5 meters and B to A is negative 5 meters. Okay, and A to C is it's in the opposite direction, right? So 1 meter. So displacement will be how much, my dear students? It would be minus 1 meter. So this is how we say displacement can also be negative. Got it? So let me go ahead and make a copy of this. So you will be having a copy of your notes so to refer how displacement can be negative as well. Got it? I hope it's clear. It is always positive. Displacement is it can be either positive, negative or 0. Okay. This is the actual path covered. Actual path covered. This is the shortest path. Okay. This is the shortest path. Shortest path between 2 points. What else we can say about distance and displacement? Distance is a scalar quantity which has got only magnitude, no directions, only magnitude. It's a scalar quantity, and this have got both magnitude and direction, so it's scalar and vector. Yeah, right, the magnitude and direction, so it's a vector quantity. If you write this much well, you'll be given complete marks. I've brought you a question where you will be given a pole, and in the pole you know how to do, right? So we'll be having kind of all some options will be there. You'll be giving the answers, all right? So here comes the options. The options are for this 6 kilometers, option B, 5 kilometers, option C, 10 kilometers, and option D, it's 7 kilometers. Okay, let me start the poll. You've got 1 minute of time. Give me your answers, and in the meantime I'll be able to help you out. Sir, second slide please. Well, the notes will be available, my dear. I'll go to second slide, but let's see here. A car travels a distance of 1 kilometer towards east. Well, talking about the directions, this is north, this is east, this is west, and this is south. So what happens? A car travels a distance of 1 kilometer towards east. So it's going in this direction, right? All right. So east, it is going in what? How much kilometers? 1 kilometers. And then it goes 4 kilometers towards north. So north is up. So north, okay, north, it's going 4, okay. Then it finally reaches it finally goes 2 kilometers east. Another 2 kilometers, it goes east. That means from here, after it reaches 4 kilometers, it goes another, how much? 2 kilometers east. Now let's see the answer, of course. Let's see distance and displacement. You're supposed to find distance and displacement, okay? So distance is given by 4 plus 2, 6 plus 1, 7 kilometers. What's this? This is distance. Those who all gave D, 7, that's right, this is about distance. 100% of you have given the right answer, and we have got Ghosh at first place, Aditya at second place. Hats off and congratulations to you. Now, talking about displacement, how can we find displacement? Can you tell me how can we find displacement? Displacement is what? Is the shortest part between starting and ending point, right? So we can take this as start. This as start. This is what? This is where it is ending. What is shortest part between starting and ending point? That's a straight line, right? So if we kind of draw a straight line between starting and ending point, what are we going to get? We are going to get the displacement. How can we find the displacement, sir? Well, at this point, you might be able to see a triangle. Are you able to see a triangle? Do it again. Pole is not yet up. In the meantime, I'll be giving you the pole, okay? Find displacement in this case. I'll be giving you a pole. Pole has started. In the meantime, I'm explaining. If you are able to see a triangle, well, you've got the answer. So this is how triangle is formed over here, right? This is 1 kilometers. This is 5. So this is 4. So in this case, what's going to happen? You will be able to, okay, for displacement, what happens is, let us change the question for displacement, because you might not gonna get the right answer. It's not 5, it's 2, right? It's 1, 4, 2. This has to be 2. Just give me a moment. This is how much? This is not 5. This is 2, because it goes 1, it goes 4, it goes 2, right? So this has to be 2. Okay. Just give me a moment. Poll has stopped. Poll has not yet stopped. Just give me 1 moment, students. All right, the poll has stopped. This is, okay, let me try to write it over here. It goes 1 kilometers towards east. We have got 1 kilometers. Just give me a moment. The pens are not working. Hold on. I've got it. Okay, so here what is happening is that you've got like 1 kilometers triangle. Let's form a triangle. Okay, so it's like 1 plus 2. How much? We've got 3 kilometers over here, and it goes 4 kilometers towards east, and the displacement is given by green line. So if you find displacement, the shortest part between displacement, I mean starting and ending point, right? So if you find, let's name it as A, B and C. How does it look like? It looks like a right angle triangle. In a right angle triangle, you know hypotenuse square is equal to, that's AC square is equal to AB square, sum of other two sides, plus BC square, right? So what would be AC? AC would be square root of AB square. AB square is 3 square. That's how much? 9. 3 square plus BC square, it's 4. 4 square, right? So you would be getting root of 3 square is 9 plus 4 square is 16. So AC would be how much, my dear students? Root of 25 is 5 kilometers. 5 kilometers is what? Displacement. Is it done? Is it clear? Whoever gave 5 is the right answer. Let's go, okay? And see the poll whether you have given the right answer. Displacement is option B. Okay, why no one gave me the right answer? Option B would be the right answer. See, whenever you're trying to attend the poll, do not type your answers, because we might have to kind of write the answers option A, B, C or D in the live chat, okay? No poll coming. Let me check whether the poll is coming. Here you've got like 45 seconds poll. Check whether the poll is coming. In the sense, poll wouldn't pop up. You have to type your answer A, B, C or G, okay? You type your answer, this will be recorded. I just told you the answer, option B. Now let's check whether if it's working or not. Aditya, go ahead. Let's see, okay? I'm going to stop the poll and see whether if it is coming. Well, of course it came, right? Aditya, it's working. The poll is working. Let's go to the next part to understand what are the common mistakes you might do. See, some of the common mistakes you might do is that in a circular path, whenever they ask you to find the displacement, you might write displacement is equal to, in circular path, what might happen? You might think displacement is circumference, because it is the shortest path. You cannot go somewhere. You cannot take your car like from here to there, right? But that's wrong, okay? In a circular path of one lap, one circle, displacement is not 2 pi r. Is not. This is wrong. So what is the displacement? Displacement in circular path would be 0 meters, kilometers. It can be anything, okay? What you are saying diameter is that between 2 points, point A and point B, if it has made half lap, okay? If it is like half circle, half lap, in this case, what happens? From here to here, it's the diameter, right? It's the diameter itself. Absolutely great, Aditya, right? It's diameter. Diameter would be what? Our displacement. I hope this is clear. We will be going to the next part, talking about speed. Speed is the one thing which you all love. Whenever you are not with your parents, you're going to ride your bike with super high speed. So how it can be 0? Please explain. Dekho beta, what happens here is, I told you, right? Displacement when it is 0, when starting and ending point are same. I told you, right? In displacement, when the starting point and ending point are same. Starting point is there and ending point is there. In a circular path, what happens? You start from here. This is start. This is where you're going to start. Make one circle and this is where you're going to stop, right? When start and stop are same, what's going to happen? What's going to happen? Gosh, the displacement would be 0. Clear? Is it clear, my dear students? So this is how it happens, okay? Now talking about speed. You all know speed is how fast, measure of how fast it is going. Alright, great that you got it, okay? Speed is nothing but measure of how fast a thing is traveling, alright? And speed has got the formula distance, total distance covered, distance divided by time, okay? So if you can, cover this much distance slowly, we say the speed is less. But from here to there, if you're gonna run like this, your speed is more, right? The same distance you're covering in a different time, right? So this is what is speed. So what would be the SI unit, sir? The SI unit is simple. Distance is meter, right? SI unit of speed. Distance is meters. Time is second. So SI unit would be meter per second. As simple as this. So this is our speed. Got it? Now let's go talk about displacement. The rate of change of velocity is displacement. Okay, we can write it as rate of change of what? velocity, rate of change of displacement is velocity, okay? Displacement. Now how velocity is written as? Velocity is equal to displacement by time. We have displacement here, we have time here, and SI unit of displacement, if you remember, I said what is the SI unit of displacement? That's meters, right? So displacement is meters, time is second. Even velocity has got the SI unit meter per second. You can also write meter per second. S raised to the power of -1 means it is in the denominator. Got it? Great. Wow, absolutely great. Now let's go to the next part to understand uniform and non-uniform motion. Well, uniform motion is when we call when the object covers equal distance in equal interval of time. Okay, Aditya, meter per second square. Well, that's for acceleration. We are going to talk pretty soon. All right. Now, talking about uniform motion, if it covers equal distance in equal interval of time, we are going to call it as, that's uniform motion, okay? Equal interval of time. But in the case where if it covers unequal distance, okay, unequal distance in equal interval of time, or equal distance in unequal interval of time, that's what we're going to call it as non-uniform motion, okay? Unequal interval of time, okay? Interval of time is non-uniform motion, okay? In uniform motion, speed will be same, but in non-uniform motion, speed or velocity will be different, right? So in uniform motion, what will happen, my dear students? The speed will be same, right? Speed or velocity will be same because it covers equal distance in equal interval of time. That's a uniform motion. But over here, it would be varying speed or varying velocity, okay? Varying speed or velocity. Got it? I hope this is clear. Okay. So now going to the next part to understand what acceleration is. So acceleration, you might have seen those racing movies where, you know, a car will be going, it accelerates so fast that it overtakes other cars. So what does acceleration means? Like if you pedal, or if you kind of press the accelerator in the car, you might have seen your dad, okay, driving. The car goes super quick, right? In the same way, if you accelerate your vehicle goes super fast. What's acceleration? It's like talking about how speed is varying, right? Ghosh, what happens is we've got notes, okay? You'll get the complete notes. No need to write because it's a marathon. We are running, okay? So it's like one-shot revision of everything. You've got lots of time to write the notes when you get the notes, okay? The notes will be shared with you in all our social platforms, okay? Great. So talking about acceleration, acceleration is talking about speed, okay? How speed increases or how speed reduces, okay? Acceleration is given by, can someone tell me what's acceleration? Acceleration is rate of change of displacement, okay? That's displacement divided by time, okay? That's velocity by time, rate of change of velocity, okay? Acceleration is rate of change of velocity, okay? That's velocity divided by time, okay? So it's like how speed is increasing, how speed is reducing. That's what it is. Yes, in PWR, definitely you're gonna get the notes of this. Absolutely great. Thanks, Aditya. All right. So it's like a rate of change of velocity. So what's the SI unit, sir? Can someone guess me the SI? Can someone give me the SI unit of it? SI unit can be given as, if you remember the velocity SI unit, I told you meter per second, right? So we've got meter per second. This is for velocity. For time, we've got one more second, rate of change of velocity, right? So how to write, sir? So meter per second, we've got one more, so meter per second square, or you can also write meter per second square. This is the SI unit of acceleration. Is it clear? I hope you all are enjoying this session and you have understood. If you have any doubts, you can easily go to the live chat and let me know of all your doubts. I'll be here to help you out. Got it? I hope this is clear. This is acceleration, okay? Now, talking about a small numerical. How to do this? Well, we have got a small numerical where you will be having, opportunity to answer this numerical, okay? So the numerical goes like this. A motorcyclist drives from A to B. Where he's going from A to B with a uniform speed, okay? He's going with a uniform speed, he's going with certain speed, okay? Now the question is, and returns with a speed of 60 kilometers per hour. What's the average speed? See, this question can be done so easily. Average speed is given by total distance traveled divided by total time taken, okay? So we are going to use this formula to understand what's the average speed. For normal speed or average speed, the answer would be same because the SI unit would be meter per second. Answer would be different, but the unit is same. Got it? So, but nothing has been given, sir. How can we do it? You will be using a speed formula, okay? While going from A to B, let's say this is point A, okay? This is point B. While going, he goes with 30 kilometers per hour, right? 30 kilometers per hour. While coming back from B, okay, let me change the color and help you how to understand. From B to A, what is happening from B to A? He comes with twice the speed. So he's coming from B to A at 60 kilometers per hour. We're supposed to find the average speed, okay? Total distance we don't know, total time we don't know. Let's see, okay? You want options, I can give you options, okay? Let me give you the options. If you write somewhere near to this, it's fine. Option A, it's 10 kilometer per hour. Option B, it's 11 kilometer per hour. Option C, it's 20 kilometer per hour. Option D, it's 3 kilometers per hour, okay? Here comes the poll. You've got like 120 seconds. This is a bit difficult question, so I'm giving you more time for you. Let's see how to solve. See, nothing has been given how to solve this. You know that speed is equal to, speed 1 is equal to distance traveled by time taken, okay? We have different speeds, so we are going to take T1 and T2. But the distance is same, right? A to B is equal to B to A. He's going with the same path. So we can take the total distance to be, we don't know, unknown X. So we'll be taking X by T1. So we want total distance, you can cross multiply, right? X is equal to what? Speed is what? 30 kilometers per hour. 30 into T1. Similarly, speed 2, okay, is given by 60 kilometers per hour. You can see that, right? 60 kilometers per hour is equal to X by T2. So X will be given how much, my dear students? X will be 60 times T2. Okay, clear? I hope this is clear. Now, what happens is that if you see T1 and T2, he's going with this much speed, he's coming with double the speed. So T2 will be what? Half of T1, right? Because from here to here, if you go with one speed, come back with double the speed. So time and distance are inversely proportional, right? So in this case, what happens? We've got T by 2. So T2 can be written as T1 by 2. Got it? So substitute this in this formula and let me know the answer, what you are getting. Whatever you get is our average speed. That's you've got still time, okay? Shall we do it? So average speed, right? Average speed is total distances. X1 is 30 T1 plus X2 is 60 T1 by 2 divided by, what's the total time taken? Total time taken is time for going T1 plus T1 by 2. If you solve this, you'll be getting the answer, and the average speed you get is option B, that's 11.11, okay? Those who are all given option B is the right answer. See, if you solve this, okay, those who gave A also fine, because you might be not using calculator, you'll get somewhere around 10 and 11, fine, but try to be as precise as possible because precision is very important. Fine, let's go to the next part where we are going to talk about slope of a graph. Why slope of a graph is important? Because when we talk about slope and the chapter motion, equations of motions are there. You all are waiting to learn equations of motion, and I know that. So the moment for what you've been waiting for is over here. I'll make this derivation so easy that you will enjoy and you will remember this till your exams, okay? So let's talk about slope. Now, slope is like steepness, okay? While, going on top of a hill, while hiking and all, you might say, or you might hear your brother or your parents saying, do not go there, it's so much steep, okay? it is not coming average speed. Average speed, of course, it will come, my dear, because see what happens. See what happens is that, so here what happens is 2 times 1, 2 times 30, right? So you'll be getting 30 T1, 30 T1, you get 60 T1 divided by 1 plus 1 by 2 is how much? You get, like, you can take LCM, right? So you get 3 by 2 T1. So this gets cancelled. 60, 120 by 60 by 1.5. If you do, you'll be getting 11 kilometers per hour. You can roughly get 11 kilometers per hour. You can get it, okay? Option B. Right. Great, Aditya. Hi, Vidyasagar Yadav. Welcome to the session. Hello there. How are you? Okay. Going to the next part, okay? Graphs are super important, because when you try to launch the rocket, lots of data is there. It's very difficult to consume all the data and put it in the books. So if we have graphs, we can easily analyze stuff, what's happening in the background. So that's why you can see here, whenever there is rocket launch, they will be analyzing lots and lots of data with the help of graph. Graphs are the one thing which helps us to analyze the data, right? So in this case, we'll take a graph and see how a line or a slope of a graph looks like, okay? Slope of a graph is being used everywhere. You might see this, okay? You might see this kind of questions where slope is being used, okay? Okay, Vidyasagar Yadav. Okay, your name is Harshita. Welcome to the session, Harshita. Please solve it for me, sir. I'm sorry. Before ending physics, please solve it for me. Yeah, of course. I will be solving it for you. Definitely, no need to worry. Okay, talking about slope, okay? A slope of a graph is nothing but steepness, all right? It's going to say how steepness graph is, okay? Slope is what? It's steepness, okay? Steepness of a given graph. If you see over here, if someone stands, if you kind of stand over here, are you going to fall? You can somehow manage and get your grip, right? But imagine you're going to stand over here, right? What's going to happen? The chances of falling is more. So graph is steepness of any, slope is steepness, okay? So if we say the steepness is more, the slope is more. If you say the steepness is less, the slope is less. I hope you understood, right? This is about slope. Slope is just steepness of a graph, how the steepness is. And now it has come time for us to understand the graphs, equations of motion, okay? Talking about velocity time graphs. See, whenever you've got a graph with two different names, velocity and time, the first thing you'll be taken in y-axis, the second thing you'll be taken in x-axis. So shall we take velocity versus time graph? Are you all excited? See, the first chapter is a bit of theory, I know, I understand. As we move on, the theory reduces, lots of concept increases. You will be super enjoying about such an interactive session where you will be talking with me. So stay tuned. You have to just wait for a while so that the session becomes super engaging. The first chapter, I know, it's like theory, right? So what happens? You'll be like, sir, the same thing, motion is difficult, you say. So I'm here to make it easy, okay? So what have they say? What kind of graph is this? We've got velocity and we've got time, right? So velocity time graph, sir, as you said, let's gonna take velocity in y-axis and time in x-axis, okay? Time in x-axis. Sir, sure. And you said we've got a graph, right? This is like a graph looks like. So how can we actually find the slope of it? Slope of any graph is given by slope is equal to change in y-axis. Change is more like final minus initial, right? Similarly, change in x-axis, right? So change in x-axis. If they say, so compared to last year, what's your weight? Okay, how much have you reduced or gained? So you'll say, so this year, final year, so finally second year, I'm this much weight, minus initial year, I was that much weight. So difference of that will be giving you change, right? So y2 minus y1 divided by x2 minus x1. So you can see this is the point y1 and this is the point, let's say this is y2, right? So what is this? This is y2 and this is x1 and this is our x2. Okay, so let's see what is y1. Y1 is like velocity, right? So we have velocity 2 over here. This is initial velocity. Time x1 is 0 seconds. Time x2 is t seconds. Okay, you all know this, I hope, right? Now here y2 is what? v2. minus, what is y1? U, right? Divided by x2 is t divided by 0, t minus 0. So what slope? Slope is given by v minus u divided by t. V minus u is what? Final velocity minus initial velocity. Velocity minus velocity, you get velocity itself. What is velocity by time? If you remember, I just told velocity divided by time is our acceleration, right? So if you find a slope of velocity versus time graph, that will be giving you acceleration. Clear? I hope this is clear for you. So whenever you kind of take the slope of velocity versus time, what are you going to get? You are going to get the acceleration. So velocity divided by time is what? Acceleration. Okay, so slope of velocity versus time graph, what does that give you? This gives you acceleration. Clear? So what's acceleration, sir? It's like measure of speed, how fast an object is moving or how slow it's moving. If you're going with such a high acceleration, you'll reach the position fast. If you're going with very small acceleration, you're going to reach the your speed will be less, you're going to reach the position late. Okay, so this is about slope of velocity versus time graph. Do you all want me to explain the equations of motion? Are you all excited to know about the equations of motion? Yes or no? You can tell me in the live chat. Okay. No, I don't want that to be happening. Dhananjay, please, I appreciate your thing to increase that, but that should not happen in my class. Bot attacks, never, not allowed. Okay. Sir, you have considered one time t and one time is 0. Yes, my dear, because so what is happening is that it starts from 0, right? Okay, no problem, Dhananjay. I am very happy that you are knowing what's currently happening. Okay, look here, Ghosh. So time is 0 here. So as the time increases, it goes, right? It attains some velocity. We don't know what's that time, okay? So we are just taking the unknown variable terms. Got it? So this is how it is. So slope of velocity versus time graph will be giving us acceleration. Do you all want me to help you understand first equation of motion in an easy way? If yes, you can tell me. If no, well, you have got this. See, in the next step, slope is what? Acceleration, right? So in the next part, what happens is slope, I'm going to write A is equal to V minus U divided by T. So if you simplify this, you get AT is equal to V minus U. By rearranging this, V is equal to U plus AT. This is itself your first equation of motion. See, before even you know that we were doing this, we just derived the first equation of motion. So simple, right? You'll consider a graph where the graph will be between velocity and time, and take a slope of it. As simple as that, you've got your first equation of motion. Let me highlight this so you can later write it down in your notes. Okay, so this is our first equation of motion. Got it? First equation of motion. Sir, sure. First equation of motion you helped us so easily. What about second and third equation of motion? Well, we are going to use the same graph for second and third equation of motion. Sir, I know how to derive equation of motion. Great, great. Okay. Now, talking about equations of motion, second equation of motion we're gonna consider. Initially, let's say it starts with time is equal to 0. Initial velocity we can take u. Finally, it reaches certain velocity, we can take v. It starts with time t is equal to 0 and it stops its journey when time t is equal to t1, or you can just take t. Clear? I hope this is clear for you. Now talking about how to start the derivation. Okay, now if you see, we can break this into two shapes, right? One, you've got a rectangle and you've got a triangle. Can you see rectangle and triangle? Yes sir, absolutely, we can see a rectangle and we can also see the triangle. Now if you take the area of that, so how to take the area of that, sir? Well, area is equal to area under this slope, okay, area under this graph. What's gonna give you? See, look carefully. Okay, we've got one rectangle, one triangle, so it's like area of rectangle plus area of triangle, right sir? Absolutely great. So what do we have in y-axis? We have velocity. What do we have in x-axis? We have time. So if you want to find the area, it's like length into breadth, right? That's what is going to give you area, right? So area is length into breadth. Okay, in length what do we have? We've got time over here, right? Length, it's time. In breadth what do we have? Breadth, we have u, it's velocity. So it's velocity. How can you write velocity? Velocity is displacement divided by time. So time gets cancelled. So area under the graph will be giving you what? Area under the graph will be giving you the displacement. Okay, that's why we say area under the slope will be giving you the displacement. Got it? Okay. Now area of triangle is given by breadth into length or length into breadth. U into T I'm going to write, plus area of triangle is what? Half into base into height. Okay. So firstly we need to find the area of triangle and the area of rectangle. Absolutely great. Yeah, we can do that. So half. What's the base of triangle? This is the base of triangle, right? The base of triangle is how much? T. Half into T into what's the height of triangle? Height is, total height is V. Minus, you remove that because we only want this much. So total is V minus this height, that will be giving us V minus U. Clear? That's the height of the triangle. Okay. Don't erase. I'm writing. Okay, I won't be erasing from now on because you might be requiring. See, total length is V, but triangle is only this much. You remove U part, so you'll be getting V minus U to be the height of the triangle. Okay. So height of triangle is total is V minus U will be giving you the height of triangle. So let's simplify. Area, I told, area under the displacement velocity versus time graph will be giving you the displacement, right? So S is the word or a letter which we kind of use it for displacement. Okay. Sir, please dt into t, then cancelling, show that. Okay, I will show you. I will show it to you. Okay, see what happens is that area of rectangle. Okay, rectangle area. What happens is we've got length into breadth. Length is what? T, right? We have T over here. Breadth, we have got velocity. Velocity can be written as displacement by time. So this gets cancelled. So we say area of rectangle. Okay, area of velocity versus time graph will be given. What is D? D is displacement. Okay, displacement. This is what I wrote. Okay, understood, Ghosh? So this is what I said. Area under velocity versus time graph will be giving you the displacement. I hope this is clear. Okay. Now U into T is what? Ut plus half T into V. It's like okay. Before that we have got, you know, T into, I'll write V minus U. Do you remember first equation of motion? First equation of motion says V is equal to U plus AT, right? So what does that say? So we've got from first equation of motion. Shall I just make a copy of it? Next step, we'll go to the next step of it. Okay, so going to the next step. Okay, we've got this much, but still we've got something else to do, right? So what do we have? We have S is equal to ut plus half T into V minus U. T into V minus U. Let's take this as equation number 1. Okay, sir, what shall we do now? If you remember first equation of motion, V is equal to U plus AT, right? This is from what? This is from first equation of motion. You can write V minus U to be what? AT. See, you have V minus U over here, V minus U over here. Can you put AT wherever you have V minus U? Can you put it? Definitely, sir. Why can't we put? Let's do that. Okay. So let's put V minus U is equal to AT. S is equal to UT plus half T into wherever we have V minus U, we can put AT. How? From the first equation of motion. Got it? So into AT. So if you simplify, you will get S is equal to UT plus half A. T into T is what, my dear student? T square. This is your second equation of motion, done super quick with only, okay, with only small such a small derivation. Okay, now in the exam if they ask you, you'll be writing S is displacement, U is initial velocity, T is time, A is acceleration. Do this, you got full marks, complete marks. Great. I remember Vidyasagar Yadav, it's like Harshita Yadav, right? Hi there. So you're right, absolutely great Harshita. I remember that. Okay. So shall I highlight this? What's this? Second equation of motion. Second equation of motion is given by S is equal to ut plus what, my dear students? Half at square. This is our second equation of motion. Second equation of motion. So if they give in your exams, you'll be able to do it. Hi Garima, welcome to the session. Hello there, how are you? Alright, going to the third equation of motion. Sir, is the third equation of motion difficult? Or shall we be able to do it in the same easy way how you taught us the second equation before? Well, the same way, but we are going to kind of reconsider the shape of the area under the graph, okay? Hi Mohit, hi there, welcome to the session. Okay, as I said, area under velocity versus time graph will be giving you S. That's what? That's displacement. Okay, that's displacement. How is that, sir? Well, I just explained in over here. Okay, I explained over here how area under velocity versus time graph gives. Okay. Gore says fourth equation of motion. Well, fourth equation of motion, you have to give it. Just we've got like 3 now, and this has given only 3. All right, let's go to the third equation of motion. Now, if you can see this triangle also looks like a trapezium, right? We can just rename it A, B, C, D. Okay, so we have got A, we've got B, we have got C, we've got D. Can you see this? This looks like a trapezium, right? So we've got two parallel sides and 2 non-parallel sides. You already derived it. Absolutely great. Those who already derived it along with me, before me, hats off to you, super quick. All right. Now, what did I say? Initial velocity can be taken as what? Initial velocity is taken as u, right? So u is your initial velocity, and by the time it reaches here, it ends. This is final velocity. It starts when t is equal to 0 and it ends with t is equal to time t. Clear? Sorry sir, third equation difficult. No gosh, never. After this you see how easy third equation of motion is. See, keep watching. You will say it in live chat that so third equation of motion became super easy. Now you will say wait and watch. Okay. Now let me make a copy of it. Okay. Let me make a copy of it. Okay, now this is what we did. Okay, we did the basic thing, constructions. Okay, like or naming the graph, u, v and all. Okay, now if you see area, just give me a moment. Okay, area under trapezium. Okay, here we're going to find area under trapezium. Area under what kind of shape is this? That's a trapezium, right? Area under a trapezium. Well, maybe I think you would be, sir, I did not understand third equation of motion. I'm explaining, Dhananjay. Look, I'm explaining. See, what we do is that we're going to take the same graph, okay? Listen carefully. Same graph is there. Velocity graph is there. Time graph is there. And we're going to draw a slope. This slope is there, which gives that, okay? Okay. So, initial velocity, final velocity. This is what I did. That's all. For now, I'm explaining, Dhananjay, okay? Yeah, right. Yadav says rightly. First, we need to take the area of trapezium. Yeah, let's see, okay? Now, area of trapezium formula is half into sum of parallel sides, okay? Sum of parallel sides into height. This is what is our formula for area under trapezium, okay? So, parallel means what? It's like railway tracks. This goes like this. This never meets because it's like railway tracks parallel to each other. They never meet, right? So, in this case, one side is u, okay? This is the length of one parallel side. This is the length of another parallel side. Shall we write it down in the formula and derive the third equation of motion? Yes, sir. Okay, area under trapezium, I said it gives you what? Displacement, okay? Displacement, okay? Displacement is equal to half into sum of parallel sides. One parallel side is u, another parallel side is v. U plus v. What's the height? Which shall we take it as height? The height is this part over here, okay? That's t. Here half into u plus v into t, and we've got what? Displacement is s. So this much we have got, sir. Now what shall we do? Do we have, or shall we use the first equation of motion as well? Definitely, you got me right, okay? So we can use the second equation of motion. So what did we get? S is equal to half v plus u into t, right? Now from first equation of motion, V is equal to U plus AT. What's going to happen? Rearrange it. V minus U is equal to AT, right? So that's what we have, okay? V minus U is equal to A into T. Or T can be written as V minus U divided by A is equal to T, right? So you can see one T here. We have got one more T here. Shall we put it over here? Yes, why not? We can put it over here. We can substitute absolutely, okay? So in this case, what happens? So S is equal to half V plus U into what is T? V minus U divided by A. This is S, right? So going to the next part. Quickly, I'm going to solve over here. The next part is, you can 2A into S, you can write it as 2AS, right? Because it's multiplication. V plus U into V minus U, A plus B into A minus B, A square minus B square, right? So 2AS is equal to V square minus U square. So V square minus U square is equal to 2AS. This is what? Third equation of motion. Now tell me whether it's clear or not. Now I hope this won't be difficult anymore. So what's this? This is our third equation of motion. I hope this is clear for everyone. Is it clear, my dear students? What is this? Third equation of motion, okay? So this is your third, okay, equation of motion. Got it? I hope this is clear. Is it clear? Wow, thanks a lot. I'm super satisfied. I'm super, calm down. Dhananjay says thanks. Yeah, I'm super happy that you understood. Okay, so first, second, third equation of motion. First equation of motion, see what you do. You're going to just take the slope of it, okay? You're going to take the slope of it. Take a slope. Slope is y2 minus y1. So v minus u divided by t. You got it. V is equal to u plus at. The first equation of motion. What's the second equation of motion? Sir, second equation of motion is super easy, sir. You just take the area of velocity versus time graph. You've got one rectangle, one triangle, just take the area of those. You'll be getting S is equal to ut plus half at square. That's our second equation of motion. Okay, sir. What's third equation of motion? Well, third equation of motion, we are going to consider the shape as trapezium, not triangle and rectangle anymore. In third equation of motion, what are we going to consider? We are going to consider this as to be a trapezium. And what's the area of trapezium? Half into sum of parallel sides into height. So after doing that, what did we get, sir? We got v square minus u square is equal to 2as. Clear? I hope this is clear. Okay. Sir, can we have 2 minutes for water break? Yes, of course you can have. Thank you for your nice explanation. Well, welcome. Your energy is resonating here. Okay, you'll be getting just 2 minutes break for, it's been almost 1 hour since the session started. We've got like, okay, I'll give you 5 minutes break, okay? I'll be back soon. You also can have a water break. You can also kind of try to make a note of it, okay? Let me just give you a 5 minutes timer so that you all can go have a water break, okay? I've started the timer. You can just go have a small water break and then we will be back soon, okay? So it is running. I'll be back soon. So guys, I'm back, but still you've got like some more break. So in the meantime, just go ahead, take a water break, or you can also take a small break and be back, and we'll be starting soon. Okay. Just give me a thumbs up whether if my audio is audible, and of course I'm visible, right? So Dhananjay, can you tell me if I'm audible? Say yes sir, or give me a thumbs up, so that what will be happening, I will be able to proceed it pretty soon. Okay. Just tell me, just give me a thumbs up if I'm audible to you. Okay, great, great, great. Okay, let the timer ends and we'll be starting. Sure. Okay, so I hope it's all clear, right? You are not having any difficulty understanding this. Okay, 2 more minutes we have. See, from 1 hour, I know you have been watching this session continuously. You also might also have to get a small water break. Okay, from here, all the difficult equations, theory, everything is got over. Now it will be like a story, okay? You might never have heard physics in this way, but this is going to happen in that way now. Okay. Sure then. Got just 1 minute, 29 seconds left. If you have, if you want me to just go to the previous slide, I will also go, because anyhow, timer is running. We've got 1 minute left. This is the graph which I gave. Okay, just make a note if you want. I'll be starting because once the timer ends. I'm Harshita. Okay, sorry, Harshita, right? Because whatever you type, it's the name coming it to be Vidyasagar Yadav. So right, I remember Harshita. Okay, will you explain uniform circular motion? Yes, definitely I will explain uniform circular motion. Okay, shall we? Okay, are you back? Everyone is back, I believe. Okay, shall we just stop it? Pause, reset, and going to the next part. Okay, now sir, how to solve numericals whenever we have been asked to solve the equation of motion? Do we have a trick? Can you tell us a small trick how to solve? Well, I'm here to help you out. Okay, here you've got three equations of motion, right? One is first, second, and third. Okay, you've got three equations of motion. One is like v is equal to u plus at. Okay, let me highlight this. First is v is equal to u plus at. Okay, now imagine, okay, s is not given, s is not given. Okay, s is not given, v is given, u is given, a is given. Okay, so let me write it on you. V is given, u is given, a is given. So t is question mark with equation of only one unknown. Okay, hi Harshita, welcome back. Okay, with equation of only one unknown, you can easily find it out, right? So what second equation of motion? Let's say you've got s is equal to ut plus half a t square. This is second equation of motion. This is first equation of motion. Okay, so what all terms you have? U, t, a, and s. Okay, we don't have v. When v is not given, you have to choose second equation of motion. Okay, when v is not available, use second equation of motion. Of course, only one unknown will be there, so choose such an equation where you'll be having one unknown. Okay, now third equation of motion, v square minus u square is equal to 2as, right? So here imagine t is not given. Okay, t is not given. If t is given, you can use first and second, because first equation of motion, second equation of motion, both we have got t. But in third equation of motion, we don't have t, so you will be using third equation of motion when t is not given. Okay, so u, v, a, and s. So that's how you're going to use. Okay, so first equation of motion you're going to use when s is not available. Okay, okay, s is not available, use first equation of motion. Second equation of motion, when v is not known, v is not known, you can use second equation of motion. Okay, v can't be found. Okay, if v is cannot be found, okay, v is not available, yeah, v is not available, you can use second equation of motion, not available. Okay, when you are not able to get T again, if T is not available, use third equation of motion. Okay, got it? Is it clear when to use first, second and third equation of motion? I hope this is clear. Okay, so and choose such a equation that you'll be only having one unknown. Okay, because if you have got two unknowns, let's say T is also T is unknown and A is unknown, can you use this? T don't know, A don't know, we cannot use this, we cannot use this. Choose an equation where you have only one unknown. Okay, great. Okay, choose the equation where you have only one unknown. Choose such equation where you have only one unknown, where you have only one unknown. Clear? Is it clear, my dear students? You have to kind of choose an equation where we have got only one unknown. Okay, yes sir, start numerical, give some numerical. Here you've got numerical. As soon as you ask Harshita, you've got a numerical. Okay, are you taking class? Yeah, absolutely right, you guessed it, you guessed my location. That's where I've been trying to take the class. Okay, Samarth, well, we've got you covered, no need to struggle, we've got everything. Okay, sir, solve some equations based on equation of motion. Yeah, that's what we're gonna go do. Okay, so first, a car starts from rest with uniform acceleration. Starts from rest means initial velocity would be 0 meter per second, so it would be starting from rest. Okay, now with a uniform acceleration, they have given you some acceleration. You can take acceleration that's given to be 3 meter per second square. Okay, it's not 3 meter per second, acceleration is 3 meter per second square. And what else have they given? Travels for 10 minutes. Time they've given 10 minutes. Okay, find the velocity after the end of 10 minutes. Which equation of motion shall we use? Choose equation with only one unknown, with only one unknown. Okay, shall we see, everyone? So do you want a poll for this? You want a poll for this? This is question number 1, right? So the poll would be, okay, I'll give you the poll. The poll is like this. Option A is 1900. This is what? Velocity, right? Meter per second. Option B 1800 meter per second. Option C 2000 meter per second. Option D, it's like 1000 meter per second. Okay, so I'm going to start a 120 seconds poll. Let's see how to solve this. Are you all ready? Are you all ready to solve this? See, I'm going to take the first equation of motion where V is equal to U plus AT. So U is given, A is given, time is given. What is unknown? V is unknown. So you have to choose such an equation of motion where you have only one unknown. So where do you have got only one unknown? One unknown is there in first equation of motion, right? So we shall be using that. V is equal to U is what? 0 plus A is what? A, right? 3, right? Okay, it's 3. What about time? 10 minutes. But minutes has to be taken in seconds, right? Because we are converting, right? So it's like you have to take everything in SI units, seconds. Okay, so 10 minutes have got how many seconds? 10 into 60, right? Because 1 minute has got 60 seconds. Like that, we have got 10 minutes. Okay, so 3 is our acceleration. V is equal to 3 times 60 is 180 into 10. So final velocity would be how much? 1800 meter per second. Those who all have given option B is the right answer. Okay, option B is the right answer. No one gave, it's fine, next time you can do that. 1 minute is equal to 60 seconds. Absolutely great. 10 minutes, 600 seconds. 60 into 100, 600 into acceleration 3 will be giving you. Very good, Ghosh. Right answer. Alright. So this is how you're supposed to do the numerical. Okay. Let's do one more. Shall we do one more numerical or shall we go to the next part? You want one numerical or the next part? Just give me a confirmation. Okay. If you want another numerical, we shall do that. Or if you want me to go to another slide, well, I will be going. That's in next chapter. Okay. Alright, going to another numerical where we have got uniform arrow from rest. Okay, rest means initial velocity is 0 meter per second. Gains a velocity of 25 meter per second. Final velocity is how much? 25 meter per second. In how long? This everything is happening in only 4 seconds. Okay, Dipanshu, I'm doing one more numerical. Okay, so time is सब कुछ होने के लिए it is taking only 4 seconds, right? 4 seconds. Find how far it has reached in 60 minutes. Consider the arrow has got uniform acceleration. See, we are supposed to find displacement. S is question mark, okay? Which formula shall we use? Well, we cannot use any formula because two things are unknown, okay? Acceleration, we don't know. Displacement, we don't know. So, shall we leave this numerical, sir? No, definitely. Sir has told take an equation with only one unknown. But we've got here two unknowns. Shall we leave it? See, I'll tell you how to do it. Okay. So first we can use first equation of motion to find the first unknown. Okay. So first unknown v is equal to u plus at. Final velocity is 25. Initial velocity is 0 plus acceleration is what you are supposed to find. Sab kuch hone ke liye it is taking 4 minutes, right? So a will be how much? 25 divided by 4 would be giving you how much, my dear students? Can you tell me what is 25 divided by 4? Okay. 25 divided by 4, acceleration you got 6.25 meter per second square. See, now you got acceleration. Can you use second or third equation of motion? Definitely, sir, we can use it. Do you want a pole for this? Okay, pole, yeah, pole. I'm giving you a pole over here. This is question number 3, right? So you've got A, okay, 4,500 meters. Option B, 3,500 meters. Option C, 10,500 meters. Option D, 9,0500 meters. We are supposed to find what? We are supposed to find how long it has gone. A, B, C, D. Okay. So you've got like 120 seconds again. Go ahead, quickly go ahead and give me your answer. I will be waiting for your answer and I will be proceeding with finding the displacement. Okay. Now, v square minus u square is equal to 2as, right? S is unknown, rest all have been given. So what I can do, of course, I can use third equation of motion. So v square, it's like 25 square minus u square is 0 square is equal to 2 into acceleration you got 6.25 times s. So can you get s? Yes, definitely we'll be getting s. 25 times 25, 625 divided by 2 divided by 6.25. Okay, so there might be some small, mistake with the options. Options are rechanged, okay? Options are rechanged. Time will be given. You still got time, okay? Option A, 50 meters. Option B, 60 meters. Option C, 70 meters. Option D, 80 meters. A, B, C or D. Go ahead and give me quickly A, B, C or D. You should be typing your answer in the live chat so that I will be able to see A, B, C or D. Go ahead, quickly give me your answer. So S will be how much? 25 times 25 divided by 2 into 6.25. Got it? So 2 into 6.25 will be giving you 12.5. So 25 divided into 25, how much, my dear students? 625 divided by 12.5 will be giving you how much? A, B, C or D, my dear students. So that's option. The timer, I'm going to end it quickly. Now is the time for you to grab your pole and tell me what is the right answer. I hope you all have understood how to do this, okay? So option A, 50 meters is the right answer, okay? 50 meters is the right answer. Alright, great. Going to the next part. Where have you stuck? Ghosh, can you tell me where have you stuck? See, you have to be quick because the poll timer also ends, okay? Now did you understand? Tell me if you have understood. Is it clear? B, you gave great. Ghosh, sir, I'm stuck, unable to solve 6.25 into 12. 6.25 into 12, my dear student, is 12.5, okay? Fine. I really appreciate your effort in doing that. Is it clear? I hope this is clear. Yes? Yes or no? Now tell me which chapter do you want me to start? Force and loss of motion, or work and energy, or you've got like gravitation or sound. Which one? Shall we start gravitation? Shall we start gravitation so that we can come back later for the other chapters, okay? Or shall we start equation of motion? Okay, or force and laws of motion. This is the second chapter. Hello there, we've got the boss. Hi there. Okay, sorry sir, I missed this question. What happened, Arshita? What happened? Why didn't you attend this question? What happened? Are you facing any difficulty? Is it clear? Thank you, Dhananjay. When you explain, everything is clear, sir. Well, it touched my heart, my dear. This is all possible because this energy is possible because of the energy what you are showing to me. It's just resonating with me here. Okay? Great, Dhananjay. I hope this is clear. Now, force and laws of motion. This is your second chapter. Okay? Second chapter. Well, what is this? I've got something for you, but you can relate. There is a question, okay? He asks, okay, why is it so easy to stay awake until 6 a.m. but so hard to wake at 6 a.m.? Can you repeat it? Can you relate it? Okay. See, let's say you are late night. You're playing, kind of games and all, and by the time you realize it's almost 6 a.m. the time went so fast and you were not able to know how it went. But for the same reason, if your mom asks you to wake up at 6 a.m., it would be difficult. It is so cold. I want to sleep 5 more minutes, mom, right? So that's what this says. Why is it so easy to stay awake till 6 a.m. but so difficult to wake up at 6 a.m.? Okay. Well, the thing is, she says things in motion tend to stay in motion, while things are at rest tend to stay at rest. What is this? This is according to Newton's first law, right? Newton's first law. Technically right. And look at his face, baffled. He never heard this Newton's first law before. Okay. Before ending the class of physics, please explain average speed of arrow. Okay. Yeah. Average speed is, see, here in the arrow what happens, it's like acceleration, not average speed. Okay. Speed they have given 0 meter per second initial speed, 25 meter per second final velocity. Okay. I hope you are all able to relate it, right? Whenever you are watching a movie, binging a movie, the night goes so quickly. Whenever you want to wake up at the morning, it would be like super cold. It's difficult, right? So yeah, I can also relate it. Okay. Going with what is force, okay? Well, force is a simple push or pull is what we're going to call it as force, okay? What is force? Force is a simple push or pull, okay? Simple push or pull is called as force, okay? Now we have got 3 equations of motion. Well, this is what the chapter is about, the equations of motion. Well, the first equation of motion, before you understand that, you should know what inertia is, okay? Inertia is what? Like first law is also called as inertia, law of inertia. Let's see. Have you ever just hit a carpet when it is beaten with a stick? What's going to happen? Dust comes out, right? Or you might have seen this, a coin kept on this mug. When you kind of flick this, the coin falls inside the cup. Why do you think this happens? This happens because of inertia, okay? Inertia is like, it's like a behavior of an object to change what it is doing. For example, you know what? Let's say you're watching a movie, okay? Your mom calls, it's time for your study. Come away, go and study. You don't want to do that, right? Okay? You would be like, mom, give me 5 more minutes. I want to keep doing the same thing. Or let's say you're doing an assignment. Your mom calls you for dinner and you'll be like, no, I don't want to have it now. Let me have it later. So you want to do what you're trying to do and you want to keep doing the same thing, right? So the same thing is happening. See, the coin is at rest over here, okay? When you flick it, the coin does not want to just go away. It is at rest. It wants to stay at rest. So it falls here. Similarly, the dust, what happens? Okay, so what happens? Here the coin is at rest. When you flick it, the coin does not want to go away, but it falls. So that's what is inertia, right? Ghosh says 50 meter per second of arrow. Numerical is correct, sir. Yeah, that's correct. That's correct. Okay, you've got like yeah, that's correct, my dear. Okay. So inertia is like resistance to change its state, okay? If it's in rest, it wants to stay in rest. If it is in motion, it wants to continue be in motion. What is happening for the case of dust is that, let's say you have a carpet, okay? Where we have dust on the carpet. when you hit the carpet, carpet goes away, goes back, but the dust, it does not want to go away. It is in rest, it wants to stay in rest, it will be wherever it is. So it appears dust is coming out of the carpet. Got it? Is it clear? I hope this is clear. This is what we call it as inertia of rest. So what's inertia of motion? Well, imagine you're going, okay, you're sitting in a bus, okay, and the driver applies brake so quickly, you'll go front, right? So you're going in a bus, driver applies the brake quickly, you feel the jerk. That's what it is. You wanna go, the body is moving, but the brake applies, but your body does not want to stop. Okay, so this is what we call inertia of motion. A body in motion continues to stay in motion. Okay, Dhananjay, great sir, I got wow, absolutely, because of our lectures. If that is helping you out, we are super grateful. All right, so inertia of motion is that whenever he's skating, okay, he sees a bump, what's going to happen? He's going to kind of fall, right? So you're just going. So this is what is inertia of motion. So because of bump, the skateboard stops, but you tend to go forward and fall in this case. So this is inertia of motion. Talking about inertia of direction. So what is happening? We have a bus over here and things are falling out of the bus. What is happening is, imagine you have a road like this, okay? You have a path like this, okay? And this is an end. Of course, we cannot go in this path. You have to make a right turn, okay? In this case, you might have observed, while going in a hilly stations, when you make a sharp right turn, what's going to happen? You will be thrown to the left, right? Whenever you make a sharp right turn, you will be thrown to the left. This is because of inertia of direction. So what is happening is, the car is going in this direction, okay? There is a change. This is the change, that is change in direction. But it does not want to accept the change. It wants to go in the same path how it was going. So this is the right path. This is the left, right? So if it makes a change to the right, okay, it tends to go to the left. Compared to this right, this path is a bit left, right? A bit left. So this is what we are going to call it as inertia of direction. Clear? So I was talking about average speed numerical. Please solve it at the end of the class. I will remember Ghosh and I will solve the numerical. Okay, fine. Did you understand the inertia of direction, inertia of rest, motion and direction? Once you have understood this, it's time for us to understand first law of motion. Because Newton's first law of motion, you will understand only when you understand inertia, right? Because it is talking about the nature of inertia itself, okay? Now comes the Newton's first law, okay? Newton's first law of motion says, it's a combination of inertia of rest, inertia of motion, inertia of direction. If you just combine everything, remember, recreate and write it, that's how you got it, first law of motion, okay? So remember, inertia of rest, okay? Sir taught inertia of rest with this example. Next, sir taught the inertia of motion with this example. And then sir taught inertia of direction with this example. So if we just combine everything and write, we got Newton's first law, as simple as that, okay? So how does that say? A body at rest or uniform motion will remain in the same state unless when? Unless, okay, an external unbalanced force is acted upon it, okay? So hi, Newton gamers, play hi there. So this, yeah, of course, we're talking about Newton's law itself and we've got a student or an audience with Newton's name. Such a coincidence. Okay, I hope this you understood. To write it in a different way, okay? Okay, the next way, you can also write it as an object in state of rest, or motion or continuous motion. What does that do? It continues to do so, all right? It continues to do so. When? Do so until an external unbalanced force is acting on it. Until someone disturbs it, it wants to do whatever it is doing. If it is moving, it wants to go. If it is at rest, it is at rest, okay? See, imagine I've got a bottle at it, okay, in my hand. Until I move, until I just push it out, it does not fall by itself, right? So this is what is going to happen, okay? Right. So do so. An object in the state of rest or motion continues to do so until an external unbalanced force is acting on it. Okay, until okay until an unbalanced force. Okay, unbalanced force is acting on it. Acting on it. Clear? I hope this is clear, my dear student. This is what? This is Newton's first law of motion. It's also called as law of inertia. Okay, remember this law is also called as what? Law of inertia. Why is it called as law of inertia? The reason is this is talking about inertia of rest, inertia of motion, and inertia of direction. That's why we're going to call it as inertia of rest. I mean, a law of inertia. Got it? Is it clear? I hope everyone you are understanding this. Okay, let's go to the next slide to understand Newton's second law. See, before you understand Newton's second law, there is something you should also know. What is that, sir? That's about momentum. Okay, momentum, you know what? Momentum, it's like measure of how the impact would be because of the speed of body and the mass of body. Okay, now talking about this thing. Okay, let's say you have a small ball with you. Okay, you have a small ball with you and your cousin throws at you a small sponge ball. Okay, the mass is so less. Okay, so what happens? You wouldn't feel that much pain. Now, so he sees that, so oh, my brother, he is not responding. Shall we try to kind of throw a big basketball at him, so that because he's calling you to play and you're not responding, you're kind of doing something. Okay, he throws a basketball at you. What's going to happen? You feel the impact, right? You feel the momentum, right? When he threw a sponge ball with the same speed, you did not feel that much impact. But when the ball was shifted to a basketball, you felt what? You felt it, right? So momentum is as simple as that. It's the measure of, it's the product of mass of a body times with what speed it's going. Okay, velocity. This is what we are going to call it as what? The momentum. Okay, is it clear, my dear student? This momentum, I hope this is clear for you all. Momentum is product of mass times velocity. Okay, so what does this say? What does momentum say? How the impact will be based on collision. How the impact will be after collision. Okay, will be after collision. Okay, if momentum is more, the impact is more. If momentum is less, the impact is less. Okay, I don't want to give dark examples, like imagine a kid just bumping at you. Kid is very small, he's got very less mass and his speed is less. Okay, so imagine a big athlete. Okay, you are in a marathon and you're just walking into the tracks unknowingly, and a marathon guy with so much power, so much speed hits you. What's gonna happen? It's kind of knocking out, right? So that's what momentum is. Momentum is all about how much impact will be after a collision. Okay, if mass is more, momentum is more. If velocity is more, momentum is more. So momentum is given by mass times velocity. Okay, and what's the unit of it? Mass, we know it's kg, and what's velocity? It's meter per second square. So SI unit of momentum would be kg meter per second square. As simple as this. As simple as this. This is what is our momentum is. Okay, once you know momentum, it's time for us to understand Newton's second law, because Newton's second law talks about rate of change of momentum itself. Okay, you might also expect some numericals on this. Okay, you might also expect some numericals or derivation in your exam. So stay focused and listen to how we are trying to say. Okay, so the net force acting on a body is equal to rate of change of momentum. Change, I told, change is final momentum divided minus initial momentum. Why, sir? See, last year you had some weight. Okay, let's say in 2025 you are like 30 kgs. Okay, in 2024 you were 28 kgs. Okay, what's change in kg? Change is final. This is final, right? This is initial, right? So 30 minus 28, you'll be doing 30 minus 28 would be getting 2 kg. Change is what? Final minus initial will be giving you change. That's what is change, okay? So the force acting on a body is equal to rate of change of momentum. Rate of change in momentum, okay? Change in momentum of a body. Okay, in this case, what's going to happen? Momentum is given by mass into velocity minus mass into initial velocity. Rate means change in with respect to time, okay? 2 kg. Very good, good. Absolutely great, okay? So, what is common? Mass is common, right? Because mass is same over here in this scenario. So, m into v minus u divided by t. This is what? We are talking about force. So, finally, force would be how much, my dear students? F is equal to m into what is v minus u by t. Remember first equation of motion. First equation of motion, v is equal to u plus at. So v minus u by t, v minus u divided by t will be giving you a, right? So F is equal to ma will be giving you the equation of second law, Newton's second law. This is the mathematical form of Newton's second law. Got it? Clear? I hope this is clear. If you have any doubt, you can easily ask me. Any doubts in Newton's second law? Hi Raj. Raj has joined. Okay. So this is mathematical form of what? Newton's second law. Newton's second law. Okay. Great, sir. Now shall we go to the next part, Newton's third law? What are the applications of Newton's second law of motion? Okay. Raj, yeah, this is for 9th standard. Absolutely great. This is for 9th standard. Okay. Thank you, Dhananjay. Okay. In your exams, if they ask you, please be ready. Okay. Any doubt you can ask me. Okay. Karan. Okay. Hi, Karan. Hello there. How are you? I hope you are doing great. Okay. Well, see what happens with the applications of Newton's second law of motion is that when, okay, imagine there's a car, we've got the seat belt, you have to apply brakes. Okay. So writing previous slide for 1 minute. Okay. See what happens is that, Raj, no, this is not for 10th, this is for 9th. You will be getting a notes, my dear student. Notes will be available on PW app. We'll be sharing it across all the social platforms. No need to worry. This is a marathon. The session will be running. So do not worry about notes. Notes you'll be getting for sure in our PW app, as well as where you'll be getting it in 1 second, just give me a moment. You'll be getting it in all the platforms. No need to worry regarding your notes, because notes will be, of course, obviously shared to you. It would be available. Do not worry much about the notes. Got it? Clear? Okay, so this is about second law. Application is that, see, when your momentum changes immediately, what's going to happen? When your momentum changes immediately, see, F is equal to mv minus mu divided by time. Okay, so let's say you have this momentum and it changes quickly. Okay, you have less momentum and the momentum changes immediately. The force would be more, right? So if the change in momentum is more, the force would be super high, because let's say you're driving, someone came in front of you, you apply the brakes. So without seat belt, your momentum was more because you're going with such a speed, and as you apply the brake, you might go and bump your head to something which is in there in front of you. So with that, so much pain, right? It happens, so much pain. But imagine everything is happening with certain time. Okay, with seat belt, of course, you won't go with certain height. The seat belt will be kind of slowing down your motion, and you will slowly go ahead. So it will reduce the momentum. So this is one of the application of Newton's second law. So the rate of change of momentum, the rate is happening at a slow rate, the force would be less. Okay, if time is more, the amount of force experienced by that body is less. Okay. No, Jake, that is not allowed. Jake is talking about what attack? No, that's not at all allowed in the class. Okay, going to the next part. Okay, third equation of motion. Well, you all know third equation of motion. You know this. What does third equation of motion says? Third equation of motion, you all know, for every action, there is equal and opposite reaction, and action and reaction would be acting on two different bodies, right? Usually you will be just writing this much, right? For every action, there is reaction force, and action is equal to reaction, because this is how it happens, okay? Class 10th class 10th exam will be there. Current 10th exam, class 10th, we will be going to see the sessions for sure, okay? Here, what does Newton's third law says? For every action, there is equal and opposite reaction. Equal and opposite reaction. And what's going to happen? Reaction. Action and reaction acts on two different bodies, okay? Action and reaction are on two different bodies, okay? Acts on two different bodies. This is what is the Newton's third law. Got it? If you're in class 10, my dear student, please do not worry. See, we have got this marathon for class 10 as well. So do not worry, this would be happening soon. Just keep exploring our channel, okay? So what are the applications of Newton's third law, sir? Well, what happens is, you're going to might see how the the recoil of gun happens. When the bullet goes in front, it is kind of applying a force in the backward direction. For every action, there is equal and opposite reaction. Imagine swimming, okay? What's going to happen? You're trying to push the water backward. How are you going to swim? This is how you're going to swim, right? So while swimming, what's going to happen? You're going to push the water backward, and the water is going to push you forward. So this is how the third equation of motion, Newton's third law works. Got it? Is it clear? Okay. PW app, yeah, it's working. It's totally working fine. Do not worry about the app, okay? So this is about Newton's first, second, and third law. Now comes gravitation. This is one such chapter where everyone were asking me to do it, okay? Gravitation we have, work and energy we have, sound we have, everything we will be doing in a comprehensive manner. So the things you have to remember mainly is regarding, okay, Newton's first law, second law, and third law, talking about inertia as well, okay? So this is what you'll remember. Inertia of rest, inertia of motion, all these things you remember, okay? Newton's first law is important, second law, third law, applications of that, okay? Great, okay? Now let's talk about gravitation. Gravitation is third chapter for us, okay? This is gravitation. This is our third chapter in 9th CBSE physics, okay? Now I've got something for you. Watch this. What's happening here? You all watch cartoons? Do you all watch cartoons? Well, I used to watch when I was a kid, just like you. Now what is happening over here? Okay? What is happening over here? We've got is this Looney Tunes? Like, I remember this character when I was a kid. Looney Tunes used to come. Okay, so what is happening? Okay, so this gravity works in cartoons only when you look down, right? Whenever you kind of look down, the cartoon characters are starting to fall. Before it does not look down, it doesn't fall, right? So gravity works, the first law of cartoons. What is that? So it's like gravity will not work until you look down. Right, that's there, okay? Current, hi sir, hi. How are you? Okay. Next comes over here. This guy is falling, okay? He's about to fall. And he knows the first law of cartoon. That's gravity does not work until you look down. So what's happening? He is not looking down and it's like he's floating. Well, this only happens in cartoon and not in real life, remember, okay? Sir, I am Raj. Hi there. My name is also Sri Raj. Okay. Break Zarur, of course, milega only after every 1 hour. Okay, it's 11:50. You're gonna get a break at 11:55. So stay tuned till there. Of course, you'll be given a small break so that you can go replenish, drink some water and all. Okay, going to the next part. So this was just for fun. Okay, in the exam, if they ask you, do not write. What's first law? Do not write. Okay. Hi there, so many new students are joining. Hi Tanu, how are you? Good morning, welcome to the class. Alright, great. So the first law works only in the cartoon. I mean, this first law of cartoons works only in the cartoon, not anywhere. It's like you wouldn't fall until you look down. Okay, now, but does that happen over here? So when you look at the apple falls, or else the apple would be floating. Okay, will that happen? Hello, Yuvraj. Get into the class. Welcome to the session. Okay, so imagine, just like in the cartoon, you're watching the apple is falling. You do not watch apple stucks, and then you watch the apple, it falls, and then you go there wherever the apple is, you look at it and catch. Does that happen? That does not happen, right? Because this thing, whatever we saw, this only happens in cartoons. Okay, this is only in cartoons. Okay, great. Now Newton was a scientist who also gave us the universal law of gravitation. He talked lots and lots about gravitation. Okay, so I'm getting so many requests over here. Manshar, Marvel, not now, definitely. You might one day see me dance as well. Well, let's focus here now. Okay. Now, there is something called as gravitation. Okay. Why does apple fall towards the ground and why does it does not go up? Why do you think? Okay. If that's the case, let's say Earth is attracting the apple. Okay. Earth is attracting the apple. Okay, attracting the apple. Okay, so earth attracts everything towards it, sure, but why not earth is attracting the moon? Why doesn't earth just grab the moon, and why moon is not falling on the earth? Okay, well, to answer all these questions, we have watched through the gravitation chapter. Stay tuned. The universal law of gravitation is going to talk about everything regarding how gravitation works, all the numericals, let it be the formula, everything. Okay, so let's get started. The one thing what you might expect in this chapter is universal law of gravitation. Okay, so how this universal law of gravitation works, what it is actually. Okay, so shall we go ahead and do the universal law of gravitation? Okay, so the universal law of gravitation says every object in the universe attracts every other object in the universe with certain force. Okay, let's say you're over here and your cousin is over there. Even though he is not kind of pulling you, what's gonna happen? It's like he is attracting you with some force. That's what is gravitational force. If anybody has got some mass, it's like it will be having gravitational force. Okay, so shall I write the universal law of gravitation? Those who wants to make a note of it can definitely go ahead and take a note of universal law of gravitation. Okay, what does that say? So universal law of gravitation says every object attracts every other object in the universe, every other object in the nature or universe, in universe with certain force, right? It attracts with certain force. What is that force? With a force directly proportional to product of their masses. Okay, directly proportional to the product of their masses. Okay, proportional to the product of their masses, and what's going to happen? Is it that much or is it inversely proportional to something else? It is inversely proportional to square of distance between them. Okay, and I'm going to write the next part in a different color. And inversely proportional to proportional to square of distance between them. Okay, square of distance between them, distance between them. Okay, so how do you understand universal law of gravitation? I will also write a mathematical form of it. Okay, so it says that every object attracts every other object in the universe with a force directly proportional to the product of their masses and inversely proportional to the square of distance between them. Okay, OP means, is it overpowered? You know what? I'm a Gen Z just like you. The tutor and the students are of the same generation, so there would be better bonding because I understand what you said. OP means overpowered, right? I do understand that. Okay, great. So this is what is first law, is it, sir? How can we write it in a what's the mathematical form of it? Well, the mathematical form, see, I'm not erasing, notes will be there. If you go back, you'll be getting the notes. Hello there, Saroj. Welcome to the class. Okay. What's the mathematical form of this? If they ask numericals on this, how am I supposed to do? What am I supposed to do? Okay. Adarsh Kumar, class and marathon, when it will be happening? Soon, my dear student, marathon will be happening. Just keep exploring the channel and you can see when this marathon would be happening for your 10th standard as well. Okay. Shall we see mathematical form of it? Okay. Mathematical form of universal law of gravitation. What does that say? Every object, okay, attracts every other object. Let's say we have an object, we have another object. Two objects attract each other, right? Okay. After square of distance, what did you write, sir? See, what did I write? Between them, it's not visible. Is it not visible? Between them, my dear. This is them, THEM, okay? Okay. Now, so force between two objects is directly proportional to what? Is directly proportional to force of attraction between two objects is directly proportional to product of their masses. If one object has got mass m1, if another object has got m2, yes, a chota sa break milega, just let me finish this. Okay, so F is directly proportional to m1 m2 divided by, let's say the distance between them is d, right? So it would be d square. So F is directly proportional to m1 m2 into d square, or you can write F is equal to m1 m2 by d square. Bring a proportionality constant, that is g mm by d square. Okay, so what is g? I'm going to tell you, is equal to g. Okay, well, g is universal gravitational constant. Yes, you're going to get a break, just wait. Okay, universal gravitational constant. This is our g. Value of g would be, my dear students, 6.67 into 10 raised to the power of minus 11. How to write the unit I will tell you, but for now I'll write for you Newton meter square per kg square. Okay, this is how a new universal law of gravitation works. So you will be given a timer, okay, a small timer, so that you can just go and have a loo break or water break, because you've been requesting me since long. 4 minutes is enough, I guess. Okay, you can quickly go and come. Got it? 4 minutes timer, we can quickly go and come. Quick. Okay, a small break, water break has been given. You can just go and come back quickly. Well, I will be here. If you have any doubts, I will be kind of helping you out. Let me turn on the timer. Come back quickly. A small water break has been given for you, so you can just take a water break and come back soon. Okay. Guys, if you have any doubt, you can, of course, just let me know, because I'm here to help you out. So any kind of doubt, please reach out, okay? Any doubts? We've got Anya as well. Please let me know if you have got any doubt, okay? So I know it's exam times. Well, marathon sessions, it's like, even though it's pretty long, it would be helping you a lot, okay? Because, well, these marathon sessions will be helping you out for to revise entirely, okay? Hi there, OP Rushi, welcome to the session. How are you? How are you doing? Had your lunch, guys? It's almost 12 o'clock, okay? We've got still some more time for the lunch, I guess, okay? Done. Shall I stop the timer? Are you back? Everyone, are you back? Shall we just go ahead and continue with gravitation? Is it done? Okay, great that everyone are back. Let's go and continue what we were studying, okay? Universal law of gravitation. Now, how can we get the unit of universal law of gravitation? What's the SI unit, sir? If you ask me, I'll show it to you, okay? I'll be using this formula. So, take your notes and, be ready by, writing down everything, okay? Whatever I say. See, F, this can also be written as I said, F is equal to G m1 m2 divided by d square. This I told you, right? So this I already told you. But how did you write the unit of universal law of gravitational constant, sir, if you ask me? See, keep G one side, rest all things other side. F into d square is equal to G into m1 m2, okay? So you can also write F d square divided by m1 m1 m2 is equal to G. This is universal law of gravitation. I mean universal gravitational constant. Now, how to write the units? Well, if you focus over here, SI unit of force is Newton. SI unit of distance or displacement, it's meters, Newton meter square divided by SI unit of mass, it's kg. SI unit of mass, again it is kg, right? Kg into kg what? Kg square. So this is how we got Newton meter square per kg square. Got it? Is it clear? Did I clear your doubts? So it's Newton meter square per kg square. This is the unit of SI unit of universal gravitational constant. Clear? Ghosh, is it clear? And if they ask you the value of it, you'll be writing it to be G is equal to 6.67 into 10 raised to the power of minus 11. How much? Newton meter square per kg square. Is it done? You need some more time to write it down, or you have already written and we can go to the next slide. Shall we go to the next slide? Okay, going to the next slide. We have first ever question. So this is a question, right? I'll be giving you poll first and then let's see how many of you will be able to answer, okay? So I'll be giving enough time for you. Options for the poll is option A, we're supposed to find force exerted. Option A is 3 into 10 power 20 newtons. Option B is 2 into 10 power 20 newtons. Option C is 4 into 10 power 20 newtons. Option D is 5 into 10 power 20 newtons. Is it clear? So these are all the things. Sir, when the session ends, physics part, my dear, is gonna end somewhere at 2 o'clock, and then biology starts, and then we've got chemistry. So This is like a big marathon. I know, like marathon, running in marathon requires lots of energy. So stay relaxed. You're at your houses. Stay relaxed. Write down wherever it's required, so that you will be having, kind of enough energy and focus on the subject. Okay. Right. Sure. Okay. Now we are supposed to find this poll. Let me start the poll of 120 seconds. Let's go ahead and try to answer this. Okay. The mass of the earth is 6 times 10 power 24 kg. What are they giving? They are giving you the mass of the earth. Okay. I'm going to write capital M is how much? 6 into 10 power 24 kgs. Okay, sir. And that of mass of moon, they are giving you the mass of moon as well. What's the mass of moon? A small m I'm going to write, that is 7.4 into 10 power 22 kg. Okay, guys, poll is running. You can give your answers as well. Okay, you can just type your answer in the live chat. Your name will be visible over here. Okay, now the distance between them is given to be 3.84 into 10 power 5 kilometers. Remember, they are giving in kilometers. But how are we supposed to take? We're supposed to take in meters. The reason is we are calculating everything in SI unit, keeping everything in SI unit. Clear? Is it clear? Okay. Now, how to convert it to meters, sir? See, you know that 1 kilometer has got 1000 meters. That can also be written as 10 power 3 meters. So this many kilometers, 3.8 into 10 power 5 kilometers have got how much? Direct proportional. You just multiply with 10 power 3. You would be getting, okay? Check. We have got a small mistake, not A. Check. A is ruled out. Small time left. Quick. Okay. Now, coming here, so we know that force is equal to product of their masses, square of distance between them, times G. Okay. Abdul, very good. Abdul gave the right answer. Let's see. Okay. Abdul Razak gave the right answer. Okay. Now let's see the answer over here. Okay. So how to solve? See, everything is important. F is equal to, what's the value of G? They've given, right? 6.7, or you can take 6.67 into 10 raised to the power of minus 11. Mass of first object, 6 into 10 power 24. Earth, 6 into 10 power 24 into, what is happening over here? Mass of moon is 7.4 into 10 power 22 divided by, whole divided by what, my dear students? Can you tell me? Whole divided by square of distance. The distance is given to be this much. In kilometers, how much? Okay, Pradeep, very good. B, option B. Adarsh also says option B. Hats off. But you should give before the poll has been stopped, or else your name won't be recorded. Okay. Now, divided by distance between them is, they are giving it to be 3.84 into 10 power 5 square. Not required. Calculator is not required, because all the powers you can easily kind of do it with the help of exponents, adding of exponents, subtracting of it. So calculator is not required. Okay. So at the last you will be getting somewhere around 2 into 10 power 20 Newton. So option B is the right answer. Let's see how many of them have given the right answer. Okay. Option B. Why didn't no one give the right answer? Option B. Got it? I hope this is clear. You won't be making this kind of mistake again in your final exam. Will you be doing this kind of mistake in final exam? No, please don't do it, okay? Because whenever you have got this precision with you, well, of course, it's fine. But the numbers between 2 and 3, the difference should be there, okay? Thank you, Dhananjay. Great, okay? Yes, going to the next part. This kind of numerical will be asked, okay? Now comes the part where we are going to talk about acceleration due to gravity. This will be used so many places. Numericals on this part will be using acceleration due to gravity. But sir, how to find this? How to find acceleration due to gravity? Can you teach us, sir? Sir, please teach us, sir. We want it. Well, of course, I'm here, okay? Now, understanding what acceleration is, you know that acceleration is nothing but talking about how speed is varying. Acceleration itself means what? Talking about how speed or velocity, how velocity or speed is varying. I'll explain, do not worry, okay? Varying. That means, see, in a vehicle, okay, got after class 10 when will class 10 marathon? Class 10 marathon, yeah, you will be getting it soon. After square of distance, what you have written, sir? Okay, fine. Those were the old comments. Okay, fine. So talking about here, so you know that acceleration is what? Acceleration is like you increase the acceleration of a bike, the speed increases. You reduce the acceleration of the bike, you are going to stop. So that's what is acceleration. Acceleration is going to just talk about how the speed or velocity of a body is changing. So in this case, when you throw something, see here, when you throw something, it comes back. When you throw anything on top of earth, it comes back, right? It's going way too high and comes back. Similarly, imagine dropping a watermelon from this height, okay, from here to floor. What happens? Watermelon might break into just 2 pieces. Imagine dropping the watermelon from 10th floor. So everything becomes pieces, right? Why is that happening? Because every moment its speed is increasing with certain acceleration, and that acceleration is what we call it as acceleration due to gravity. Gravity is pulling everything towards it with certain acceleration. If you have some acceleration, the speed will increase every second with that much amount of acceleration. That's what it is, okay? How to find acceleration due to gravity? Well, you know that F is equal to gm by r square or d square, okay? Okay, now see here, I'm going to take r square because we are taking the distance between the center of the earth and you, or the object, okay? The center of the earth and you, okay? Now, do you know what's the mass of the earth? Okay, see, acceleration due to gravity would be same for all the objects. You throw a paper, you throw a pen, or you just freely leave a rock. Everything has to follow the same speed. But due to air resistance, the paper might kind of fall slowly, and the pen falls super quickly. That's how it is. Okay, paper falls slowly, but the pen falls quickly. Okay, we can see this because of air resistance. But if I just drop both of this at the same time, without, without air, the paper will be and the pen will be, both will be traveling at the same speed. Got it? I hope this is clear, right? So now going to the next part. So F is equal to what? F is equal to m into a. How did we get F is equal to m into a? Sir, Newton's second law you just taught us. F is equal to ma. Okay. Now is equal to gm by r square. So mass gets cancelled. Any of the given body will be having same acceleration. That's what I said. Acceleration due to gravity would be same for any given object. Now a can be written as g. Why? G is acceleration and this acceleration is due to gravity, right? So a can be written as g over here, okay, is equal to, can you see what's the mass of the earth? They have given mass of the earth 6 into 10 power 24 kg. 6 into 10 power 24 kg into what's g? G they have not given, but you should know. G is 6.67 into 10 raised to the power of minus 11 Newton meter square per kg square. Why should you know this? Because this will be used in so many places. In all the numericals, even if they do not give you the value of g, you will be requiring to use that, okay? So use that into mass of the earth is done. Acceleration, universal gravitational constant 6.67 into 10 raised to the power of minus 11, okay, divided by radius of the earth has been given 6.4 into 10 power 4 meters, okay, 6.4 into 10 power, I guess 6, okay, it's 6, 10 power 6 square meters. This is not 4, this is 10 power 6, okay. Now if you do this, how much would you get? If you simplify everything, you will be getting somewhere the value to be somewhere around how much? The value is 9.8 meter per second square. What is this? Acceleration due to gravity on Earth. What do you mean by that? What do you mean by that? Acceleration due to gravity on Earth is 9.8 meter per second, means it's whenever you drop anything, it will be increasing the speed of the rate of falling of that body by 9.8 meters every second. Okay, this means a body falling on Earth, falling on Earth in gains a speed of how much? Speed of 9.8 meter per second every second. Acceleration का मतलब ही यही है. Okay, acceleration itself means this. Okay, that means for every second how much speed is increasing. If it's a negative, we call it as retardation. Well, here we've got positive. Acceleration due to gravity means what? Every second the body which is falling will be having a speed increase of 9.8 meters every second. Okay, so that's why when you drop it from here, it takes us 1 second to drop. Okay, let's say this is somewhere around 10 meters. Okay, 10 meters, it will take only 1 second. But if you drop it from very height, so the speed gains. A body increases the speed every moment. The speed will increase 9.8. If it is 2 seconds, 9.8. If it is like 10-story building, every second 9.8 increases. So momentum is so big. So momentum is big, impact is big. That's why watermelon breaks when you breaks into many infinite pieces when you drop it from very high. But when you drop it from such a low height, it does not break into many pieces, only it breaks into 2 pieces. Got it? So this is about acceleration due to gravity. Imagine without air, a rock, an apple, a big truck, everything will be falling at the same speed itself. Got it? Is it clear, my dear students? I hope this is clear for you all. Equations of motion for a freely falling body. What's happening here? What's happening here? A guy has been thrown into a swimming pool. Okay, do not worry, he's not gonna fall. We've got some swimming pool. It's like he has been to a water world where we've got water inside of it. Okay, now when the gravity says hello, can you see this? When the gravity says hello, what's gonna happen? Gravity is pushing him towards the center of the earth, right? I told every second for a body which is falling, the speed increases, right? See what happens? A body falling on earth gains speed of 9.8 meter per second every second. Okay, sir, when will we get long break? लॉन्ग ब्रेक मिलेगा at 1 o'clock. 1 o'clock एक 7 minutes का एक छोटा सा ब्रेक मिलेगा. मतलब कंपेयर टू प्रीवियस ब्रेक वो लॉन्ग है ना. Hello there, we have got ASSK Mysuru. Hi, welcome to the session. Alright, so this is what it is. Got it? Now talking about free fall. Free fall is that when the body is falling under the influence of gravity without any without any friction. Okay. Hi there, welcome to the session, Deepa. Alright, so free fall is like when a body is falling under the influence of gravity without any force. Alright, force acting on it. Okay, when a body is falling under the influence of gravity, under the influence of gravity without any other force acting on that. Okay, so this is about a free fall. What is going to happen? What are the equations of motion and how are we going to change that? Okay, hello, welcome back, Yadav. Welcome back to the class. Okay, so now let's see how we are going to use that. Sir, I missed the second chapter. Not to worry. The reason is okay. You can just go back and learn, but now I would suggest you to watch the live session. Once the live is done, you can just go back and see what all we have done. Okay, now when a body is falling under the influence of gravity itself towards the surface is what we call it as free fall. Sikandar, hats off to you, have given the right answer. Okay, great. Now talking about equations of motion, what are the equations of motion is You all know the three equations of motion, right? The first equation of motion is V is equal to U plus AT. Second equation of motion, S is equal to UT plus half AT square. Third equation of motion, S is equal to V square minus U square is equal to 2AS, right? V square minus U square is equal to 2AS. But what's the one thing you're going to know here? Wherever we've got acceleration, you're going to replace it with acceleration due to gravity. That's G. You know that, right? So let's do that. So equations of motion under gravity. V is equal to U plus GT. Another one. S is equal to UT plus half GT square plus V square minus U square is equal to 2GS. So this is what the equations of motion looks like whenever we are going to talk about equations of motion. But one thing, okay, well, you've got a question. Initial velocity U will be 0, sir. Yeah, whenever you are trying to hold an object and leave that, then the initial velocity will be 0. And whenever you're throwing up, what happens initially? The body is at rest, right? Only then we are going to take initial velocity 0. Not always initial velocity 0. When the body is starting from rest or it has been held, you can say, the velocity is 0. But if the initial velocity is not 0, they will be giving you in the exam. Do not make a mistake, okay? Now, sir, is the equation of motion same everywhere for an object going up, for an object going down? No. No. Why? See, whenever I throw a pen, it goes up and comes down. Before it will be coming down, it stops there for a moment. It's like it gone up, waited a moment and come back, right? So this is what is going to happen. So let's see what or how the equation of motion will be for different cases, when the body is going up or when the body is coming down. Yeah, Harshita, right. In the place of S, we put A. That's right. I mean, in the place of A, you put G, my dear. Okay. A will be replaced by G. That's acceleration due to gravity, where G will be always 9.8 meter per second square. Okay. Sir, is it the same thing for the objects going up or going down? Let's see. Okay. Shall we do it? Shall we do it, my dear students? Okay. Let me go and help you out. The equations of motion for a body which is going up and which is going down. See, while coming down, it picks up velocity because every moment its velocity keeps increasing by 9.8. But when you throw an object up, what happens? It goes slow down, reach a point, stay there for a while and come back, right? So, for an object which is moving towards the earth, acceleration due to gravity, you take positive. For an object which is going away the earth, you take acceleration due to gravity to be negative. Got it? So, shall I write it on the screen? Okay, I'll be helping you to understand when the acceleration due to gravity would be positive, when it would be negative. When the object is moving towards the earth, okay, moving towards the earth, what happens? The acceleration due to gravity would be positive. When the object is moving away the earth, what's going to happen? Acceleration due to gravity would be negative. Okay, so the acceleration due to gravity is negative when the object is moving away the earth. No, if the object is moving away the earth, okay, away the earth, what's going to happen? The acceleration due to gravity would be negative. Remember, okay, so V is equal to U minus GT. Wherever you have got plus, it's like deceleration, right? The acceleration, very good, Sikandar, negative. Hats off to you, very good, well said, okay? So similarly, S would be UT minus half GT square. Similarly, V square minus U square is equal to 2 minus G into S, okay? So this is what the equations of motion, whenever we are talking about equations of motion for a freely falling body under the influence of gravity, okay? I hope this is clear, right? Is this clear, my dear students? Do you have got any doubts? Any doubts, you can definitely ask me. If you do not have any doubt, we can just go to the next part, okay? Shall we go to the next part, my dear students? Okay, So this is about it, equations of motion. When the object is falling towards the earth, you're gonna take positive. When it is going away the earth, you're gonna take negative. Sir, wait sir, are you making a notes of it? Notes will be visible, my dear. No need to actually make notes of it. It would be definitely available, made available for you for sure, okay? Sir, please revise again. Okay, Harshita, listen. These are the equations of motion. You know these, right? So the equations of motion, you know this, okay? Where A becomes acceleration due to gravity because acceleration is because of gravity. Okay, sir, done, clear. When positive, when negative. See, when you're dropping something, every second its speed increases by 9.8 meter per second, right? So that's the acceleration is positive. Speed increase hoga, right? So similarly, when you throw something, it goes at a certain height. See, it's going and coming back. It's going and coming back. Why? Earth is pulling, right? So before coming back, it stops there, right? So it stops there and its speed reduces. That's why we are going to take negative. Is it done? Clear? Harshita, is it clear? Okay, Ghosh, I hope you have also written. So let's go to the next slide, okay? Those who are still writing, you can of course go ahead and make a note of it. Those who have doubts, please ask me. Those who do not have doubts, we can go to the next part. Okay, let's go to the next part, my dear students, okay? It's time for us to understand the difference between mass and weight. Well, 3 marks question might also be asked over here. What's mass and what's weight? Okay. See, very simple. Okay. Mass and weight, we have got, this is mass. I'm gonna write weight over here. Okay. Mass is amount of substance present in a substance, okay? Amount of matter present in a substance is called as mass, okay? Very good, Sikandar, right? Imagine you have a pen over here. You have a pen, right? Let's say we have got like 2 billions of atoms here. That's what makes the pen. Now take this digital pen to the moon, okay? Do you think the size of this reduces? Do you think the particles reduces? No, right? So mass is same everywhere. So mass is amount of matter in a body, okay? So how can we say mass? Amount of matter in a body. Amount of matter in a body, okay? But what is weight? Weight is influenced by gravity. That means if you're on Earth, let's say your mass is 30 kgs, okay? But acceleration due to gravity is 9.8. So your weight would be, let's take it as almost 10. 30 times 10 is 300 Newton. Why? Kg times kg meter per second square is what? Newton, right? See, weight is mass times acceleration due to gravity. Acceleration due to gravity, okay? Due to gravity. So what's the unit for weight, sir? Mass is kg. Mass is kg. Acceleration due to gravity is meter per second square. So what is this? Kg meter per second square. Where did you see kg meter per second square? Can you remember? Okay. We are talking about Satyam Singh. We are talking about gravitation, class 9 CBSE ka class chal raha hai. Okay. Okay, done. See, Newton's second law, what does that say? Newton's second law says F is equal to m into a, right? Or m into g or m into a. Mass is kg, a is meter per second square. So what is kg meter per second square? That's what is force, right? So that's weight. So it's kind of weight, okay? Weight or force is kg meter per second square. Since acceleration is a vector quantity, force is a vector quantity, we have got weight to be the vector quantity, okay? Yeah, so this is a vector quantity, got it? This is a vector quantity, okay? Now what about mass? Mass is a scalar quantity, okay? Sir, when the session will, after physics, okay, yeah, after physics there will be bio class. After bio you will be having, yeah, chemistry class. Hello Satyam, hi there, welcome to this session my dear. How are you? Okay, weight is expressed in Newton. Yeah, we're gonna see. Okay, no, it's like, yeah, force is Newton, right? Either kg meter or Newton. Okay, kg meter per second square or Newton. Well, mass is same everywhere. Okay, mass is same everywhere. Same or constant everywhere. It's constant everywhere. But what's going to happen for weight? Weight is influenced based on acceleration due to gravity. Okay, so based on acceleration due to gravity, the weight will end. Okay, see, Ghosh, since this is a marathon, of course it will be for a long time. No need to kind of get stressed about it, because of course we know no one can sit that long, but you can take frequent breaks. Frequent breaks will be given in the middle, so you can just go chill and relax and watch the lecture. When you make me your focus, what's going to happen? The things whatever we say get started inside your brain, so no need to worry. Okay, yeah, Sikandar. So it's a scalar quantity. Mass is a scalar quantity. This is a vector quantity, right? It's a scalar quantity. Got it? Is it clear? And one more thing I wanted to say. See, the weight depends upon the acceleration due to gravity. Okay. On Moon, your weight would be less. Okay. On Earth, your weight would be more. On Jupiter, acceleration due to gravity would be much more. Okay. Okay, nice explanation, sir. Thank you. Okay, Harshita, thanks for the compliments. Hats off to you. And thank you for watching the session as well. Okay, so weight depends on what? It depends upon the, can you tell me? Weight depends upon acceleration due to gravity of a certain planet or an object. Okay, depends on acceleration due to gravity. Acceleration due to gravity. Clear? Is it clear, my dear students? Shall we go ahead and proceed by learning many other concepts regarding your 9 CBSE? Great. Let's go to the next part. Okay, talking about pressure and thrust. Okay, pressure is like the measure of force acting upon a unit area. Okay, study with Aditya. Hello, how are you? Welcome to this session. I'm good. How are you doing? Hello, Sergi. Hello, student. Okay, so pressure is a measure of how much force is acting per unit area. Okay, it's like force divided by area. Okay, and force SI unit is given by Newton, area is square meters, right? Or you can write it as Newton per meter square or pascals. Okay, Pascal. This is the SI unit of pressure. Okay, so pressure is like force per unit area, that's Newton per meter square or pascals. And thrust is, you know what? Thrust is a perpendicular force acting on a surface. Okay. Okay, welcome to the class, Prathamesh. Welcome for you as well. Okay, so how are you doing? Great. Okay, so thrust, talking about thrust is what? A perpendicular force acting on a surface. Okay, thrust is perpendicular force, on an object acting on a body, on a surface, you can say. Okay, on a surface. Okay, on a surface. This is what, my dear students? Pressure and thrust. I hope this is clear. Is it clear, my dear students, what thrust is, what pressure is? So pressure is force acting per unit area. Thrust is the perpendicular force acting on a surface itself. Okay, this is about thrust and pressure. Now let's do a small numerical. So there will be a poll. Do you know how polls are supposed to be answered? Poll, how to answer? Do you know how to answer poll questions? Very good. Okay, A, B, C, D questions will be given. I mean, options will be given. You will be just telling me the answer in the A, B, or C, or D. Okay, I'll be giving you the options. Option B to be 2000 pascals. Option C 3500. Option D 9,000. Okay. So the question, okay, I'll start the timer. The timer would be for 150 seconds so that I can explain. You'll be having enough buffer time to answer. Okay. Yes. Now the question is, a nail is hit with a hammer. The cross-sectional area of the head of the nail is 0.04 square meters. The force applied by the hammer is 80 newtons. Find the thrust and pressure in this case. Okay. Guys, check. Do not randomly give the answer. Do not randomly give the answer. You've got time. Prathamesh, check. Okay. See, they have given that the area of cross section of nail. Okay. Nail's area of cross section. Okay. Area of cross section to be 0.04 square meters. Well, this is an SI unit. No need to kind of, convert it. Okay. I want everyone to give the options. I want everyone to give your right answer. Sikandar, just check once more. You've got time. See, time is running. Okay. Let's see. The force applied is, okay, the force applied is 80 Newton. We are supposed to find thrust and pressure. Pressure, you just talk about pressure. Thrust, I'll tell you what thrust is. Okay. Harshita, check once. Is it C? No, not C. C. C is not the right answer. I told A is not right answer, C is not right answer. Only 2 is left. Now you cannot guess. You have to give me the right answer. Okay. We know that thrust is what? Thrust is perpendicular force. Thrust is what? Perpendicular force. See, whenever you hit a nail, you're going to hit it perpendicularly. No, do not say B or D. One option is required so that you can see your leaderboard. Great. You can see your leaderboard and you can flaunt it in your circle. I'll show your leaderboard what you are doing. Okay. Now, so what's the perpendicular force here? The thrust itself, right? 80 Newton. So thrust is 80 Newton. We got it. So what about pressure? Pressure, sir, you told me pressure is equal to force by area, right? So pressure is equal to force by area. So force is 80 divided by area is 0.04 square meters. That would be giving you how much? Shall I stop the poll? Is it done giving the answers? Option B is the right answer. Okay, I'm going to stop the poll. Option B. Guys, see, you have to give me the right answer. Okay, so because you can just flaunt it in your leaderboard, yeah. Okay, so you would be getting 2000 Newton per meter square. Okay, Newton per meter square or pascals. Okay, is it done? Clear? See, do not guess because in numericals you might have chances of losing marks. I don't want anyone to lose marks because you know what, that is going to improve how you might score in your final exams. So do not make these silly small mistakes. Okay, clear, my dear students? Any doubt? Do you have any doubt in this numerical? If you have doubt, you can let me know. If you do not have doubt, Vishal, please divide 80 by 0.04. Okay, go see how to do such numericals. See, 80 is there, 0.04 is there. Okay, now what I do is that multiply and divide by 100. If I do that, will I make any changes? Everything would be same, right? I'm teaching you. Okay, sir, I have not a pen to copy, so sorry. No problem, Harshita, because the reason is this is a live session which will be recorded. Very good, Sikandar. Very good. Okay, so 8 into 100 will be 8000. 0.04 into 100 would be 4. 4 times 1, 4 times 2 would be giving you 2000. That's all. Did you understand, Ghosh? Is it clear? I hope you are able to understand what we are doing here. Is it clear now? Yeah? Yes. Let's go to the next part. Okay, this is how you do the numerical without having a calculator. Just try to find small tricks where you would be easily able to divide stuff without having the difficulty into get into the decimal part. Sir, clear like Bisleri. Thank you, Arshita. Thank you, Sikandar. Thank you very much. Okay. Now going to the next part, my dear students, we are going to talk about pressure in fluids. You know, pressure will be there in fluids. You know, you might have seen scuba diving or, okay, or it's like you might have went inside the water pool. What happens? Water molecules are stacking upon each and every other water molecules, right? So as you go down and down and down, what's gonna happen? You might see the pressure increase. Okay. Sir, have you met Alex, sir? Well, I'm just waiting to meet sir. He is such a motivational personality and such highly knowledgeable person. I really admire him. I wish I could meet him one day. Well, definitely I'll meet him. Such an inspiration. Okay, right. So what's going to happen is pressure in fluids. So in pressure in fluids, what's going to happen is, well, of course, the water molecules will be over here, right? On top of this, we'll be having some more water molecules. On top of that as well, and on top of that as well. In this case, what happens as you go deeper and deeper and deeper, what's going to happen? We are going to get more and more molecules on top of that. The weight increases, the pressure is more. Okay, so this is what we say. So as we go deeper in fluids, all right, not only in liquids, in any fluids, we would be having higher pressure. Okay, I wish, Sikandar, I wish that happens. Okay. Okay, now, so acts equally in all direction. The pressure in fluids acts in all direction and the pressure increases with depth. Got it? So the pressure increases with depth and the pressure will be acting equally in all the directions. This is about pressure in fluids. Okay, now talking about the next part, this is buoyancy. You know what buoyancy is? How to spell this? Okay, this is like B-U-O-Y-A-N-C-Y, buoyancy. Buoyancy is the upward thrust experienced by a body which is kept in fluids. Okay, now it's like see, I use the word thrust over here. Up thrust in the sense, let's say this scuba diver is there, right? So now when he is kind of floating in the water, what might happen? There would be a force, upward force acting on him. This upward force is what we're going to call it as up thrust. Okay, so the up thrust, the upward force experienced by an object when immersed in a liquid is known as up thrust or also called as buoyancy. Okay, so the upward force experienced by an object that is immersed in a liquid is known as either up thrust or it is also known as buoyancy. That's how you spell. Sikandar, right? Buoyancy, correct. Okay, but the spelling is like B-U-O-Y-A-N-C. Okay, it's not like buoyancy, don't say that. Okay, buoyancy, right? And the magnitude of the buoyant force, well, it depends upon many things. Okay, the magnitude depends upon nature of fluid. Okay, nature of fluid, or it also depends upon nature of object. Okay, nature of object, nature of fluid, nature of object, shape of object in that matter. Okay, shape of an object, shape of an object. So these are all the factors the buoyancy depends upon. Got it? Is it clear? I hope this is clear. This is about buoyancy, the upthrust experienced by the body. Okay, now let's talk about how an object might float or sink when submerged in a fluid. Okay, now imagine you're gonna put a rock inside a glass of water. Okay, what might happen? The rock will be just submerging inside the water. Why is this happening? Because the rock is more denser than the water, right? But in that case, what if you put a plastic ball, inside a cup of water? The plastic ball will be floating. Why? The density of plastic ball is less compared to the density of water. What about if you put a water ball inside the water? It's going to float somewhere, right? So that's how the buoyancy works. That's how the density works. Sir, when will you start Archimedes principle? Right after this, we've got Archimedes principle. Just wait and watch, Harshita. Okay. Now, when the density of a body is less than that of a fluid or water, it floats in water. When the density of a body is equal to the density of a fluid, it gets submerged. It is like kind of in the middle. Okay. When the density of a body, density, of course, density depends on mass and volume, right? If you have more mass in a small volume, we say the body is more denser. Correct, Sikandar. And if the body is having more mass, more density in less volume, so it is having denser body and it sinks inside. Got it? Is it clear, my dear students? So this is about buoyancy. Let's talk about Archimedes principle. Okay. Now Archimedes principle talks about how much is this buoyant force. The upthrust is there, right? How much is that? It talks about that. How much is upthrust? How much is upthrust? Upthrust acting on a body. Well, the amount of upthrust acting on a body, that's what? A buoyancy, right? Buoyant force is equal to, let's say you're going to fill the water till the neck of a vessel, and you put a 5 kg of, here we are putting 5 kg of something inside the water. So it displaces water, right? The water will come out because the volume increases. Now the amount of buoyant force or the upthrust acting on the body is equal to weight of fluid displaced. Okay, weight of fluid displaced. Okay, so this is what we are going to call it as what? The Archimedes principle. Is it clear? I hope everyone understood. Okay, all right. So you should have such a high energy Josh, because you should not have such a low Josh, because of course how's the Josh? Josh should be high. This is the time of exam. You were preparing for this day and the day has come. All your efforts can be used and showcase your skills, how you must put your efforts throughout the year in the exams. So do not be low, have high. Okay, Josh meter pole, well, I'll give you, sure. Okay, next. So buoyant force is weight of fluid displaced. Okay, how much ever fluid is displaced, if you kind of get the weight of it, so mass into acceleration due to gravity, you will be getting the buoyant force acting on a body. Okay, so 2 last chapters are there. That's like we have got sound and work and energy. Let's do that super quick, and physics part will be done. You will be expecting chemistry and bio class to happen soon. So without any further ado, let's get going. Okay, now one more thing they might ask you is Pascal's law. Okay, Pascal's law. What happens is that when you apply some force in a fluid, that force gets equally and undiminished,ly spread across the fluid. That's what is. Okay, now when it says that when pressure, okay, the pressure in a liquid, the pressure applied on a liquid, the pressure applied to a liquid, the pressure applied to a liquid, transforms, okay, transforms throughout the liquid undiminished,ly in all directions. Okay, the pressure applied to a liquid transforms equally and undiminished,ly in all directions. Equally and undiminished in all directions. Okay, in all directions. This is what is our Pascal's law says. Well, the application is hydraulic lift. That means if you just apply some force over here, the force is enlarged. How? See, you're going to apply some F1 force over here. Okay, force is F1 and area of cross section is A. What is pressure? Pressure is F by A, so pressure over here is F by B, but area is twice that of A, right? So if A is here, it is twice of that of A. Okay, so P1, so what did I say? The pressure applied, so P1 should be equal to P2. That means, so the force at 2, P1 is what? F1 by A1 is equal to P2 is F2 by A2. So in this case, you'll be getting F2 to be F1 times A, right? F1 by A1 is P1. F1 by A1 into A2. A2 is bigger. So force at this part will be pressure of P1 part times A2. So it would be more. This is what Pascal's law says. Hello Srishti, hi there, welcome to the session once again. Okay, say I give you a shout out. 5 minutes break, come back quick. 2 more chapters are left. These chapters to be done in such an interesting way. 5 minutes break will be given, my dear students. So be ready and come back. Okay, I'll be giving you a 5 minutes break now. Okay, 5 minutes break has been started. So be back quickly, okay? Let's meet at 1. No, let's meet at 12:55, my dear. Work and energy, yeah, as soon as the timer ends, the next chapter what we have is work and energy. All right. Soon. Next chapter is work and energy. Guys, shall we start, or you've got like 1 more minute? We've got 1 more minute left, so come back soon. Hi Athar, how are you? How are you doing? Welcome to the session. Okay, I hope everyone are back. So let's start with work and energy. Work and energy is the first thing what you're going to learn about work and energy is, technically you might think you're working hard, but not so much, because according to science, work is when you apply the force. Okay, according to science, what happens is work is when you apply the force. Okay, we say work is done when you apply a force. Okay, and that force is going to cause the object move. Okay, hello Daksh, hi. Sikandar, yeah, you can have, but eat something healthy. No, I can chill back and have it in the class, but eat something healthy is what I say. You apply a force, and because of that force, the object moves. The object displaces. Okay, displaces. This is when we say work has been done. Okay, hello, come back, welcome back, Harshita. So force is Newton, displacement is meters. So Newton meters, work is Newton meters, or you can say joules. Okay, done. Is it done? Capacity to do work, energy we will do. Okay, but before that, so this is work. See over here, this guy is at position 1 pushing and the box moves. So he did a work on the object because of some force, the object is moving, right? So this is our work and work, okay? Now, when do we say positive work? When do we say negative work? Is that, let's say you're trying to push a table, okay? Imagine I've got a chair in front of me, I'm pushing it. And if the object is moving in the same direction of the applied force, we say positive work, okay? Positive work is motion happens in the direction of applied force, okay? Motion happens in the direction of applied force. What do we say? We're going to say that's positive work. If the motion happens in the direction of applied force, okay? If the motion happens in the direction of applied force, what do we say? This is positive work, okay? This is positive work. The frictional force is opposite, right? Very good. Sikandar, right. If the motion is in the opposite direction of applied force, that's negative, okay? Work done by, let's say this is Charlie, right? He's going, so it's positive. Work done by friction. Friction is the opposition force. Opposite, well, it's a vector quantity, so we get negative over here. Work done by frictional forces, what? Negative over here. I hope you understood, okay? So this is how you say what is work and how work done is going to be called, okay? Well, talking about, imagine you're pushing a wall, okay? When you try to push a wall, do you think the wall is going to move? No, right? So if the force are opposite and the direction of applied motion, force is in the one direction, movement is in other direction, then we take work to be negative. Got it? All right. Now talking about zero work. Zero work is when you're trying to push something and the object does not move. So what is happening? F is equal to, work is equal to force into displacement. Force into displacement. Where it does not move, displacement is 0. So work done will be 0 joules. Got it? Is it clear? When the work done would be 0. Okay. Second case is that when displacement is 0. When displacement is 0. Okay. When displacement is 0. When displacement is 0, what happens? In displacement, like what happens is that, okay, in first case, what is happening is that if you're applying force, but there is no displacement in wall, or you're applying force, F is equal to D, F into D, okay? In the, tug of war, both are applying same force. Force gets cancelled. When the force is 0, work done is 0. When the displacement is 0. In a circular path, what happens? Displacement is 0, right? So, work done would be 0. There is another special case where the angle between, see, she is trying to, displacement is happening like this, but pulling is happening like this. Between this, we have 90 degree. Angle between force plus displacement, okay? Force and displacement is equal to 90 degree. We say again work done is 0, right? Harshita. So if the angle between applied force and that would be 0, we would say what? We would say that the work done is 0. See, after this you will be having two type of energy, work and energy, right? So Ujjwal, hi, welcome to the session, okay? So what happens is work energy theorem. So work done can also be defined in another way. Work done can be defined as rate of change of, okay? Before that, let's talk about energy, okay? Energy is like transfer, like energy is capacity to do work. So energy can be defined as capacity to do work. If you are able to do some work, you've got energy, right? And also we can say that work is done only way, we can also say that work done is the only way to transfer energy, okay? And the SI unit of joules is, SI unit of energy is joules, okay? Rajnish Yadav, hello there, welcome to the session, okay? So energy is capacity to do work. We have work energy theorem, which says how we can actually talk about how much work is done on a body, okay? Now before that, let's talk about kinetic energy. Kinetic energy is energy possessed by a body, because of its motion, virtue of its motion, okay? It's given by half mv square. This is what is kinetic energy, okay? Now, so work done is given by change in kinetic energy. This is what the work energy theorem says. Change in kinetic energy. It would be half mv square minus half mu square. So work done can also be found out using half m into v square minus u square. This is what is our work energy theorem. Remember, work energy theorem, they might ask you theory or numericals will also be asked. Okay, so this is about work energy theorem. Talking about kinetic energy and momentum. You know that kinetic energy is equal to half mv square and momentum is given by mv. Shall we put it over here? So kinetic energy is equal to half mv into v. But for mv we can put momentum, right? So kinetic energy is equal to half pv. So this is the relation between kinetic energy and momentum. Remember, okay, this is a small relation. Okay, now talking about potential energy. Okay, talking about gravitational potential energy. Okay, well, gravitational potential energy says when you keep a body at certain height, it gains some energy. That's what is we're gonna call it as potential energy. Okay, so energy possessed by a body. Okay, energy possessed by a body due to virtue of its position. Okay, due to virtue of its position is called as what? Position is called as potential energy. Okay, is what we're going to call it as. Position is potential energy. Okay, potential energy. Now, how is potential energy is given by? Potential energy is mgh, where m is mass, g is acceleration due to gravity, h is height. So work done due to gravity is, see, whenever you keep it at certain height, you're going in the opposite direction of universal gravitational pull. So this is how work done will be whenever we're going to talk about universal gravity work done by gravity. Okay, so you will be having power. Okay, so power is rate of rate of transfer of energy. Okay, so rate of doing work itself is what we can also call it as power. Okay, so it's like the power is rate of doing work or rate of transfer of energy. So it's like power is equal to work by time. Okay, so work is joules, SI unit of time is second. It would be joules per second, or SI unit would be watts. Okay, WTT, watt. Okay, so this is how we're going to talk about power. This is going to end your work energy. Such a quick recap. Now comes the most interesting, most beautiful chapter, that's sound. You all have, sir, what is law of conservation of energy? Well, law of conservation of energy says energy can neither be created nor be destroyed. Okay, let me write over here, law of conservation of energy. Okay, see, I was trying to focus on high weightage chapters. Sound. Okay, sound I'm going to explain in such a beautiful way. You will wait and watch. I've got so many visual representations. So law of conservation of energy says energy can neither be created nor created nor destroyed, but can be converted from one form to another form. Nor destroyed, but can be converted from, just give me a moment, but it can be converted from one form to another. One form to another. This is what is law of conservation of energy. Did you understand? Is it easy? Okay, so next comes the sound. Well, such an interesting chapter. This is chapter 4. Okay, this is chapter 4th chapter. Now sound. Okay, 4th chapter. What does that say? Well, sound. Okay, such an interesting, such a beautiful chapter. Okay, goes, no problem, you can join now. Well, we will be focusing on the last chapter, 5th chapter. I mean, this is not 4th, this is 5th chapter. Okay, this is 5th chapter. Okay, Now, production of sound. You all know that sound is a form of energy, right? How do we get sound? Sound is like because of vibrations, sir. Take a guitar, just hit the string of a guitar, you get to see sound. Or take a drum, hit the drum, you're gonna see this sound. What is happening? Okay. Work and energy is done, Ghosh. We were talking about the last chapter, that sound, okay? Focus here because this is very important, high weightage chapter. This has got lots of weightage, numericals, everything will be covered. Focus now, okay? You can just go behind and watch about work and energy, okay? How sound is prepared? Well, sound is prepared because of vibrations, okay? It can be anything, vibrations of string, vibrations of particles. In fact, when I'm speaking or you speak, there will be something vibrating inside. So that's vocal cords. So that's also will be vibrating. So it's like vibration happens only when, sound is produced only when the particles vibrate, okay? So the first thing is, over here, what is happening? We have got the strings are vibrating, but over here the drum vibrates. So this is how it's going to, okay, the other way around. We have drum over here and strings over here, right? So this is how the sound is produced, okay? Now going about how sound is produced in our own body, okay? Sound is produced inside our human body because God has given us a pair of vocal cords that vibrates, okay? When the air enters the air column, it vibrates, okay? So this is how we are going to produce sound with the help of vocal cords, okay? So it is also called as sound box or voice box. It's called as larynx. Inside the larynx, we have two beautiful vocal cords which vibrate. When these vocal cords vibrate, okay, this is going to produce a sound, okay? Harshita, actually I gave a break, 5 minutes break I gave already, okay? If you can just focus on 45 minutes, the chapter will be done, physics marathon would be done, so just wait for 44 minutes, okay? I gave a break, Harshita, because see, 12:50, I gave a small 5 minutes break, okay? Please focus, a small bit is there, okay? So nature's gift is our voice box. We are able to produce sound with the help of voice box. Now, how does sound travel? Well, sound has to travel, right? Sound is a form of energy. It's not particle. Particle means particle will go from one place to another place. But in case of sound, it travels in form of waves. It's like he says something, he turns his head, he says the same thing to him, and the message goes. Can you see, people are wherever they are, but the message is going, right? So message is energy here. Particles are people over here. So sound travels in the form of energy, travels in form of waves. Another example is, imagine you've got this, a still calm lake. And what are you going to do? You are going to drop a ball, okay? Okay, so ball is dropped. So there creates waves. There will be ripples, right? Now the ball will be staying wherever it is. It will be like oscillating wherever it is. But these waves are going to travel, right? So this is what we're going to call it as sound waves. Sound travels in form of waves and not particles, right? See, the waves will be going, but the ball will be oscillating wherever it is, right? So this is what we're going to call it as waves. Sound travels in the form of waves. I hope this is clear for you, my dear students, okay? Now, what kind of waves it travels? Well, we'll definitely see, okay? Now, talking about a thing where we going to prove sound requires a medium for propagation. Why and how, you will know. See, you might have heard about this bell jar experiment. Have you heard about bell jar experiment? Well, what does that say? That proves sound requires a medium for propagation. But how and why? See, so revise again. Which part you want me to revise? This one. The waves. Well, I will explain. Okay, do not worry. Okay. So talking about sound requires a medium for propagation. We're going to write sound requires a medium for propagation. All right. What does sound require, my dear students? Sound requires a medium to move, okay, for move propagation. See, I'll quickly explain how this happens, okay. First, take a glass jar, okay, put a bell inside of it and turn on the bell. You can hear the bell ringing. But in the same case, you connect a vacuum pump remove all the air from the jar. What's going to happen? As the pump as the pump is removing all the air, even though the bell is ringing, you are not able to hear that. Why? We don't have any air. It requires a medium. Sound actually requires a medium for propagation. Without a medium, sound cannot travel. It requires either solid, or it requires liquid, or it requires gas to travel. When the bell is ringing, when there is no air, the sound cannot just travel. It requires a medium. So that's why, even though there is lots of noise happening in the sun, we are not able to hear that. We are peacefully here, because even though if we have an earth over here, okay, between sun and earth, what do we have? We have vacuum. Vacuum means there is no medium, okay? There is no medium. Without medium, sound cannot propagate, okay? No medium, what happens? Sound cannot propagate. Understood? Cannot propagate. Understood? Sound requires a medium for propagation, okay? So the question was, how long does the sound take to reach the earth from the sun? Technically, it does not reach, because we do not have any medium. Between sun and earth, we have vacuum, and the vacuum is not going to let the sound travel, because it requires a medium for propagation. That's what we just kind of proved with the help of bell jar experiment. Got it? Right. So there might be a question for you. Why sound waves are called as mechanical waves? Okay. Well, sound waves require what? I just said, okay. Sound waves require a material medium for propagation. Waves require a material medium, right? Material medium for propagation. Medium for propagation. So that's why material medium for propagation. Well, what can be the material medium? It can be solid, liquid, or gas. The material can be, or the medium can be solid, liquid, or gas. Sir, can the sound travel in solid? Of course. In the olden days, we did not have GPS and all. So they used to keep their eyes on the tracks, where they could hear a train coming 20 kilometers away. But that is super dangerous. I don't want you to do that. Just listen, okay? So yeah, of course, you can just keep your head on top of a desk and knock the desk. You can hear the sound, right? Inside the water, how do you think the dolphins are going to communicate? By making sounds itself, right? So this is how sound can travel in solid, liquids, and gases. Okay, I hope that this is clear. If they ask this question, you will be able to answer yes or no. Will you be able to answer if they ask this question? Definitely, you will be able to answer. Next comes the question, how do sound travel? Sound travels in form of waves. Do we have two types of waves here? Yes, indeed we have two types of waves. See, when there is a vibration, so what happens is that the sound is because of vibration. The vibration is going to be passed in the air, and that's how it reaches your ear, right? So how the vibration happens, let's see. Okay, vibration can happen in two ways. Okay, for example, the particles can move like this. See, the particles are vibrating like this, okay, but the energy is going in this direction, right? The particle vibration is like this, but the energy is going in this direction. So particle vibration and energy propagation direction both are happening parallelly, okay? Shall I revise this part, longitudinal wave? See, Harshita, I just started by telling sound is a form of wave. It requires a medium for propagation, first part, okay? Now sound requires a medium for propagation. Without medium, it cannot travel. That is the first thing I told, okay, Harshita? The second part, what I said was how the sound travels. Sound travels in two forms, longitudinal and transverse wave. What do you mean by that, okay? See, the vibration produced has to vibrate in the air. Air molecules vibrate. That vibration reaches your ear. That's what I said, okay? I hope this is clear, okay? Now, if the particle vibration and the wave propagation are parallel to each other, we're going to call it as longitudinal wave, okay? See, in longitudinal wave, we'll be having compression and rarefactions, okay? Do you think the sound also travels in another form? Yes, definitely, okay? When the particle vibration. You can see the particles, we have particles over here, okay? The particles are going up and down, up and down. In this case, this is how particles are moving, but the wave is going like this, okay? Particles are going up and down, and the wave is going in this direction. When the particle vibration, okay, and the wave propagation is perpendicular to each other, we're going to call it as transverse wave, okay? Alright, okay, so this is about transverse wave. Now, understanding about longitudinal and transverse wave, understanding about waves itself, we are going to consider sound waves to be a transverse wave, okay? Now, what is going to happen is that I told you in transverse wave, the particles, will be oscillating up, and then the particles will be going down. So this is how the oscillation happens. But the wave is going like this, okay? Now, topmost point, okay, of the transverse wave is called as crest. What is crest? It is the topmost point of a longitudinal wave or a transverse wave, okay? Now, bottommost point of a transverse wave is called as trough, okay? This is what we are going to call it as trough. Okay, sir. So, what's the length of a wave? Well, the wavelength can be found out using the distance between two consecutive crests, okay, or two consecutive troughs. See, this is one wave. This is another wave. One crest and one trough is going to form one wave. Here we have how many waves? Two waves are there because we have one crest, one trough, one wave, another crest and another trough, we have another wave. So, we have two waves. Got it? So, this is about crest and trough. If you measure the distance between two crest or distance between two trough, that will be giving us the wavelength. Wavelength is given by lambda, okay? Wavelength. I hope this is clear for you all, okay? Why do we require this? We are going to analyze sound waves based on the same details. That's why we would require this, okay? And the SI unit of wavelength is meters, okay? Meters given by m, okay? So, you got to know about crest. Crest is the topmost displacement from the mean position, and trough is the bottommost displacement from the mean position. So, this is about how sound travels or propagates, okay? Now, talking about amplitude and loudness. This is where most of you get confused. Amplitude, loudness, frequency and pitch, okay? Not to get confused, because I'm here to clarify your doubts, okay? See, if I talk like this, hello students, how are you? Hello students, how are you? So the sound is less, right? But if I say, hey students, how are you? The sound is more, okay? Now if I say, hey students, how are you? Sound is less. If I say, hey students, how are you? The sound is more, right? So amplitude talks about loudness of the sound, okay? So amplitude talks about the loudness. If the amplitude is more, see, the displacement is more. That means louder, the sound is more louder. But if the amplitude is less, the size of the particles is less, we say it is less sound. Got it? So we say it is kind of loudness is less, okay? So amplitude, loudness is directly proportional to square of amplitude, but you know this. If amplitude is more, the sound is more. If the amplitude is less, the sound is less, okay? So this is about amplitude. Now comes the frequency. Do not get confused between amplitude and frequency, because these two are the terms which are related to each other, okay? What is the sign of lambda? See, it is positive. It cannot be negative because it is distance, right? Distance is measured in positive direction. Got it, Ghosh? So it's positive, okay? Now talking about pitch and frequency, okay? Now listen to my voice carefully, okay? If I say like this, hey my dear students, how are you? This is such a bass voice. But instead if I say, hey my dear students, how are you? Well, this is such a high pitch, right? So this is what is the difference between low frequency and high frequency. Usually boys will be having low frequency, girls will be having high frequency, okay? See, I'm going to tell you low frequency. Hey my dear students, how are you? This is very low frequency. That means number of waves are coming very small, okay? Now high frequency is, hey my dear students, how are you? Right? It sounds so funny. It's like when you inhale the helium, that's how you get it, okay? I know it was funny, okay? Now frequency means how many times a wave is coming, okay? how many times a wave is appearing. Frequency is how many times a wave is appearing. Okay, that's what we are going to call it as frequency. If more number of wave comes, we say high pitched or high frequency. In the same case, if we get less number of waves, we are going to get bass frequency. Okay, well, you got motivated, thanks a lot, hats off to you, Ghosh. All right, so a good example, you might have seen a sparrow chirping is of high pitch. Okay, and this lion is of very bass voice, so that's lion roar. Okay, hello Nirmal, wishing you a very happy birthday. Is it your birthday today? Happy birthday, have a great year ahead. Okay, so that's all, that's about it. Okay, so time period and frequency, and how the time period and frequency are related. So time period is inversely proportional to frequency. Okay, that means, see, in 1 second we have these many waves. That means high frequency, time is less. In the same time we've got less waves, right? So frequency and time period are inversely proportional. Just know this. Okay, so frequency is very simple. How many times a wave is coming in a given time? More wave comes, more frequency. Less wave comes, less frequency. Okay, now how does high pitch sound like? You can go back and listen. Okay, and how does low pitch voice sound? Low pitch voice would be having very bass voice, just like me. Got it? Now going to the next part. Okay, we have a something called as quality of sound. Well, you know what, you might have seen a scenario which has got same loudness, same frequency, but still, okay, see, the thing is, if sound out of guitar and tabla, okay, of same loudness and frequency might be different, right? Same loudness and same frequency sounds different, isn't it? Sounds different. Why is that? This is because of the internal ripples. Okay, okay, are you a guitarist? Wow, nice. I would like to hear you perform someday. Okay, Ghosh. All right, now see, sound out of a guitar and tabla of same loudness and same frequency might sound different. Why? The reason is we have something called as timbre. Timbre is quality of sound. Quality of sound is also called as timbre. Okay, well, timbre is like, see, you can see here, I can just draw a line to show you the frequency is same. See, everything, amplitude is at same level. Okay, here also amplitude is at same level. Okay, even if you see the frequency of one wave is same everywhere, but still the sound from a tuning fork, violin and noise would be different, right? So this is what is ripple. The internal reflections will be different. Okay, great. So this is about how quality of sound is and how this happens. Got it? So now, before we actually go, just make a note of it and I'll be back real quick. Okay, just make a small note of this. I'll be back. So I'm back. So this is what it is, right? So you got to know about ripple and timbre, amplitude and frequency, right? So amplitude is when you say the loudness is more. Okay, if the amplitude is more, the disturbance is more, so it is more louder. Similarly, if the pitch is more, okay, we say the frequency is more, the pitch is more. Okay, it's like shrillness of the voice. High pitch, very shrill voice. Low pitch, very bass voice. I hope you understood. Okay, great. Now talking about a question. Okay, you've got a poll, you've got 30 seconds left. Okay, I'll give you like 60 seconds. Now the question is like, which of the following statements are true regarding the pitch of a sound wave? Now, pitch depends upon frequency. Second, pitch depends upon, okay, just wait. Okay, option A, option B, option C, option D. Okay, pitch depends upon frequency. Option B, a bird produces high pitched sound. Option C, the voice of a woman is higher than pitch of man. Option D, roaring of a lion is high pitched. A, B, C or D you should say. By the way, this is a multiple choice question. Okay, I'll give you a multiple choice question. So I'll give you a multiple choice question. You should tell me which is the right answer. A multiple choice question. The time has started. See, the question is the pitch depends upon what factor they're asking. Okay, so the pitch depends upon what all factors, and they're saying the bird is going to produce a high pitched sound. They also say the voice of women is very deeper. Think whether it is true, or they're saying high pitch, and then they are saying the roaring of lion is high pitched. Say A, B, C or D. Wow, very good, Ghosh. Very good. Very good. Absolutely great. So roaring of lion is not high pitch. We just saw that's a low pitch sound. So first three are right answers, right? So option A, B, C are right options. Okay. Now talking about this is correct. Okay. A is correct. B is correct. C is correct. Option D is wrong. So I'm going to end the poll. So option A, B, C both are correct. Wow. Very good, Ghosh. You are at the top, leaderboard top. You can just flaunt it in your social circle. That today I attended physics for a class and look where I'm standing at. Okay, great. So this is about pitch, bass and frequency. All right. Now, talking about a question. Let's do a question, okay? The given, okay, we have a wave and it has a speed of, they have given the speed of that to be 500 meters per second. Okay, now determine the frequency of time wave. Well, have they given the time period? Well, the time period is not given. I'll give you a time period. Time period is equal to 0.1 seconds. Okay, now see, the speed of a sound wave has been given, but that is not required. That's not at all useful. We know that the frequency is equal to 1 over time period, right? Frequency is equal to 1 over time period. So frequency we are supposed to find 1 over 0.1, multiply and divide by 10. So this is how you'll be getting 10 hertz. Got it? So in 1 second 10 sound waves are coming. That's what we say. Okay, so this is how you're going to do a numerical. Now let's talk about speed of sound. Okay, now you will be telling me how and what you'll be listening first. So you might have seen firecrackers, right? During the time of the festival of lights, you might see firecrackers, sky shots, New Year, everywhere. Now, if a sky shot is happening very far, can you see it first or can you hear it first? Similarly, during the case of thunder, can you hear the thunder or can you see the lightning first? Can you tell me in the chat forum? Live chat, you will be telling me what is going to happen first, okay? The thing is, the speed of sound, okay, you can see it first because, see, what's going to happen is that speed of sound is just 330 meter per second. But similarly, the speed of sound, speed of light, okay, speed of light is unit 10, 100,000, 10,000 lakh kilometers per second, meter per second. So which is faster, light or sound? So light is faster, so you hear the sound later. So the speed of sound in air is a bit less compared to the speed of light, and speed is given by wavelength divided by time period. Okay, speed of sound wave is the product of wavelength and the frequency. Why are they telling product of wavelength and frequency? 1 by time period is equal to frequency, right? So wherever 1 by frequency, 1 by time period is there, you can take frequency. Okay, no problem, Ghosh, no problem. Do not make this mistake in your final exams. Okay, it's fine. This is your playground. This is where you kind of do all the trial and error and be ready for the exam. Okay, right. Now, and what speed is given by? Speed or velocity is given by wavelength, time, frequency, or wavelength divided by time period. You can also expect numericals on this, so be prepared. So do not kind of skip this part, because numericals will also be asked over here. Okay, now how speed of light will be in different mediums? Well, we can see, well, speed of light will be different in different medium. Why, sir? Because of particle arrangements. If you see gases, the speed of light in gases is less. I just told speed of light in air. Didn't I just tell you the speed of light in air, right? So this is air, okay? The speed of light and speed of sound in air is in light. I mean, speed of light and speed of sound in air is what I said, okay? 330, right? What happens in the case of gases? In gases, we will be having particles loosely packed. So let's say the sound hits the first particle. This first particle has to go here, hit this one, and this has to go here. So it takes time, right? So sound travels a bit slower in gases. What happens in liquid? It's pretty closer. So the vibrations can reach quicker compared to that of air. So it travels faster in liquid. What about solid? Solids are tightly packed, right? So the speed of sound in solids will be highest, in fact, compared to liquid and gases is in solid. So for example, you can see here, in speed of sound in air is almost 344 meter per second. In water it has increased, but if you see in iron, compared to both, it is much more, 5100 meter per second. That's almost 5 kilometer per second, right? So this is how the speed of sound varies in different mediums. Got it? Is it clear, my dear students? Yes, sir. Now, talking about a question, let's try to do a numerical based on the speed of sound. Are you all ready to do a numerical on speed of sound? This is a question what we have over here, okay? Okay, this guy, name of this guy is Rock. Just like how we have got Dwayne Johnson, the name of this guy is Rock, okay? Rock hears a thunder 8 seconds after the lightning. So there will be a lightning happening. After 8 seconds, he hears thunder, okay? So time taken to hear the thunder is 8 seconds. Or, okay, sir, after 8 seconds, what happens? Let's see. How far are the clouds producing the sound? Okay, how far? Distance of cloud we are supposed to find. Distance of clouds we are supposed to find, okay? Distance of clouds we are supposed to find, okay? Now they're giving you the speed of sound in air, that's 340, okay? Okay, now so the speed of sound they're giving it to be speed of sound, how much is given as 340 meter per second, okay? 340 meters per second. We're supposed to find distance. You know that speed is equal to distance divided by time, okay? Now speed has been given, distance distance to be found out, okay? So distance would be how much? Distance is equal to speed into time, isn't it, my dear students? Speed into time. So speed is given to be 340 meter per second and time is, it takes 8 seconds. So what is 340 times 8, right? So 340 times 8, 340 into 8. So it is somewhere around 2720, all right? So 2720 meters far, that means 2 kilometers, okay? So the clouds are, answer is how much, my dear students? Answer is 2720 meters far. This is how you do. Got it? Is it clear? 2720. It's like 8 seconds, my dear. Okay, see, it is in 8 seconds. Okay. Now let's go to the next part, which we're going to talk about reflection of sound. Okay. You know, reflection of sound is like bouncing back of sound when it hits a surface. Reflection of sound is also called as what? It's the echo, right? So reflection of sound is bouncing back of sound. Okay, bouncing back of sound when it hits a hard surface or reflecting surface. Okay, hard or reflecting reflecting surface. You know, hard surface in the sense like we've got concrete walls. Wood is also hard, but wood absorbs, remember, okay? Metals are hard surfaces which are reflecting, okay? Surfaces. So this is what is reflection of sound. And reflection of sound follows the law of light. No worries, okay? No problem, Ghosh, no problem. You please do not repeat that mistake, okay? So what is reflection of sound? See, you might have seen a scenario where you might have, you know, gone on top of a hill. And on top of a hill, what you will be doing? You will be shouting your names, your friends' names, and what happens? You might hear someone else is shouting from that direction. Why? Was that? You think someone else is waiting for you to shout and they are going to listen and shout it back? No, right? So here, that's what is, we call it as echo. Whatever you shout, the same sound goes and hits the hill which is opposite to it, if in case we have a hill, and that sound comes back and the same sound we are going to hear. That's what we are going to call it as reflection of sound. So what's the reflection of sound? Called as, reflection of sound is called as echo, okay? You all know about echo, right? I know you all know about echo. See, what do we call it echo as? Reflection of a sound wave when it hits a surface is called as echo, okay? So original sound wave will be going in this direction, echo will be going in the opposite direction, okay? So repetition of sound due to reflection of sound wave is called as echo. And to hear a distinctive echo, it requires 0.1 second, okay? To hear a clear echo, to hear a clear echo, human brain, okay, requires 0.1 seconds, okay? If the reflection is happening between, okay, 0.1 seconds, so what are we gonna call? Let's see, okay? Hi, I'm back. Okay, Krish, hi there, welcome back, okay? So this is what is echo, okay? Now talking about reverberations, when you go to open houses, or you know, what do you mean by open houses? Open houses is like when you try to go and look into an empty house to move in. That's what we're going to call it as open house. So what is happening in that case? Can you imagine? Well, when you try to say something loud in the empty houses, what's going to happen? You are going to kind of feel a different feel there, right? So what's that? That's what we're going to call it as reverberations. Reverberation is multiple reflection of sound happening in less than 0.1 second, okay? So if reflection is happening in less than 0.1 second, if echo is less than, okay, echo is reflection of sound, okay, less than 0.1 second, our brain thinks this as prolongated sound, okay? Our brain processes, okay? Our brain thinks it as prolonged sound, okay? Prolonged sound, okay? This prolongation of sound is what we call it as reverberations, okay? Reverberations, once more I will explain, okay? Listen, when the time between normal sound and echo minimum it's 0.1 second, we can hear that to be a clear echo, distinctive echo. But ये जो echo है, like this echo, if the echo is happening in less than 0.1 second, see, so one reflection, another reflection reaching you, this multiple reflections happening in less than 0.1 second and reaching you, the original sound and the reflected sound, the time difference between that is less than 0.1 second. Our brain cannot process that as an echo. It feels like the sound is elongated. That elongation of sound is what we're going to call it as reverberations. Got it? Derivation of echo, Krish. Now we are going to do that, okay? So what formula we are going to use for echo? I'll tell you, okay? Okay, I'm going to tell you, okay? How to solve numerical on echo? How to solve numerical on echo? Okay, this is what you were asking, right, Krish? Yes. Imagine you have a hill over here. You have a hill, and one person is on top of hill shouting something. Okay. So what happens? The sound will be going here. this is going, right? The sound is going and hitting it, and after some time what happens? It has to come back. It has to come back, right? So this is what is happening. So everything, it is echo is happening. Echo is happening. Now how to solve numerical based on echo? Okay, now focus, focus. So important, I'm going to tell you. So important. You know that speed is equal to distance divided by time, right? You know this, but in case of echo, they'll be giving you the time taken for echo. See, time taken is for going, let's say it takes some time, for coming it takes some time, okay? They'll be giving you time for an echo, okay? When they give time for an echo, when time for echo is given, time for echo is given, what are you going to do? You take half of the time, because sound has to go from here, it takes some time, covers some distance. While coming back, it travels the same distance, covering some more time, right? So twice the distance, right? We don't want twice the distance. They'll be asking you to find the distance between the source of the sound and the place where it echoes, right? So you'll be using the formula for echo, for time, when the time for echo is given, okay? Use the formula, this formula you'll be using, okay? Use the formula speed is equal to distance by 2, distance divided by 2 divided by what? Time. Why are we going to use that? Because to go once, it has traveled some distance. To come back, it has traveled some distance. During echo, they won't be asking you to find twice the distance. They are going to only ask you the distance between source and the place where the reflection happens. So Chris says 7.2 meters. Am I right? Yeah, like 7.2 meters is the minimum distance for an echo to form. Okay, so that's about it. Okay, so now talking about the next part, what is going to happen? This is about echo, right? So what is going to happen in case of echo is this. All right, so this is about echo, how to use the formula. You can either use this formula or you can use distance divided by half of time, okay? 2 into time. So what happens? Whatever time taken for once, time taken for twice, distance will be divided by 2, one and the same, okay? Now going to the next part, uses of multiple reflection. See, reverberations are not bad, okay? Almost done, Ghosh, almost done. Hello Tameen, hi there, you're watching from Saudi Arabia. Welcome to the session. I'm super excited to teach you as well, okay? So now, see, reverberations are not bad. Reverberations are not always bad. The reverb effect in, the musical system, production of sound gives you such a good effect. But imagine you are listening to this lecture with reverberations on. What's going to happen? It's not going to make you understand, because the sound is overlapping, right? But reverberations have also got some of the applications. What are the applications of reverberations? See, multiple reflection. We are going to use the multiple reflection and use that in megaphone. Megaphone is like you direct the sound in one direction, right? So that's multiple reflection. Do you know stethoscope? Well, doctors are going to use that, right? So what is going to happen? They are going to capture the multiple heartbeats, focus that, and they are going to use that for in stethoscope as well, okay? Right, so this is about the multiple reflection of sound where we use it, okay? So always reverberations are not bad, all right? Now, one last thing, I just wanted to conclude it, but before that, you know what? 700 years ago, a fort built in Golconda has got the structure in such a way that if someone shouts from over here, imagine the enemy is entering, the king at the top of the fort should be told, but it is so far, right? So many kilometers you have to go up. There were no walkie-talkies or phones. What were they doing, right? They're going to create a sound in one place, so the reflection happens in the multiple place and reaches the king at the top of the fort. Look at the technology, how they were using echo in the olden days itself, okay? So this was about one small fact about echo. And range of hearing, I told frequency, right? Frequency is number of times a wave is appearing. That's what we're going to call it as. Is that Golconda Fort? Yeah, my dear, this is Golconda Fort. Can you see this? Have you been there? Have you been to Golconda Fort? If you have been there, you might have experienced it. See, the range of hearing is certain frequency of sounds are audible and certain frequency of sounds are not audible for us. Okay, so a sound wave which is appearing less than 20 times in a second is not audible. We're going to call it as you know what, this is audible range, this is ultrasonic, this is infrasonic. Okay, so these waves are not audible. The frequency of sound below 20 hertz, okay, is not audible for us, for humans, but it is audible for it's audible for giraffe, elephants, pigeons and all. They can hear that. Okay, next we have got audible range for humans, 20 hertz or 20 kilohertz. That means any sound wave coming, appearing 20 times in a second or up to 20,000 times, we can easily hear that. Beyond that, we are not able to hear that. Okay, so that's audible range. This is audible range. This is audible range. Okay, and next comes ultrasonic. This is not audible for us, but it is audible for dolphins, bats, and we're gonna call it as dogs. Okay, below 20,000 hertz it's infrasonic, my dear. Okay, infrasonic. Okay, infrasonic. Okay, this is ultrasonic. Ultrasonic waves. Okay, so remember, a question on this might also appear. All right, so that's all for today, my dear students. I hope you all enjoyed these sessions. This mega revision was super fantastic. Thank you for sticking with me till the end. Now comes your biology class. Okay, sir, आपका नाम क्या है? Well, my name is Sriraj. Okay, application C, ultrasounds. Yeah, we will be using it in case of C. If we try to match the frequency of debris in the bore well, okay, we are able to just break the stones. Imagine someone is suffering from kidney stone. What are they going to do? They're going to pass the sound in the same frequency of resonating frequency of that kidney stones, so that the kidney stones break. Okay, understood, Krish? So this is about it. I hope you all have understood. Range of ultrasound sound, anything beyond 20,000 hertz, it's ultrasound. Got it, Ghosh? So see you, my dear students. I hope you all enjoyed. So I enjoyed a lot. All the best for your exams. Do study, do not procrastinate. This is the time where you can show your hard work during exams. All right, so whatever hard work you have put would be giving you lots of confidence. Thank you very much, everyone, for attending. See you all. Have a great day. See you. Tata. Take care. Bye bye.
Hello everyone. Welcome back to your PW channel. I am Astha, your biology tutor, your biology educator. How are you all doing? Hi, Krish. Hello. Hi, everyone. A very good afternoon to all of you. How is everyone doing? Hello. Hi, Krish. So, bache, you know why we are here? Hello. Hello, Betnai, Ghosh. Hi. Good to see you. Hi everyone, good afternoon to all. So I hope you all know why we are all here for the 9th class marathon series. And today, beta, we're going to discuss all the chapters, right? Today is for the science class. Obviously, I'm the bio teacher. We have already covered the physics class. Today, we'll be talking about biology, right? Right now, we're going to discuss about the biology, all chapter, be it cell, be it tissues, be it improvement. We're going to discuss about every single chapter today. Hi everyone, good afternoon. So from when your exams are starting, beta? On which date your exams are gonna start from? Kab se exam start hai? From which date your exams are starting? Fish, yes, I do teach in Vidyapeeth as well. साइंस का 14th को है, so it's like nearby, right Krish? बहुत ही nearby है. It's just like maybe in few days it's starting. I hope you all are set, beta. And obviously ma'am, end moment में you need कि Thank you so much, Bitnayak Ghosh. Thank you so much for your kind words. So, bache, as you know that today, beta, where I am from Delhi. अच्छा, यहाँ पे नैतिक इज लाइक अपने ही स्टाइल में, नैतिक इज लाइक सब लड़कियों को यूनिक वे में प्रपोज करने के लिए कुछ रिप्लाई बताओ. नैतिक, प्रपोज वगैरह छोड़ो, पढ़ाई पे फोकस करो, है ना. ये वैलेंटाइन वीक तो चलता रहेगा, वैलेंटाइन वीक विल बी देयर थ्रू आउट, है ना. बट do all these things once you are stable in your life. Right now अभी तो ये propose वगैरह सीन छोड़ दो यार, है ना. move past that, ठीक है. और अभी कोई लड़की नहीं पटने वाली तुमसे, उसको छोड़ो. ठीक है. तो बच्चे, what we are going to discuss today आज हम क्या करने वाले हैं, we are going to complete the whole 9th class syllabus, that is बेटा cell, tissue as well as improvement in food resources in single go, है ना. Obviously, if required, we're going to take breaks today whenever required. So first, cell. Obviously, cell is the chapter name would be the fundamental unit of life cell, right? The fundamental unit of life cell. Then we'll be talking about tissues, and after tissues, beta, we'll be talking about improvement in food resources, है ना. Improvement in food resources, ठीक है. We are going to take all 3 chapters, beta. All 3 chapters will be covered today. But are you all ready? All set? All set, beta. Shall we begin with the 3 chapters? Right, we'll start with the very first chapter, that is cell. Shall we begin, beta? Shall we begin with cell chapter? बताए. Shall we start? What do you say? Shall we begin with the cell chapter? Are you guys all ready to look about cell? What is cell? Who discovered cell? What are the components of cell? What is cell division? Are you all set and ready? Quick. All ready? All set? Shall we begin? हाँ जी, शुरू करें. चलो जी. The very first thing, beta, what is cell? Cell is... Okay, come on. So cell is, beta, the basic unit of life, the structural and functional unit of life, basically the karta dharta of the body. All living organisms, be it plants, be it animals, all are made up of cell. Be it any plant, be it any animal, be it birds flying in the sky, be it the dogs barking, right? Be it the plant at your home. Every living organism is made up of cell. It's the smallest unit of living organism. It is the basic building block of living organism. So cell is the structural and functional unit of life. And what we are doing today, beta, we are studying cell. So study of cell is called as cytology. Cyto means cell and logy word comes from study. So study of cell is called as cytology, and cell is the structural and functional unit. Clear, beta? Hi. Good afternoon, Hassan. Alright, shall we proceed? Okay, chalo. So similarly, just you could see a wall is made up of bricks, right? It's a wall, and just like a wall is made up of bricks, similarly, living organisms are made up of cell. Living organisms are made up of cell, right? Next thing, about the discovery of the cell. So the cell was discovered by Mr. Robert Hooke. Robert Hooke, he discovered cell. How he discovered cell? He took the cork of the tree, right, from the tree, that is from the bark of the tree. He took a cork and he observed it under the self-made microscope. It is self-made microscope. And once he observed it under the self-made microscope, he found a honeycomb-like structure. Right? And in this honeycomb-like structure, there were small compartments. And he labeled those compartments as cell. He called those compartments as cell or cellulae. Cellulae is just the Latin word for cell. ठीक है बच्चा. So who discovered cell? Robert Hooke, and absolutely as mentioned by Hassan, it was discovered in 1665. Remember, the cell discovered by Mr. Hooke is a dead cell. It's not a living cell, it's a dead cell, right? There were no living components of the cell present inside it, right? Alright, next Mr. Leeuwenhoek. Leeuwenhoek discovered living cell. If the question comes who discovered cell, we will answer Robert Hooke. If the question comes who discovered living cell, we're going to write down Leeuwenhoek. Leeuwenhoek, L for Leeuwenhoek, L for living cell. And remember, Robert Hooke discovered the dead cell. He discovered the cell for the first time, but that cell was dead, right? That is a living component, that is what is present inside was absent in it. ठीक है, चलो. Next thing. Next is Mr. Brown. Brown discovered nucleus. Remember, Robert Hooke discovered cell, but Robert Brown discovered nucleus. ठीक है जी. चलिए जी. Next चलते हैं. P for Purkinje and P for protoplasm. See बेटा, this is the cell, है ना? ये cell है. This is the cell. Whatever is present inside the cell is called as protoplasm. Whatever is present inside the cell is called as protoplasm. है ना? Whatever is present inside the cell is called as protoplasm. Now, who discovered it? Right? Who coined this term? Who gave this term protoplasm? Who gave this term protoplasm? The protoplasm term was given by Mr. Purkinje. Purkinje gave the term protoplasm for the fluid substance of the cell. Next, Schleiden and Schwann. Schleiden and Schwann beta discovered, they said that all plants and all animals are made up of cell, right? Schleiden, he was a botanist, that is he was studying on plants, and Schwann, he was zoologist, that is he was studying on animals, right? So what did Schleiden and Schwann said? They said that all plants and all animals are made up of cell. That is, they gave this concept of cell theory. They gave the concept of cell theory. What is cell theory, beta? All plants, all animals are made up of cells. ठीक है बेटा? Done. Now बच्चे, from where this cell came? From where these cells arising? Are they just dropping from the, like let's say from the atmosphere, right? Like a Big Bang theory. So it's not like that. So basically we can say the cell arises from the pre-existing cell. है ना? Yes, absolutely right, Krish. The cell arises from pre-existing cell, right? So that was told by Mr. Rudolf Virchow. So what did Rudolf Virchow said? Omnis cellula est cellula. Omnis cellula est cellula. What do you mean by omnis cellula est cellula? That is, all cells arise from pre-existing cell. All cells arise from pre-existing cell. ठीक है बेटा? Hooke discovered the cell, Leeuwenhoek discovered living cell, Robert Brown discovered nucleus, Purkinje coined the term protoplasm. Next, Schleiden and Schwann, all plants and animals are made up of cell. Rudolf Virchow said omnis cellula est cellula, that is, all plants, the cells arise from the pre-existing cell via the process of cell division, चले बेटा आगे. Shall we move ahead? Shall we move ahead beta? Is it clear up till here? Hi Pooja, how are you beta? चलिए. Hi Pooja, hi Shiv, how are you? चलिए बेटा, shall we? Today is your birthday. Happy birthday Nimble. Good afternoon, Shiv beta. I'm happy. Acha ji, that's good to hear that you are happy beta. Everyone should be happy. All right. Hello, Tanmay. Hi, Sikandar. Hi, everyone. A very good afternoon to you. चले स्टार्ट करें. चलिए. Now, बच्चे, organisms are of two types depending on how many cells are present in their body. If the organism have only one cell in their body, they are called as unicellular. Beta, uni means single, right? Uni means single, that is one. So if they have only one cell in their body, they are called as unicellular organism. Multicellular, multi means many, right? What do you mean by multi? What do you mean by multi? Multi means many. That is, they have more than one cell in their body. So if they have only one cell, if they are organized, if they are made up of only one cell, they are called as unicellular organism. But on the other hand, if they are made up of two or more cells, they are called as multicellular organisms. Obviously, beta, if they are only made up of one cell, they will be doing all their functions by themselves, right? For example, bache, if they are made up of only one cell like amoeba, paramecium, bacteria, yeast, right? All these organisms are unicellular organisms. They are made up of only one cell, and that single cell is able to do all the functions. Maybe it is able to respiration, breathing, we can say digestion, or we can say excretion, or we can say growth. So single cell is able to perform all the functions. But on the other hand, multicellular organisms, since there are many cells, right? Since there are many cells, so cells organize to form tissue, tissue organized to form organ, and organ organized to form organ system. So hence we can say, in the case of multicellular organism, we see division of labor. We see division of labor. ठीक है बच्चे, since there are many cells, cells organize to form tissue, tissue organize to form organs, and organs organize to form organ system. Hence we say the work has been divided. Division means we are dividing the work, and labor as in for work. So we are simply dividing the work among different cells, right? So the examples of multicellular organism include obviously animals, and fungus includes, or maybe plants. They all come under multicellular organisms, and the unicellular organism examples are amoeba, paramecium, chlamydomonas, bacteria, and yeast, right? When is your birthday, ma'am? My birthday is in June. Right now, please focus here on unicellular and multicellular organism. Is this concept clear? Shall I move to the next slide, beta? Two types of organism, unicellular, multicellular. One cell, uni, more than one cell, multicellular. Done, bitches. Shall we move ahead? Chale aage. Huh? Let's move ahead. Chaliye. Now, bache, depending on the shape as well, the cells are of different types, right? All the cells in this world do not have a single type of shape. All the cells in this world do not have a single type of shape. They change their shape, right? So they can be irregular. Irregular means that is they are changing their shape. They are changing their shape. The shape is not fixed. The shape is not fixed. But if the shape is fixed, they can be of different types. Let's say, beta, if they are changing the shape, right? What type of shape that can be? For example, it can be seen in amoeba. But amoeba have a definite shape or a indefinite shape. Amoeba can change the shape or it cannot change the shape. What do you think, beta? Shiv, you should focus on the class, beta. है ना? Thank you so much for your kind words. But please focus here. है ना? बताइए, it can? Do you guys agree? Indefinite? Right, beta, it can change the shape, and similarly WBC, that is white blood cell present in our body, can also change the shape, right? So amoeba and white blood cell are the example of irregular cell shape, that is they can change the shape, but the shape can be fixed also. That is either the shape can be discoidal. Discoidal means disc-like, which is of red blood cell. Now cell have elongated and branched. elongated and branched. Elongated means long beta. They are very long, right? So elongated and branched. We could see branches as well. Smooth muscle fiber have a spindle shape. What do you mean by spindle shape? Spindle shape looks somewhat like this, right? That is broad from the middle and pointed from the top. Broad from the middle and pointed from the top. This is spindle shape. Bone cells are stellate. Stellate means star shape. Stellate means star shape. Star shape. Eggs have spherical shape. Fat cells are elliptical, somewhat ovalish. Thank you so much, Tanmay. Alright, let's get back. Okay, beta. So the shape can be regular or the shape can be fixed. Moving forward. Now, we're talking about the cell size. The cell size can be very small up to the size of micrometer, or it can be very large up to a size of meter. So the smallest cell, beta, is PPLO. What is PPLO? Pneumonia like organisms. Beta, example, mycoplasma. Mycoplasma. So mycoplasma, remember beta, it's the smallest cell. What's the smallest cell? PPLO. Next, largest cell. Beta, largest cell is ostrich egg. Largest cell is ostrich egg. But if someone asks you what's the longest cell, the longest cell, remember, is neuron. Neuron. Okay? Or also we can call it as nerve cell. Right? Neuron or nerve cell is the longest cell. Clear, beta? Shall we move ahead? Okay? Shall we move ahead? Chalo. Now, Bachchi, we talk about what are the components of the cell. Yes, you can take the screenshot. If you want to take the screenshot, beta, you can. Okay? You can take the screenshot if you want to. Which is largest cell is ostrich egg. Okay? Now, Bachchi, let's have a look at the parts of cell. What are the different parts of cell? What are the different parts of cell? बच्चे cell बना किसका है? What is cell made up of? What is cell made up of? Let's have a look at that. So if we look into the parts of cell, let's have a look at it. ठीक है बच्चे? So obviously imagine cell like a swimming pool, है ना? Imagine cell like a swimming pool. So swimming pool has a boundary. Swimming pool has a boundary which is separating the swimming pool from the outer environment, right? Similarly, a cell will also have a boundary, and that boundary is called as plasma membrane. So the boundary of the cell is called as plasma membrane, or also called as cell membrane. Plasma membrane, or also called as cell membrane. ठीक है बेटा? So the outermost covering of a cell is called as plasma membrane or cell membrane. What is this cell membrane doing? But it is separating the inner components of the cell from the outer environment. It is separating the inner components of the cell from the outer environment, right? Is it fine up till here, beta? Done? So it is separating the inner components of the cell from the outer environment. Now what is present inside the cell? Let's have a look at it, right? What is present inside the cell? Let's have a look at it. So basically it has a control house called as nucleus. It has a control house called as nucleus which controls all the cellular activity. Nucleus control all the cellular activity. And bachche, this region between nucleus and plasma membrane, it is filled with the fluid. It is filled with some jelly-like substance, with some semi-fluid substance called as cytoplasm. Right? Cytoplasm. So the fluid, the semi-fluid, or shall I say the jelly-like substance present between the nucleus and the plasma membrane, this jelly-like substance, it is called as cytoplasm. And cytoplasm is the region, beta, where all the cellular activities are taking place. ठीक है? Clear? So nucleus is the control house, the boundary is plasma membrane, and cytoplasm is the site of cellular activities. Now Bhatnaik is asking, ma'am, cytoplasm or protoplasm, what are these two things? So you got to know what is cytoplasm. Now what is protoplasm? So protoplasm is beta nucleus plus cytoplasm. Alright, Bhatnaik beta. So what is protoplasm? Protoplasm is nucleus along with cytoplasm. Clear beta? So I'll write it for you. That nucleus plus cytoplasm is protoplasm. ठीक है बेटा? What is protoplasm? Protoplasm is nothing but nucleus plus cytoplasm. Svetaksh, beta, abhi focus on what I am teaching right now. ठीक है जी? Reaction को कैसे lame करें? Which reaction you are talking about, Naitik? All right. Chali beta, is it fine? All right, Krish, let's not focus there. Let's focus here. What are the parts of the cell? Is it clear? Let us move towards the detail of this, right? But Naitik, this is the bio class going on, right? After the bio class, chemistry class will be starting, okay? Rachita ma'am will be taking that class. So you can ask and clear your chemical reaction questions from Rachita ma'am, right? Right now, let's study about cell. ठीक है जी? Okay, now let's talk about the cell membrane, or also called as plasma membrane. Cell membrane, or also called as plasma membrane, is the outermost covering, and it is made up of lipid as well as protein. It is made up of lipid as well as protein. Now what is the function of plasma membrane? It provides the shape to the cell. Next thing, bachche, it's like a boundary, है ना? What is boundary doing? It's controlling who will enter the cell and who will exit the cell, isn't it? What is the boundary doing? Imagine just of your home. What's that boundary doing? It's controlling who will enter and who will exit. Similarly, this plasma membrane is like a boundary. It will control who will enter the cell and who will exit the cell. Therefore, we can say this plasma membrane is selectively permeable membrane. It is selectively permeable membrane. That is, it will control the substances who will enter and who will exit the cell. It's not like anyone can enter the cell and anyone can exit the cell. Only the selected substance will enter the cell and selected substance will exit the cell. So we can call it as selectively permeable membrane. Selectively permeable membrane. That is, only selected substances will enter the cell and only selected substance can move out of the cell. ठीक है? Done? That's it. Okay. Now, bachche, what type of transport takes place, right? If the substance is moving in and out, what type of transport it is? That is, it is the passive transport or is it the active transport? Passive, bachche, when the energy is not required. So, if the energy is not required, we call such type of transport as passive transport. But phospholipid is a beta lipid molecule, fatty molecule, right? You see oil, ghee at your home. What is it made up of? Right? ये किसका बना होता है? Fat molecules. ठीक है? Fat का बना हुआ होता है. Reproduction. Vicky, we are talking about class 9th today. Cell chapter is from class 9th or class 10th. Is it from class 9th or class 10th? Cell is from 9. That is, we are taking today's classes for 9th, not for class 10th. Reproduction is part of class 10th. ठीक है बच्चे? Alright. Let's move ahead beta. Passive transport is when energy is not required, and active transport is when energy is required. So if the energy is required, we call such type of transport as active transport, but if the energy is not required, we call such type of transport as passive transport. So bache, passive transport is of two types, diffusion and osmosis. So diffusion beta is the movement of the substances from the high concentration to low concentration. What is diffusion? The movement of the substances from the region of higher concentration to the region of lower concentration. Now, for example, bache, if I lit a agarbatti in one part of the room, the smell will spread in the room throughout, right? अगर मैं अगरबत्ती को एक कॉर्नर में लिट करूंगी, so the smell of that अगरबत्ती will spread in the whole room. That is, the substances, they move from higher concentration to lower concentration. Let's say this is amoeba, right? And this amoeba is placed in a solution which is having lower CO2 and higher oxygen, right? Oxygen concentration is high. Now, whenever we use this word high and low, we use it in comparison to the cell. ठीक है बेटा, we compare. Whenever we use the word high, low, we always use this word in comparison. So I'm saying high oxygen as compared to what? As compared to amoeba. So obviously, if the outer environment is having high oxygen amount, the inside amoeba will be having lesser oxygen concentrate. Next thing beta, next thing, CO2 is higher in amoeba as compared to the outside solution. Now from where to where the oxygen and CO2 will move? Can you write down in the chat section? Oxygen will move into the cell or outside the cell? Oxygen will move into the cell or outside the cell? बताइए. Into the cell. Absolutely right. Absolutely right. So the oxygen moves from a region of higher concentration to the lower concentration. That is, it is moving from outside to inside. And what about CO2 beta? CO2 also moves from a region of higher concentration to the lower concentration. Higher concentration is present inside. So obviously it will move from higher to lower, that is inside to outside. So diffusion is the movement of the substances from the region of higher concentration to the lower concentration, which we have seen through this. Okay. Next beta, let's say we have taken a beaker and I have taken some dye, and if I'm going to drop that dye, again the dye molecules are going to spread throughout. The same reason, that is, it is moving from a region of higher concentration to a region of lower concentration. Now beta, osmosis. The basic difference between diffusion and osmosis, that is both. We can say osmosis is like a special case of diffusion. Osmosis is like a special case for diffusion. So what is happening in diffusion? The substances move from a region of higher concentration to lower concentration. Diffusion. No membrane is required. For example, beta, if I am putting dye in water, do we require any selectively permeable membrane? There was any selectively permeable membrane present? No. But if, for example, if I spray perfume in one corner of the room and the smell spreads throughout, right? If I lit a agarbatti in one part of the room, the smell spreads throughout. Was there any selectively permeable membrane present there? Answer is obviously, ma'am, no selectively permeable membrane was present. So we can say, beta, remember that here in osmosis, the selectively permeable membrane is required, but in diffusion, there is no selectively permeable membrane, right? It might be there, it might not be there. It might be there, it might not be there. It's not a requirement. But in osmosis, it will be there. Right? So the definition of osmosis is movement of water from the region of its higher concentration, that is from where the water is present in higher amount, it will move towards a region where it is present in lesser amount across a semi-permeable membrane. Across a semi-permeable membrane. For the guys who are here asking for, ma'am, this is for 10th class. No, bache, this is for your class 9th. I am not going to take any class 10th questions here, any class 10 topic here. This marathon is specially dedicated to the class 9 students here. Okay, we'll have a special marathon for class 10 students as well very soon. So guys, wait for that marathon. Aaj ki class, today's class will be all about which class? Class 9th, not at all class 10. Secondly, beta, this class is for English medium. That is, this class will be purely communicated in English. No Hindi, beta. This class will be discussed for the students who only know English. They don't know Hindi language, right? That is why this channel is here. Fine. I'm really sorry that I cannot take the class 10th. Also, I cannot discuss in Hindi. ठीक है? तो ना हम हिंदी में बात कर सकते हैं, ना हम क्लास 9th का ले सकते 10th के क्वेश्चंस ले सकते हैं. ठीक है? चलो. अब so Bashi, let's say there are two solutions, solution A and solution B. Let's say beta solution has large amount of water and solution B has lesser amount of water. The concentration of water is less here, and if we talk about it here, obviously if the water, that is solvent, is high, the solute will be low. The solvent is high, the solute will be low. But here it will be opposite. But since the water is low, solute will be high. It's just having a opposite relation, right? So here we can say the solute will be high. Now from where to where beta water will move? From B to A or A to B? In which direction beta the water will move? What do you think, bache? Bataiye. In which direction the water molecules will move? The water molecules will move from A to B or B to A. What do you think so, guys? क्या लगता है? What do you think so? Hanji, in which direction the water molecules will move? A to B or B to A? Can I say beta water molecules will move from A to B? A to B, that is from the region of higher water concentration to the region of lower water concentration. Done beta, done. Now bache, there are three types of solution: isotonic, hypertonic and hypertonic. If we talk about ice, let's start with hypotonic, then you will be easily able to understand isotonic and hypertonic. Let's first start with hypotonic solution. But you remember, hypo means less, and less we are talking with respect to beta solute. Okay? That is, this solution has less solute. Imagine always whenever the solute will be less, the water will be high. Whenever the solute will be less, the water will be high. Fine? And as compared to inside, the inside obviously just beta ulta. If outside the water is high, inside the water will be low. So from where to where the water will move? Water will move from its higher concentration to its lower concentration. That is, it will move from outside to inside. What happens if you put water in a balloon? What happens when you put water in a balloon? The balloon swells up, right? So what will happen? What will happen beta to plant cell and to the animal cell? What will happen to the plant cell and to the animal cell? The animal cell beta obviously will swell up. As soon as you put water into a cell, it will swell up, right? It will swell. But bache, what happens if you continuously put water in a balloon? The balloon will burst. The balloon will burst, right? Similarly, bache, if you put water into the cell of an animal, it will burst because beta it does not have a rigid cell wall. It only has plasma membrane. Plasma membrane beta cannot withstand high pressure. Plasma membrane cannot withstand high pressure. So we can say it will swell and it will burst. Those of you who do not have any idea about cell wall, ma'am, what is cell wall? So bache, do you remember I discussed few moments back the parts of a cell? Do you remember this whole thing? So bache, this is present in a plant cell as well as in an animal cell. But if we talk about plant cell have a special covering. They have an additional covering called as cell wall. ठीक है बच्चे, what did I say? I said that additional to plasma membrane, plants have a special covering called as cell wall. So remember, cell wall is present outside the plasma membrane. Cell wall is present outside the plasma membrane, and remember beta, this cell wall will be absent in animal cell. It will be absent in animal cell. ठीक है जी, डन है इतना. So it will be present in plant cell, obviously. It will be present in plant cell, but it will be absent in animal cell. And this plant cell wall is quite rigid in nature. But animal cell do not have it, and hence it cannot withstand the high pressure, and hence it's going to burst. But if we talk about plant cell, they have a cell wall. So they will swell beta, but they will not burst. Plant cell will not burst. Why it will not burst? Because, but Nayak, you can make the notes later, right? You will get the notes in the comment section, in the chat section. You will get the notes, right? You can make your notes later. Right now, focus on understanding. Okay? Clear? ऐसे तो if you're gonna write every single thing during the class, it will take 7-8 hours, है ना? In today's class, we have to complete physics also, chemistry also, biology also. It's like a marathon series, right? We have to be little quick. We have to be little fast. ठीक है? It's like a marathon. It's not like a slow pace where you are just running like that. थोड़ा सा fast, little fast. ठीक है? चलो. So plant cell will swell but not burst because of cell wall. Because of cell wall. So since plant cell have a cell wall, they will swell but will not burst because they have a rigid cell wall which will prevent the bursting. ठीक है? This is clear. Hypotonic. है ना? What happens in isotonic? What happens in isotonic? So isotonic, if we talk about here also, the solute and solvent is same as that of the cell. That is, the solution has same concentration of solute and solvent inside and outside the cell. It's same. The solute and solvent concentration is same inside the cell and outside the cell. That is from where the water will move. So little water can move outside, little water can move inside. But is there any net movement of the water? Let's say 5 molecules have moved in and the 5 molecules have moved out. Then what's the total movement of molecules inside or outside? It will be nothing. No net movement. Hi Paras, first of all we are taking for class 9th, है ना? Today's class is dedicated to class 9th, not to class 10th. Thank you so much for your kind words that I teach well, thank you. But today's class beta is for English medium students, ठीक है? So the students who don't know about Hindi much, for those students we have scheduled this class. Alright, so today's class will be communicated only and only in English. Hi Mohit, hi Anup, hi beta. So we're discussing class 9th revision. It's like a 10th Mohit very soon, okay? So today's class will be specifically for class 9 students. We'll be coming with the marathon for class 10th also very soon. ठीक है? चलो. Alright. So isotonic we can say no net movement. Therefore beta, no net movement. So बच्चे बताओ what will be the cell size? The cell size will remain same. Very soon Anup. So the cell size remains same. The cell size remains same. there is no change in size. Whereas in hypotonic, so remember hypo with hippo. Hippopotamus is like mota mota na. Therefore, in hypotonic, the cell becomes mota. It swells up, right? Hippo से याद रखना. Hypotonic में remember with hippo. Hippo is like this now. Therefore, we're going to say in hypotonic solution the cell swells up. ठीक है? What happens in hypertonic? बच्चे hyper means more, and more we are talking with respect to solute. ठीक है? That is, बच्चे the solution is having higher solute. बच्चे higher solute means lesser water. Higher solute means lesser water. And beta less as compared to what? Whenever we say less, more, we use it to compare. So less as compared to what? Less as compared to the cell. The cell will have more amount of water. So what will happen now? Water moves from a region of higher water concentration to a lower water concentration. Where is water high? Inside. So it will move from inside to outside. ठीक है? Inside to outside. So बच्चे water is exiting the cell. Water is exiting the cell. Hence we call it as exosmosis. Exo means exit. है ना? Exit of the water outside the cell is called exosmosis. And beta what will be this? This will be the water is entering the cell. So हम इसको क्या कहेंगे? What are we going to call this? Tell me. If the water is entering inside the cell, we'll call it as endosmosis. Beta endosmosis. Endosmosis. So बच्चे remember, if the water enter inside the cell, we call it as endosmosis. If the water exit out of the cell, we call it as exosmosis. ठीक है? बच्चे obviously what will happen if the water exit the cell? What will happen to animal cell? Do they have a cell wall? No, ma'am. So what will happen? They will shrink. Imagine if you take out water out of a balloon, it will shrink. So what will happen to animal cell? The animal cell will shrink. But bache, what will happen to a plant cell? It will show plasmolysis. It will show plasmolysis. Now what is beta plasmolysis? Let's have a look at this. ठीक है? चलो. Okay, चलिए, let's focus here. ठीक है? What happened to plant cell? It will show plasmolysis. Now you'll be like, ma'am, what is plasmolysis? What is this? Let me just tell you what is plasmolysis in a minute. ठीक है? Let's have a look at it. ठीक है? What is plasmolysis? Let's have a look at it. So see beta, this is what plasmolysis is shown, right? It can be only seen in the plant cell, and when a cell is kept in which solution beta? Hyper ki hypo? Plasmolysis is seen during hypertonic solution or hypotonic solution. Tell me. बताए. Plasmolysis can be seen when a cell is kept in hypertonic or hypotonic. Hypertonic, very good Paris yaar. Hypertonic solution. Again beta, this is because of the presence of cell wall. This is because of the Mohit ji, बिल्कुल जाइए 10 पढ़िए. Your boards exams are near है ना. Do not waste your time. Your time is very, very crucial, right? Only 5 days are left for your boards exam. Not even 5 days because bache, today is 10th and on 15th you have your first board exam. So do not waste your time. Go and study for your first English board exam. ठीक है? So all the best. Go study for your class 10. Let class 9 students study here. Okay? Chalo. So again beta, plasmolysis happens because of the presence of cell wall. So they have a cell wall, right? Plants have a cell wall. So what will happen? The water will move out, but since the cell wall is rigid, it will almost stay there. But bacha, the inner components of the cell will move away from the cell wall, right? Could you see the inner components of the cell is moving away from the cell wall? Could you see the inner components of the cell is moving away from the cell wall. So बच्चे this shrinkage, this contraction, this shrinkage of protoplasm away from the cell wall, this is called as plasmolysis. So when a plant cell is placed in hypertonic solution, there is shrinkage of protoplasm away from the cell wall, and this process is called as plasmolysis. ठीक है बेटा, let's move ahead. चलो जी, now talking about the cell wall, beta cell wall is present in the plant cell also. Beta it is present in not only plant cell but bacteria cell and also in fungus. It is present in bacteria as well as in fungal cell. ठीक है, it is present in bacteria as well as fungus. ठीक है, so plant cell as well as bacteria as well as fungus have this cell wall, but remember beta, it is absent in animal cell. Yes Paras, bache, it is absent in animal cell. Bache, now again as I have told you beta, it's a rigid covering. And a rigid covering, what it is made up of? It is made up of, remember, cellulose. It is made up of, in plant cell, the cell wall is made up of cellulose. It is made up of cellulose. Clear? Clear? And since this cellulose provides strength to the plant, but Nayak, as soon as the syllabus finishes, right, we have 3 chapters. As soon as all the 3 chapters are completed, we'll end the class of bio and chemistry class will start. Very easy question. What's difficult to understand? है ना? ठीक है जी? So obviously it will provide the strength as well as support to the cell. Also बच्चे, it protect the cell from any injury, any harm from any harmful microorganisms. ठीक है जी. Also बच्चे, we have seen in hypertonic solution it will prevent the cell from bursting. So once we place the cell in hypertonic solution, it will not allow it to burst, right? And why is this happening? Because of cell wall. चलिए जी, now we come to nucleus. ठीक है मैम, मेरे को बायोलॉजी में बस इतना ही आता है, mitochondria, powers of the cell. Amit Singh, that is why we have scheduled this class. ठीक है, so if you gonna focus here, then obviously this topic will be clear to you. चलिए जी. So what's a nucleus? As I have told you, it's the brain of the cell, it's the control house of the cell, it's the director of the cell, because बच्चे, it controls every single thing. So it's the brain of the cell. It's the brain of the cell. जल्दी जल्दी से देखते हैं what is nucleus doing. So बच्चे, if we look into the nucleus is double membranous structure. That is, it is surrounded by 2 membranes. Nucleus is surrounded by 2 membranes, that is the outer nuclear membrane and the inner nuclear membrane. Nucleus is surrounded by 2 membranes, that is, it is protected by 2 coverings, the outer nuclear membrane and the inner nuclear membrane. ठीक है जी, इतना done. Outer nuclear membrane and inner nuclear membrane, they are like the coverings which will surround the nucleus, right, which will protect the nucleus. Now the fluid present inside the nucleus, the jelly like semi-fluid present inside the nucleus, is called as nucleoplasm. It is called as nucleoplasm. The jelly like fluid present inside the nucleus is called as nucleoplasm. What is this nucleoplasm containing? The nucleoplasm contains chromatin. It contains chromatin. What is chromatin, beta? What is chromatin? It is made up of DNA and proteins. It is made up of DNA as well as proteins. So this, as you could see, what does chromatin look like? Chromatin looks like an entangled mass of thread-like structure, right? Just imagine this is a thread, right? And you have entangled it, something like this, right? This is like your chromatin, है ना? This is like your chromatin, right? Now what is happening when the cell undergoes division. So when this cell undergoes division, this chromatin, it organizes into a rod like structure called as chromosome. ठीक है बेटा? This chromatin organizes, it condenses to form chromosome beta when during cell division. During cell division. So imagine a chromosome as a book. Just like a book has many chapters, right? Similarly, the chromosomes has various genes. Just like a book has many chapters, the chromosome has various genes. It is having genes. ठीक है? Chromosome consists of gene. And beta remember, these genes, they make up the protein. Genes make the protein. And bache remember, these proteins, they control the character. These proteins, they control the character. ठीक है? For example, you see any plant being tall. Why it is tall? Again, because it is having a gene like that. If you see violet color, why a flower is violet in color? Because it has a gene like that present in it. ठीक है बच्चा, इतना clear है? Okay, चलिए जी. हनुमान जी, I'm sorry. We are not, no need for typist. And right now we are focusing on the cell chapter. We are studying cell chapter. ठीक है जी? Thank you so much, हनुमान जी, for your क्या बोलते हैं इसको, जो भी आपकी कंट्रीब्यूशन थी, फॉर योर कंट्रीब्यूशन, थैंक यू सो मच. ठीक है? Okay, now let's get back to it. So obviously beta, these chromosomes, they are transferred from our parents to offspring. These chromosomes, they are transferred from parents to offspring. Therefore we say these genes, they are transferred from parents to offspring, and therefore we say that since these genes control the characters, we say we look like our parents. Why do we look our parents? Why our characters are similar to our parents? We get our characters from the gene, and genes are present from the chromosome, and chromosome are transferred from one generation to another. Hence, ठीक है? चलो जी. So bache, there are two types of cell, prokaryotic cell and eukaryotic cell. Pro means primitive, so bache, they are smaller in size, and eukaryotic cells, they are little bit larger in size, right? Prokaryotic smaller in size, eukaryotic larger in size. Prokaryotic has membrane bound cell organelles. For example, we have ER, Golgi, mitochondria present here. Eukaryotes have ER, Golgi, mitochondria present. So eukaryotes have ER, mitochondria, Golgi, but prokaryotes do not have ER, Golgi, mitochondria. That is the cell organelles which are surrounded by a membrane. They are not present here. That is, prokaryotes only have ribosomes. Eukaryotes obviously have ribosome. What type of ribosomes are present in prokaryotic cell? 70S type. But if we talk about eukaryotic cells, they have both 70S and 80S type of ribosomes. ठीक है? Prokaryotic cells, if we talk about them, they do not have the nuclear membrane. Their genetic material, that is their DNA, just lying in the cytoplasm. They do not have a covering. They do not have nuclear membrane. So their genetic material is just lying in the cytoplasm, and this is called as nucleoid. So in the prokaryotic cell, we could see nucleoid, but on the other hand, we can say in eukaryotic cell, the nuclear region is very much defined because they have a nuclear membrane. ठीक है जी? Done है. Obviously, if you have to write the examples, you can mention the examples of prokaryotic cells. Example can be bacteria and cyanobacteria, right? But if we talk about the eukaryotic cells, the example can be plants and animals. ठीक है? Done? Next bit is cytoplasm. So cytoplasm we have seen as a jelly-like fluid which is present between the nucleus and plasma membrane, right? Clear? It is made up of beta two things, that is the cytosol, the fluid part, and the cell organelles, that is the structures which are embedded in the cytosol. The structures which are embedded in the cytosol, that is the fluid part, are called as cell organelles. There are three types of cell organelles, that is a double membranous cell organelle, single membranous, and non-membranous. But a double membranous means they are surrounded by two membranes. They are surrounded by two membranes, that is plastids and mitochondria. Single membrane, that is surrounded by only single covering, that is ER, that is endoplasmic reticulum, Golgi bodies, and lysosome. Non-membranous, that is they are not surrounded by any membrane. Example is your ribosome. Itna clear hai beta? Are we clear up till here? Shall we move ahead? Chaliye. So बच्चे endoplasmic reticulum ER, it is, remember, obviously absent in your prokaryotic cell. It is absent in your prokaryotic cell. So if we look into the ER, what are the components of ER? So the components of ER include cisternae, vesicles, and tubules. Tubular, as the name says, they are tubular structure, tube-like structure, right? Tubular structure. Then we have vesicles. Vesicles are like sac-like structure. Sac-like structure. On the other hand, cisternae are like parallel stacks, right? You could see parallel stacks like structure. Cisternae. Now, beta, ER is of two types, RER and SER. Let's have a look at it. So, ER is of two types, that is RER and SER. RER and SER. Rough endoplasmic reticulum and smooth endoplasmic reticulum. ठीक है? Rough endoplasmic reticulum have ribosomes attached on its surface. So if the ER has ribosome attached on its surface, we're going to call it as RER. But if the ribosomes are not attached on the ER surface, we're going to call it smooth endoplasmic reticulum. Why the name rough endoplasmic reticulum? Because once the ribosomes are attached, it will give a rough appearance under the microscope. Hence the name rough endoplasmic reticulum. But smooth endoplasmic reticulum do not have any ribosome attached on the surface. Hence the name smooth, because it will appear smooth under the microscope, and hence the name smooth endoplasmic reticulum. What's the function of RER? RER makes the protein and send it to various parts. So it's making the protein, it's synthesizing the protein. On the other hand, SER synthesizes lipid. See beta, RER synthesizes protein, SER synthesizes lipid. What is plasma membrane made up of? Plasma membrane is made up of lipid as well as protein. So can I say ER helps in the formation of plasma membrane? ER helps in the synthesis of plasma membrane, and which is this synthesis, this formation of plasma membrane is called as membrane biogenesis. Membrane biogenesis. So it is also helping in the process of membrane biogenesis, because RER makes the protein and SER makes the lipid. What is the function of SER apart from making the lipid? It is also making substances like cholesterol, or we can say testosterone, estrogen. It also synthesizes that. Also we can say beta, this SER, it helps in detoxification, right? That is, it will convert the toxic substance into non-toxic substance. It will convert the harmful substance into harmless substance. So it is also performing detoxification, and this beta SER therefore is found in our liver cell. So if we check our liver we say it performs a function of detoxification, right? So detoxification has SER which perform the function of detoxification. ठीक है जी? Hello Dhruv, hi. मैम सर दर्द हो रहा है बेटा, सर दर्द हो रहा है, relax, take a deep breath, have some water and you will be feeling fine. ठीक है जी? Alright, now we come to Golgi apparatus. Golgi was discovered by Mr. Camillo Golgi. Again, beta, remember, it will be absent in a prokaryotic cell, and in plants we use the term dictyosomes because the Golgi apparatus is comparatively more simpler. And very soon, beta, very soon. Now, bache, if we talk about Golgi's function, Golgi क्या कर रहा है? See, ER has made proteins, right? But those proteins are not ready to be sent to various places. Those proteins require some changes, require some modification. Those proteins, therefore, once they are made by ER, they will come to Golgi. What will Golgi do? Golgi will store them, Golgi will modify them, and then finally Golgi will transport them. So the proteins are made up by ER, but they are sent to Golgi for the purpose of storage, for the purpose of modification, for the purpose of packaging to the various parts. So it is acting like somewhat like a post office. ठीक है जी? So Golgi apparatus, it helps in storing, modification and packaging of products. Also bache, since it is modifying all those components, it is modifying the proteins, it is modifying the lipids, therefore beta, therefore we say it is helping in the formation of cell wall, plasma membrane and lysosome. It helps in the formation of cell wall, plasma membrane and lysosome. One more function beta, it converts the simple sugar into complex sugar. It makes a complex sugar from simple sugars. So it is also making complex sugar. Done hai itna? Hi Abhi Pandey, hi Tanmay, hi. Good afternoon everyone. So is it clear up till here beta? Shall we move ahead to the next topic? Done Golgi. Now we come beta to lysosome. Lysosome beta, they are like digestive bags. They are also called as digestive bags because bache, they have digestive enzymes. They have digestive enzymes. What are these digestive enzymes gonna do? But digestive enzymes, as the name says, they're going to digest something. They're going to break down something. What will they break down? But if there is any old cell organelle is there, it will break down that. If any foreign material is coming into the cell, it will break down that. It will break down if any harmful pathogen is entering into the cell. If any waste is present in the cell, it will break down everything. Therefore, it is acting like a waste disposal of the cell by clearing the cell. It will make the cell clean by digesting all these substances, worn out cell organelle, or we can say any foreign material or any pathogen. It will digest everything. Also remember beta, lysosomes, they are also called as suicidal bags of the cell. Why we call them suicidal bags of the cell? But let's say if the cell is damaged, the lysosome will burst and it will release the digestive enzymes out, which will break down the cell components. So since beta, it is causing the death of its own cell, right there, because it is eating up, digesting its own cellular components, hence we call it as a suicidal bag of the cell. So it is suicidal bag as well as the waste disposal system of the cell. ठीक है बच्चे? Next beta, vacuoles. Vacuoles, what's the function of vacuoles? To store. Remember, in plant cell they have a larger vacuole, but in animal cell they have a smaller vacuole. So plant cell have a larger vacuole, on the other hand animal cell have a smaller vacuole. They are storing different things. Therefore, it will provide turgidity and rigidity to the plant cell. It will provide turgidity and rigidity to the plant cell. It will store various things. Now, you'll be like, ma'am, what is it storing? So, it will be storing amino acids, sugars, organic acids, as well as protein. It stores various things. This is like a storage vacuole, storing something. But there is a vacuole called as food vacuole, which is present in amoeba. But this type of vacuole is present in plants. But if we talk about animal, right, animal cell if we talk about amoeba have a vacuole called as food vacuole, where the food will get digested, Finally, bache, there are some type of vacuoles which help us to eliminate the excess waste as well as to maintain the salt balance in the body, and that is present in unicellular organism. So they help to expel the excess water and waste from the cell. They help to remove the excess water as well as waste from the cell. Those are present in again some of the unicellular organisms. Fine, absolutely right. Bitnayak, hi Rahul. Hi Chandan, hi everyone. So bache, we are discussing cell chapter. Since you have joined little late, please focus here. Now बच्चे let's talk about mitochondria. बच्चे mitochondria again dual membrane structure. One outer membrane is there. You could see one outer membrane, right? You could see one outer membrane, and there beta is one inner membrane also which is folded. Could you see this inner membrane which is folded beta? One inner membrane which is folded. So they have an outer membrane as well as they have an inner membrane which is folded. This inner membrane beta is called as cristae. Now why it is folded? It is folded so as to increase the surface area. The inner membrane of the mitochondria, it is folded so as to increase the surface area. Why we are increasing the surface area? Bache, so that we can perform ATP synthesis. That is beta. Now what is ATP, ma'am? What are you talking about? Bache, remember, mitochondria is powerhouse of the cell. It is called as the powerhouse of the cell. Beta, why we call mitochondria as powerhouse of the cell? Why we call mitochondria as powerhouse of the cell? Because here bache, energy is made from the food. We are preparing energy from the food. That is, it is the site of cellular respiration. Very number one point. That is the breakdown of food to yield energy. Now bache, energy is formed in the form of ATP. It is formed in the form of ATP. What is ATP? Adenosine triphosphate. Adenosine triphosphate. ठीक है जी? Again, bache, it is also called as strange or semi-autonomous cell organelle. Why we are calling it as strange cell organelle? Semi-autonomous cell organelle because they have their own DNA as well as ribosomes. Because they have own DNA as well as ribosome, with the help of which they can make few of their own proteins. They can make few proteins by themselves. Hence, we call them as semi-autonomous, so strange organelle, because they have their own DNA as well as ribosome. Now we come to plastids. Plastid beta only present in the plant cell and absent in animal cell. Plastids beta are of three types: chloroplast, chromoplast and leucoplast. ठीक है? Chloroplast beta are green in color, and that green is because of chlorophyll. That green is because of chlorophyll. And beta chlorophyll क्या करता है? What is chlorophyll doing? Beta, it absorbs the sunlight and helps the plant to make food. That is, it helps in the process of photosynthesis. It helps in the process of photosynthesis. And beta, remember, this chloroplast will be present in your leaves. It will be present in your leaves. Chromoplast beta gives orange color, yellowish color, reddish color. So we can say beta, it is made up of, it is having pigments called as carotenoids, carotene and xanthophyll. Where it is present beta, remember, it is present in fruits and flowers. It is present in fruits and flowers. Lastly beta, leucoplasts, they are colorless. They are not giving any color. But what are they doing then if they are not giving any color? But if they are not giving any color, they are storing different things. For example, they store the sugar, they store the oil, they store the protein. So if beta, they store the sugar, that leucoplast is called as amyloplast. Elaioplast store the oil and aleuloplast store the protein. Yes, bache, whole of the class is NCERT based. Okay. Hi Muskan. Hello beta. How are you? चलिए ठीक है. Now बच्चे, we are talking about the difference between plant cell and animal cell. Obviously the very first difference is beta cell wall. Cell wall is present in plant cell but absent in animal cell. Beta second, cell membrane is present in both, right? Now let's talk about vacuoles. We know the vacuoles are larger in size in plants and smaller in size in animals, right? Vacuoles are larger in size in plants and smaller in size in animals. Therefore, beta, since the vacuole here in plant is such large, so large, therefore, beta, the nucleus shifts towards the corner. The nucleus shifts towards the periphery, right? Therefore, we can say the nucleus is towards the corner, but in animal cell, it is present in the center. Next difference is about the plastids. Plastids are only present in plant cell but absent in animal cell. Also, bache, remember centrosome, the cell organelle which help the cell to divide. It is only present in animal cell but absent in plant cell. ठीक है? Animal cell has centrosome. What is centrosome doing? Helping the cell to divide. ठीक है, डन, चलिए आगे. चलिए बच्चे, cell division. What is cell division? बच्चे, cell division is simply बेटा where a single parent cell divides to give two or more cells, right? What is cell division? Where a parent cell is dividing into two or more daughter cell. It is of two types, mitosis and meiosis. But in mitosis, you could see one parent cell give rise to two daughter cell. One parent cell give rise to two daughter cell. So from a single parent cell, there is production of two daughter cell. ठीक है, but in meiosis, a single parent cell give rise to four daughter cell. One parent cell give rise to four daughter cells. You could see here, beta, mitosis, one parent cell give rise to two daughter cells, but in meiosis, one parent cell giving rise to four daughter cell. What about the chromosome number? Remember, in mitosis, the chromosome number remains same, है ना? Chromosome number, the daughter cells have same chromosome number as parent cell. So parent cell, let's say if the parent cell have 46 chromosome, the daughter cell will also have 46 chromosome. So the chromosome number remains same. Very good, yeah, Sikandar, very good. As Sikandar is mentioned, ma'am, in meiosis, the chromosome number does not remain same. It is reduced to half. You could see chromosomes here and you could see chromosomes here. So in daughter cell, the chromosome number is reduced to half. Let's say if parent cell is having 46 chromosome, the daughter cell will have only 23 chromosome. Half number of chromosomes. So in meiosis, the chromosome number is reduced to half. Have half the number of chromosomes as parent cell. ठीक है जी, डन है इतना. Is it fine? Now, next thing, beta, next thing, why mitosis is taking place? For what purpose? For the purpose of growth. For the purpose, let's say if we are growing the organism, we need mitosis to increase the cell number. Also, we require mitosis, beta, for second purpose, that is to replace any old cell. If let's say the cell is old or maybe injured, then if you have to replace that old and injured cell, we require mitosis. But bache, meiosis is required for the formation of gametes, for the formation of sperm, for the formation of egg. We would require meiosis. Clear, beta? Done? So, bache, with that, we are done with the cell chapter. Now, let's quickly see some of the questions of the cell chapter. Beta, quickly answer करना है इसको. Answer it, beta. Answer it. Quickly. A, agree. Hi, Alok. Amit, Patnayak are saying, ma'am, option number A. But mitochondria is powerhouse of the cell, obviously, correct. Right? Mitochondria is the site of ATP synthesis, correct. But is it the reason of the first statement? Is second statement the reason of first statement? Yes, yes. And that is why beta answer is option number A. Very, very good, beta. Very, very good. Chali beta, why are lysosomes called as suicidal bags? What are we going to write here, beta? Why lysosomes are called as suicidal bags? Quick, answer it. Huh? Why lysosomes are called as suicidal bags? What will you write here? क्यों कह रहे हैं? Why we're calling them as suicidal bags? So remember, beta, once the cell is damaged, the lysosome will burst and release the digestive enzymes. Those digestive enzymes will digest its own cellular contents, and since it is digesting its own cellular contents, we call it as the suicidal bags. Right, fine, Amit, fine, but you just narrate the whole story. Do not write in short, but absolutely right. Okay, let's move to the next thing. I want to give you one question as homework. Beta, try to do this question as homework. Okay, I am giving you one question as homework, and beta, now it's time for a small break. We are taking a small break of 5 to 10 minutes. Okay, we will meet in 10 minutes and then we'll begin with the next topic, that is tissues. Chalega? Is it fine, beta? Chale? Chalo. Let's take a small break. Timer. Okay, beta. We are taking a small break of 10 minutes. Okay? So, I shall see you in 10 minutes and then we will start with next topic, tissues. Then beta will start with tissues. Okay? So see you in 10 minutes everyone. We'll start with tissue chapter. All right, beta, we are back and we are back to discuss now tissues. Okay, now we are done with cell chapter, beta. Cell is done. Okay, now we are moving towards the new chapter, beta, which is tissues. Let's have a look into tissues now. Okay, beta. Now, what is tissue, beta? A group of cells. A group of cells which are performing a particular function together is tissue. Okay? And beta, just like the study of cell is called as cytology, the study of tissue we call it as histology. The study of tissue is called as histology. So obviously, if the cells they combine to form tissue, we say there is division of labor. There is division of labor. But that's the why? Because the division process is like that. Okay, Bitnayak, if you go to your class 11th, right? If you go to your class 11, Bitnayak, then what will happen? This cell division and cell cycle will be an entire chapter. One whole chapter is dedicated to only cell division. So once you understood the whole concept, then you will get to know that why chromosome, how chromosome are coming out to be half, or shall I say same. Okay? How this all is happening, you'll get to know in your class 11. But if you want to know that why we are doing for gametes, why gametes have half chromosome, that I can say because half from, let's say 23 chromosome from sperm, 23 chromosome from egg, they combine to form 46 chromosomes of a zygote. That is to restore the chromosome number in generations. The gametes, they have half the number of chromosomes. Okay? Chalega? Okay. Now, beta, importance of tissue, as I have told you, beta, the work will be divided. There will be division of labor. The cells organize to form tissues. Tissues then organize to form organs, and organs organize to form organ system. So basically, yes, there is division of labor here. The work has been divided, and the load on individual cell is decreased. The load on individual cell is decreased. This is about tissues. Let's talk about the plant tissues and animal tissues. Remember, plant tissues has more dead cell and animal tissues have lesser number of the dead cell. They have more living cells, right, as compared to the dead cell. If we talk about why plant cell have dead tissues more in number, because the dead tissues provide them the strength. Second thing, plants do not grow throughout the body. That is, the growth is only restricted to definite regions. The growth is only restricted to definite regions, but yes, they do grow throughout the life. On the other hand, do animals always grow throughout the life? No. We stop our growth after a certain age, right? For example, my height has stopped to increase after a certain age. Now it will not increase continuously, right? So basically, animals do not grow throughout their life, but yes, the growth is throughout the body. My hands will be growing, my legs will be growing, my face will be little bit also increasing in length while I was in my growing phase, obviously. So not throughout the life, but definitely throughout the body. Plants throughout the body, but not throughout the life, but not throughout the body. That was about plants. Also, plants require very less energy because they do not move. But animals, they require more energy because they do move and they have living cells more in their body. Plant cells have dead cells more in their body. What is your height, beta? How will it make the difference? What's my height? My height is 5'5". It's my height. ठीक है जी? 5'5" is Astha ma'am's height. Chalo ji. Now, plant tissues are of two types, beta. If they have the capacity to divide, if the cells have the capacity to divide, we call them as meristematic tissue. But the cells, if they have lost the capacity to divide, they cannot divide, they call as permanent tissue. Meristematic tissue further is of three types, that is apical, lateral and intercalary. On the other hand, permanent is of two types, simple and complex. Simple further is divided into three types: parenchyma, collenchyma, sclerenchyma. Complex further is divided into xylem and phloem. Ma'am, class 10th se who? All right, Aditya, bache, right now we are taking class 9th. Ashwat, class 10. Those of you who are interested in class 10th marathon and class 10th lectures, bache, today class is dedicated to class 9 students, not to class 10th. Okay, we are very soon coming up with class 10th marathon as well. ठीक है, डन, चलो next चीज बचे meristematic tissue. They are also called as growing tissue because meristematic tissue will divide and hence will increase the length of the plant, increase the girth of the plant. It will help the plant to grow, therefore called as growing tissue. Remember, meristematic tissue is not present throughout the body of the plant. It will be only present at certain regions and those regions are called as meristems. So plant has meristematic tissue only present at certain regions. Now beta, what is the characteristic of meristematic tissue? What is the characteristics of the cells present in meristematic tissue? The cells are very active. They have a dense cytoplasm, thin cellulose wall and bache prominent nuclei. That is, the nuclei will be bigger. They have lot amount of cytoplasm. They have very thin cell wall. And beta, remember, there is no intercellular space. Here intercellular space will not be there. And also beta, they lack vacuoles. But why meristematic tissues do not have vacuoles? Because their major function is not of storage. Because major function is not of storage. But if their major function is to divide, if the major function is to divide, why will they keep a vacuole? Vacuole is required for storage. They are not storing the substances. They are just dividing. So they do not have vacuoles. ठीक है बेटा? Three types: apical, lateral and intercalary. Remember beta, apical meristem is present at the shoot tip as well as root tip. Therefore, it will increase the length of the shoot as well as the root. So it will present at the shoot tip as well as the root tip, increase the length of the shoot and root. Next, beta, lateral meristem is present in the side. Therefore, it will increase the girth of the plant. It is present in the side and hence it will increase the girth of the plant. If we talk about intercalary meristem, it is present at the base of the leaves as well as above and below the internode. It is present between the nodes, that is in the internode region. So therefore, it will increase the length of the internode. It will increase the height of the plant. ठीक है बच्चे? So apical, intercalary and lateral meristem. Detail is mentioned here, though I have told you everything from here. ठीक है? चलो. Now बच्चे, few cells of the meristematic tissue, they lose their ability to divide. Right? Meristematic tissues were dividing. The cells of meristematic tissues, girth as in this part, the diameter of the plant. The diameter. ठीक है बेटा? Not the length but the diameter. ठीक है? Hi Ashish, hello. अब बच्चे, no girth बेटा, height तो length हो गया. Length wise is height. Diameter wise is the girth. Breadth we can say in that sense. ठीक है? चौड़ाई बेटा. For example बेटा, this is the length and this is the girth. ठीक है? Wow, Amit, that's fantastic beta. Super proud of you बच्चे. So बच्चे, meristematic tissue, they have the capacity to divide. Once the cells of the meristematic tissue, they lose the capacity to divide and they become specialized. That is, they have a special shape, special size, special function. Then they turn it into permanent tissue. That is, if the cells of the meristematic tissue become specialized in one sense, special shape, special size, special function, and they lose the capacity to divide, then they transform into permanent tissue beta, and this process is called as differentiation. This process is called as differentiation, and hence these cells are called as differentiated cells, and therefore meristematic tissues are called as undifferentiated cells. Now bache, Permanent tissue further is of two types, simple permanent tissue and complex permanent tissue. Simple permanent tissue have only one type of cells and those cells collectively perform a particular function. Three types, parenchyma, collenchyma, sclerenchyma. But if we talk about complex permanent tissue, beta, complex permanent tissue have more than one type of cells and those cells, they are organized to form a particular function and again is of two types, xylem and phloem. ठीक है, चलिए आगे, चलिए बेटा. Now बेटा, simple permanent tissue is of three types, that is parenchyma, collenchyma, sclerenchyma. Let's have a look at it beta. Parenchyma is having living cells, collenchyma is also having living cells and sclerenchyma is made up of dead cell, living dead cell. Now let's talk about the cell wall. So the cell wall of parenchyma is thin, it is thin. But if we talk about the cell wall of the collenchyma, it is thick, but that thick is only at the corners. That thickening is only at the corners and the cell wall thickening is of pectin. The cell wall thickening is of pectin which is only present at corners. Present at corners. The cell wall of sclerenchyma is also thick and that thickness is uniform. That thickness is uniform and that thickness is because of lignin. Lignin beta is like a cement-like substance which makes the plant hard and stiff. So definitely the sclerenchyma will be providing hardness and stiffness to the cell, ठीक है, or to the plant, ठीक है. Now, bache, if we talk about parenchyma, parenchyma have intercellular spaces present in them. Collenchyma, intercellular spaces either will be absent or will be very less, and sclerenchyma do not have any intercellular space. Why? Because of thickening. Because of presence of thickening. ठीक है बेटा? Clear है इतना? Is it clear up till here? Fine. Next, if we move towards it, so bache, parenchyma has cytoplasm. Obviously, it has a large vacuole. It has cytoplasm. It has nucleus. Collenchyma will also have beta cytoplasm. That is a large vacuole. It will have a nucleus. It will have cytoplasm. But the sclerenchyma beta, the cytoplasm is not present because it is dead beta. Dead means the cytoplasm is not there, the protoplasm is not there or very less is there. ठीक है बच्चे? Now beta, the basic function, obviously the parenchyma basic function is storage. Okay, this is how a parenchyma looks like. A large vacuole is there, the nucleus and cytoplasm shift towards the periphery and obviously there is intercellular space. But if we talk about collenchyma, they have thickening only at the corners. Again, a large vacuole, nucleus and cytoplasm have shifted towards the periphery. ठीक है जी? I have understood that, but Nayak, thank you so much for telling me. Also, beta, if we talk about sclerenchyma, where is sclerenchyma present? It is present in the nuts. It is present in the husk of the coconut. It is present in the seed coat. It is present in the guava, right? The gritty nature of the fruits like guava or apple, the crunchy flavor of the apple or the crunchiness of the apple, that grittiness of the apple of different fruits, maybe guava, apple, it is because of sclerenchyma. ठीक है? Question नहीं लिखे. Which questions Ashish बेटा? ठीक है? चलिए जी. So parenchyma, it's बेटा packaging tissue. ठीक है? P for parenchyma and it P for packaging tissue. That is, it fills the space between the other tissues. It fills the space between the other tissues. Collenchyma beta provides the flexibility. It will allow the bending without breaking. It will allow the bending without breaking. Also beta, it will be providing strength also. Where it is present in the leaf stalk below the epidermis. What is leaf stalk? Leaf stalk is this. This is the leaf stalk, है ना? This is the leaf stalk. So it is present in the leaf stalk below the epidermis. Sclerenchyma, crunchiness, but Nayak, grittiness as in the crunchiness. Hello, Alok. Sclerenchyma, which obviously I've told you, it is present in the husk of the coconut. It makes the plant hard and stiff. Also, it is present in the vascular bundle, in the veins of the leaves, and in the outer covering of the seeds and the nuts. Strength, तो obviously it gives because it has lignins. So lignins provide that hardness and stiffness to the plants. ठीक है जी? चलिए, but now parenchyma, if the parenchyma has chlorophyll, what can chlorophyll do? Chlorophyll can absorb the sunlight and help to make food. That is, it helps in the process of photosynthesis. So chlorenchyma has chlorophyll, it helps in the process of photosynthesis. If the parenchyma have air cavity, it will become light. It will help the plant to float. Therefore, it is present in aquatic plants, and arenchyma is a type of parenchyma which provide buoyancy. Lastly, which is storage parenchyma, that name suggests it will store different nutrients as well as food. ठीक है, चले आगे. Shall we move ahead? चलो. अब अच्छे sclerenchymas of two types, sclerites and fibers. You could see sclerites are somewhat spherical cells. On the other hand, the fibers somewhat look like, you know, we can say fiber-like, very long, elongated, spindle-shaped, right? Also, we could see some pits. Pits are like unthickened area, where the thickenings are not present, unthickened area. Chaliye ji. Protective tissue, the name suggests, which will provide protection, beta. The tissue which provides protection is called as protective tissue. It is of two types, epidermis and cork. Epidermis and cork. Now, but epidermis function, as the name suggests, it will provide the protection from any injury. It will give strength to the plant. Also, beta, what's the function of this epidermis? It will protect from any mechanical injury, from any pathogen attack, right? It will protect from any parasitic attack. Okay? So, these all are the function of epidermis. Now, but if we talk about the epidermis of the leaves, they have small pores, and those pores are called as stomata. What's the function of stomata, beta? Exchange of gases. What's the function of stomata? Exchange of gases. That is, you know, let's say the CO2 can come in and the oxygen can go out. That is, it helps in exchange of gases, as well as it helps in transpiration. That is, loss of water in the form of water vapor. But beta, imagine if that pore is always open, all the water can be lost through that stomata, and hence beta, that stomata will be surrounded by guard cell which will prevent, you know, which will close the stomatal pore when the gases are not required. Not required. ठीक है? तो stomata pore will be crossed with the help of guard cell. ठीक है जी? Also remember, beta, epidermis have a waxy layer over it. Epidermis of the aerial parts, that is not in the roots, beta, of the stem, of the leaves, they have a waxy layer over it, and that waxy layer is called as, that waterproof layer is called as cuticle. Remember, it's a waterproof layer, it's a cuticle, so it will be more thicker in the desert area because the temperature is so high. Therefore, in desert area, the cuticle is going to be thicker. ठीक है बेटा? Done? Okay, if we talk about the roots, beta, if we talk about the epidermis of the roots, so epidermis of the roots, beta, have some extensions. They have some outgrowth, and beta, that outgrowth is called as root hair. But what is the function of outgrowth? It will increase the surface area. That is, more the surface area, more the water absorption. More the surface area, more will be the water absorption. Clear, beta? Is it clear up till here? Chalega? Parth, you tell me which chapter is this. है ना? Your exams are gonna start very, very soon, and you are asking me, ma'am, which chapter is this? Seriously? है? क्या हो रहा है ये? बच्चे, आशीष, PDF will be provided to you, okay? PDF will be there with you. चलिए जी, cork. बच्चे epidermis is present in the young stem, but if we talk about the old stem, they have cork. Cork have dead cell and they have a cell wall thickening of suberin. They have a cell wall thickening of suberin. They have a cell wall thickening of suberin. Where it is mentioned or it's not mentioned. Maybe we can mention, right? It is having dead cells and also they have cell wall thickening of suberin. And suberin, remember, it is impervious to gases as well as water. That is, beta. Alok, the PDF of this class will be provided to you once the class is over. Not right now, beta. The class is still going on. है ना? Once the class will be over, you will get the PDF. ठीक है? चलो. So, बच्चे, cork has multiple functions apart from it, that it is being lightweight. It can be used as a shock absorber also. It is also beta going to be protect you from the harmful microorganism attack. Also beta, it can be used as sports good in the making of bats and balls and rackets, right? So all of that are also the uses of cork. चलिए बेटा, next चीज xylem and phloem. Xylem beta, remember, transport water and minerals. Phloem transports food. Xylem transports water from the roots to the leaves, but the food is transported from the leaves to the roots. Also in the opposite direction as well, that is the transport of the transport by the xylem will be only unidirectional, that is only in the upward direction. But if we talk about the phloem, that will be in the both upward as well as downward direction. ठीक है जी, इतना clear है? Now, which you remember, xylem is made up of tracheids, vessels, xylem parenchyma and xylem fibers, out of which remember only xylem parenchyma is living, rest all are dead. But if we talk about phloem beta, phloem is made up of sieve cells, sieve tube, companion cell, phloem parenchyma and phloem fibers, out of which only and only beta phloem fibers are dead, rest all are living. Rest all are living. Remember, vessels and tracheids, they help to transport water. Here the sieve tube helps to transport the water. Sieve tube does not have nucleus, therefore the companion cell will control the activity of the sieve tube. It will control the activity of the sieve tube. So I have told you this, and yes, beta, xylem provides strength as well. Phloem provides strength but not as much as xylem. Xylem provides more strength. ठीक है? अरे अरे अरे, अमित जी तो पूरी मैम की हिस्ट्री ले आए. अमित जी हैज ऑल द हिस्ट्री ज्योग्राफी ऑफ मैम. मैम टीच हियर, मैम टीच ऑल्सो देयर, मैम इज ऑल्सो टीचिंग हियर. अमित, यू हैव फुल नॉलेज, है ना? Hi Sugi, hi, good afternoon everyone. So those of you who have joined late beta, we are doing a marathon series for class 9th. That is, we have covered cell chapter, we have also covered beta tissues chapter, plant tissue part. ठीक है? This is how beta xylem looks like, which we have seen. ठीक है जी? This is your phloem and beta we have done it. अब हम आगे बढ़ते हैं एनिमल टिश्यूज की तरफ. शैल वी बिगिन विद एनिमल टिश्यूज? बताइए. प्लांट टिश्यूज हो गए बेटा, प्लांट टिश्यूज इज डन. शैल वी मूव? बताइए. हाय चैत्रा, NSGR, hi everyone. Salvi, hi Sugi, hi everyone, good afternoon. Shall we start with animal tissue beta? Okay, चलो बच्चे. Animal tissue beta are of 4 types, that is epithelial tissue, connective tissue, muscular tissue, nervous tissue. ठीक है? We'll discuss each one by one. बच्चे, epithelial tissue is the tissue which is also called as epithelium, and it will be present like a covering, है ना? It will be present like a covering outside as well as inside. It will cover the hollow internal organs as well as it will be present outside. ठीक है? What it will be doing? It will be helping in various functions, including secretion, including exchange of gases, including protection. It will be doing various types of the function. Let's have a look at the epithelial tissue in detail. But do they have any intercellular spaces? No. The cells of the epithelial tissue will be compactly packed. There will be no intercellular space. ठीक है? Kshetra, very soon. Not today, beta. Not today. Very soon. बच्चे epithelial tissues of two types, simple and squamous or compound epithelium. What is simple epithelium? बच्चे once the epithelium is only made up of single layer. Made up of beta single layer. Made up of single layer of cell. If there is only single layer of cells present, then we call such type of epithelium as, if only one layer of cells is present, we call it as simple epithelium. But beta, if we have more than one layer of cells, if we have more than one layer of cells, we call it as squamous epithelium. ठीक है बेटा? If only one layer of cell will be there, we call it as simple epithelium. If more than one layer is present, we call it as compound or stratified epithelium. Ab beta G, epithelium is of different types: simple epithelium, cuboidal, columnar, ciliated and glandular. But this should be squamous, not simple. Please correct it. इसको correct करेंगे, ठीक है? This is squamous beta, squamous epithelium. ठीक है? चलिए, let's discuss one by one each type of epithelium. We'll start first with simple squamous epithelium. But squamous epithelium means very thin flat cells. Very thin flat cells will be there, है ना? Where it will be present beta? It will be present in the blood vessel. It will be present in the air sacs of the lungs. That is, it will be present in the alveoli beta. It will be present in the alveoli of the lungs. What's the function? But it will help in the exchange. It will help in the diffusion. It will help in the exchange of substances. That is, it will help in the exchange of gases. ठीक है? So stratified epithelium is a very thin epithelium. That is why it is helping in exchanging. But chemistry class will start after the bio class, right? We are still at tissues chapter. First we'll complete tissues, then we'll move to improvement chapter. And once we are done with chemistry, then biology part, then we will start with chemistry. ठीक है? चलेगा? First we have completed whole physics part, then we are moving towards the biology part, then finally we'll come towards the chemistry part. ठीक है? Anisha, that's so great that you are taking class from Ladakh. Great, beta. What's your doubt, Chintan? Chalim, beta, shall we proceed ahead? Next, beta, cuboidal. The name itself says the shape of the cells will be cube-like. The shape of the cells will be cube-like, right? Then where it will be present, beta? It will be present in the kidney tubules, in the ducts of the salivary gland. Also, it is present in your gonads. That is your reproductive organ. That is your testes, ovaries. They are also going to find these type of epithelium. Now, beta, the functions include secretion, absorption, as well as providing the support. It will provide the support. It is also helping in secretion as well as absorption. What is respiration? Respiration is beta food से energy का बनना. Conversion of food to yield energy is your respiration. Fine, Chintan. ठीक है? Columnar, beta, name itself suggests columnar means it will have tall pillar like cells. It will have very tall, very elongated column like pillar like cell. Where it is present in the intestine. What's the function? It helps in secretion as well as absorption. Secretion as well as absorption. Ciliated epithelium. Ciliated epithelium means beta the cells will have cilia. The cells will have cilia. For example, these are the cells, and beta if the cells have some hair-like structure present on the surface, and beta if the cells have hair-like structures present on the surface, these hair-like structure they are called as cilia. ठीक है, so beta these cilia they will help, they act like a broom, they act like a jhadu, they will move the substance in one direction, therefore it will be present in our respiratory tract, in your trachea. And Raghav, the tract, it's like a tubular structure through which the gas moves, right? This is the respiratory tract, the pharynx, larynx, trachea, all of that will be part of your respiratory tract. So here we are talking about the trachea. It will be present in the trachea. Where is the ciliated epithelium present? In the respiratory tract, especially in the trachea. Also it will be present in the oviduct, that is fallopian tube, right? So yeah, that was about it. It will help in the movement of the substances. Glandular, beta, glandular epithelium is a epithelium which produce some secretion. It will secrete some secretion, right? For example, beta, we have salivary gland. Glandular epithelium, it will make saliva. Sweat gland will make sweat. Easy, right? We make saliva, we produce saliva daily because of salivary gland. We have sebaceous gland. So we have different types of gland which produce different types of secretion. ठीक है बेटा जी, epithelium is done. Shall we move to the next part? आपकी मैम रील देखी थी. That's so good, अमित जी. थोड़ा आगे चले. Yeah, Ashish, I didn't get you, beta. Hi, Dheeraj. Hello, hello, hello. चले, shall we move ahead, बच्चे? चलो. Which is stratified epithelium? Stratified, you know, it will have layers, right? Many layers of cell. More than one layer of cell will be there, and beta it will be present in the skin, in the esophagus, in the lining of the mouth. And beta, which type of epithelium it is? Stratified squamous epithelium. Stratified squamous epithelium. What's the function of it? Bache, what's the function of this epithelium? Prevents the wear and tear. Prevent the wear and tear. It will provide protection. Provide protection. है ना? Provide protection. चलिए, डन है इतना? Is it clear? चलिए थोड़ा सा आगे. Next चीज is beta nervous tissue. Nervous tissue is a tissue which is made up of. See, beta tissue is a group of cell. Now nervous tissue is made up of which cell? It is made up of neuron. The cell name is neuron, also called as nerve cell. Nervous tissue consists of the brain, spinal cord as well as nerves. Brain, spinal cord and nerves consist of, are components of nervous tissue. Nervous tissue has a cell called as nerve cell or also called as neuron. ठीक है बेटा, nerve cell or also called as neuron. एक बार जल्दी से I want to show you the image if I can. Hopefully I can. Give me just 1 minute बेटा. Yes. ठीक है. We'll understand it with the help of the 3D model. ठीक है जी. चलो बच्चे. So if we look into the nervous tissue beta, if we, okay, I hope ये visible है आपको, है ना? Just give me 2 minutes, है ना? ये इसको fix कर लेते हैं, then it will be more better to you. Better, है ना? So बच्चे, it consists of few parts. This part which you could see, it is called as cell body, which consists of the nucleus as well as the other part of the cytoplasm. So nucleus along with this cytoplasm which you could see here, this part is called as cell body. From this cell body, some branched processes arises, and these branch processes are called as dendrite. These branch processes beta, they are called as oh, ये तो क्या हो गया? This has gone for a ride, है ना? Our neuron has gone for a ride here. Okay, let me fix it. Hanji, these branch processes which are arising from the cell body, these are called as the dendrites, and from the cell body this cylindrical process also arises, and this cylindrical process beta is called as axon. This cylindrical process is called as axon, and towards the end we have the nerve terminal, or we can say axon terminal is there, right? So basically cell body, dendrites, axon and the axon terminal. Fine, these are all the components of a neuron. What all nervous tissue helps us to do? Beta, what all you can do with the help of the nervous tissue? You can smell, right? You can memorize, you can learn something, you can solve any maths problem, right? You can see, right? You can protect yourself from harm. For example, let's say this is a hot object, right? If I touch it, what I'm going to do? I'm going to remove my hand. So all these sensations you are able to feel, see something, smell something, taste something, right? All this you are able to feel because of the nervous tissue. ठीक है जी, learn something, memorize something, everything is possible because of nervous tissue. चलिए जी, I have told you everything. Dendrites, the very first thing, then we have cell body, then axon, then towards the end. Next beta, muscular tissue. Beta, this is an online class. Rook, not Rook. Hi Arshad, hi everyone. Good afternoon. Rook was some name, I guess I watched Death Note, है ना? उसमें there was a creature, उसका नाम था रूक, ऐसा मुझे याद आ रहा है. Yes, my name is Astha. ठीक है जी, चलो. Shall we start beta? Shall we begin with muscular tissue? Are you guys all ready? Shall we start? So muscular tissue beta is a tissue which helps you to move. Right, you are able to swim, jump, walk, birds are able to fly, or you are able to run. All of this is possible because of this tissue called as muscular tissue. ठीक है, muscular tissue. अब बच्चे muscular tissue, if we talk about the muscles are of three types, that is skeletal muscle, smooth muscle and cardiac muscle. You could see skeletal muscle look like somewhat cylindrical, and they have these striations, these alternative dark and light band present in them, and hence they are also called as striated muscle. But they are also called as striated muscles because they have striations present in them. And why they are called skeletal muscle? Because beta, they are attached to our endoskeleton, they are attached to our bones. These muscles are attached to our bones, hence called as skeletal muscle. Smooth muscle, why the name smooth? Because beta, here there are no striations present, there are no alternate dark and light band present. What is the shape of the smooth muscle? It is spindle shape. It is spindle shape, that is broad from the middle and corners से ये कैसा है? Pointed है. Pointed from the corners, middle से कैसा है? Broad है. Cardiac muscle beta, again how they are again cylindrical beta. They have striations, but these striations are going to be faint. One thing we can see that in skeletal and smooth there is no branching, but in cardiac muscle we can see these branches as well beta. Remember this, the skeletal muscle and smooth muscle do not have any branching, but cardiac muscles have branches. And lastly beta, one more thing, remember that skeletal muscle has more than one nucleus, that is they are multinucleated. Smooth and cardiac both are uninucleated. Thank you so much Rook. But Nayak, obviously it's an online class, you can go, why not? ठीक है बच्चे, the basic structure is clear, है ना? The basic structure is clear. Now let's look into the location and the function of these muscles. ठीक है बेटा, चलो. So the structure we have already seen. ठीक है, fibers have we have seen all of these part beta. Just give me a second. चलिए, I'll tell you this orally only. It's not mentioned here, beta. Striated muscles, skeletal muscles are striated muscles, Suhani, because they have striations present in them. That is, alternate dark and light band are present. And you could see here alternate dark and light band. You could see the striations, beta. Striated muscle. Now, where is skeletal muscle present? Remember, skeletal muscle is voluntary in nature. That is, it is under our conscious control. You can control this movement, right? I can control this movement. So, it will be present in our hands. It will be present in our legs. Done. Skeletal muscle. Smooth muscle, beta, it is involuntary in nature, not under our conscious control. For example, beta, once the food is moving in your digestive system, it is moving from stomach to small intestine. Can you control this movement? No, we cannot control it. So, therefore, it is present in your hollow internal organ, maybe your ureter, maybe your uterus, maybe your small intestine, in your stomach, in your large intestine, in your blood vessel, in all the hollow internal organs except heart, you have smooth muscle present there. So, where is cardiac muscle present, beta? Remember, cardiac word is related to heart. Cardiac word is related to heart. So, it will be present in your heart. Remember, beta, once I am, see, where skeletal muscle present? In my hands and legs. So, I am going to walk and do all the exercises. What will happen, beta? I will get tired. My muscles will pain. There will be pain in my muscles. So, my skeletal muscle do get fatigued. But, बच्चा, क्या cardiac muscle कभी fatigue होंगे? Will cardiac muscle ever get fatigued? Answer is no, beta. They do not get fatigued. थकते ही नहीं है, beta. If cardiac muscle will get fatigued, they will get tired. Then you will go. है ना, टाटा बाय बाय हो जाएगा फिर, ठीक है. सो कार्डियक मसल्स आर नॉट गेटिंग टायर्ड, ठीक है. लास्ट बेटा, कनेक्टिव टिश्यू. कनेक्टिव टिश्यू हैव सेल्स इन देम, fibers are there as well as matrix is there. Yes, lactic acid production is there. Very good, beta, very good. Okay, now there are three types of connective tissue on the basis of what type of matrix is there. Matrix is the substance in which the cells are embedded. It's the substance in which the cells are embedded. So, jelly-like matrix is there, solid matrix is there, and fluid matrix is there. If the jelly matrix is there, there are two types of tissue, loose connective tissue and dense regular connective tissue. Loose connective tissue, further two types, areolar and adipose. Dense regular, further of two types, tendons and ligaments. Solid matrix, then we call that tissue as skeletal tissue of two types, cartilage and bone. Fluid matrix is there, then we call that tissue as fluid connective tissue, that is blood and lymph. Shall we start to discuss each type of tissue one by one very quickly? बताइए, शुरू करें बच्चे. Because it has cells, it has matrix, but remember the fibers are absent here, है ना. Cells है, matrix है, it's a fluid connective tissue, ठीक है. Fibers are absent. करें start, shall we start? चलो जी. But सबसे पहले there are different types of cells present. For example, fibroblast, mast cell, plasma cell, macrophage, adipose cell. Different types of cell. Two types of fibers can be seen, collagen fibers and elastic fibers. Remember, collagen fibers are white in color. So, they are also called as white fibers. On the other hand, if we talk about elastic fibers, they are also called as yellow fibers because they are yellow in color. They are yellow in color and hence called as yellow fibers. ठीक है बेटा. Next चीज बचे, next thing. Remember beta, collagen fibers, they provide strength. They provide strength. On the other hand, if we talk about elastic fibers, as the name suggests, it provide elasticity. ठीक है. सबसे पहले एरियोलर कनेक्टिव टिश्यू बेटा पैकेजिंग टिश्यू है. इट इज प्रेजेंट बिटवीन द स्किन एंड द मसल्स. It is present in the skin and the muscle. It is acting like a packaging tissue. It is also helping in repair, beta. Also helps in repair. Also, beta, it is present around the blood vessel. ठीक है जी. Adipose tissue, beta, adipose tissue will have adipose cell, that is fat cell. Fat cell will have fat store in them, that is it will, and we all know fat is a poor conductor of heat. So beta, it will act like an insulator. It will protect you in cold climate. ठीक है, इतना डन है, चलिए आगे. Because of their structure, Suhani, the protein, it is made up of collagen protein, which is providing you basically strength. The function is that. ठीक है जी. Dense regular connective tissue. Dense regular connective tissue is of two types, tendons and ligaments. Remember tendons. Beta, MTB. Remember with MTB. M means muscle. To which part they will provide strength? Wherever they will be present, Suhani, wherever they will be present. For example, these fibers will be present in the tendons. So they will provide strength to the tendons. है ना? Wherever they will present, they will provide that strength. ठीक है जी? MTB से बेटा याद रखेंगे, will remember why this mnemonic MTB. M for muscle, B for bone, and beta T for tendon. T for tendon. So remember, tendon will connect muscle to bone. Tendon will connect muscle to bone. And beta, remember ligament. Ligament. Ligament will remember with the mnemonic bulb. That is bone. L for ligament and B for again bone. So bache, remember, bone to bone is connected by ligament. So ligament connects one bone to another bone, but the tendon connects the muscle to bone. ठीक है बेटा? Yes. ठीक है? Bone to bone is connected by ligament, muscle to bone connected by tendon. But next we come to skeletal connective tissue, provides the strength, provide the framework to the body. It is of two types, bone and cartilage. But bone का जो cell होता है, bone is obviously very strong and non-flexible. It is not flexible. You cannot bend a bone, right? You cannot bend a bone. You will break it. It's so strong, it's not flexible. But if we talk about cartilage, it is strong as well as beta flexible. It is strong as well as bache flexible. Remember it. Remember it. It's strong as well as flexible. What's the cell of the bone? Beta, bone cell is called as, the cell of the bone is called as osteocyte. The cell of the bone is called as osteocyte. On the other hand, the cartilage cell is called as, the cell of the cartilage is called as chondrocyte. Chondrocyte. ठीक है बच्चे? Cell of the bone is osteocyte, cell of the cartilage is chondrocyte. Also beta, remember, this osteocyte will be embedded in the matrix. And bache, remember that matrix is made up of calcium and phosphorus. This matrix is made up of calcium and phosphorus. Therefore, it is very strong and very hard. ठीक है? Because the cells are present in the matrix and the matrix is made up of calcium and phosphorus. ठीक है बच्चे? याद रखिएगा. It forms the framework. It is also protecting different organs. For example, we have ribs, which are bony structure, will protect our heart, our lungs. So it is basically giving you the framework as well as protecting you. Okay, what about cartilage? Where is cartilage present? It is present between the joints. It is present between the two joints. Also, it is present at the nose tip, also in our ear. Also, we can say it is present in the trachea as well as the larynx. So बच्चे, it is asked what's the location of the cartilage. I hope you got it. ठीक है? चलो जी, we are moving towards the last connective tissue and the last topic of the tissues chapter. बेटे tissue का last chapter है ये, last topic है ये, sorry. Last topic बच्चे, this is the last topic of tissues. Class 10 Swaraj, very soon the class 10th marathon will be coming. है ना? Today's day is for 9th class. ठीक है जी? चलो बच्चे, fluid connective tissue is blood. Blood is made up of two things, that is the cells, and cells are embedded in a fluid matrix. That fluid matrix is called as plasma. Plasma is the fluid matrix, and the blood cells. Beta, there are three types of blood cells: RBC, WBC, and platelets. RBC, WBC, and platelets. So, beta, what is the function of RBC? RBC provide red color to the blood, and why it is providing red color to the blood? Because beta, RBC have hemoglobin in it, and this hemoglobin beta provides red color to the blood. Acha, so hemoglobin is only doing one function, providing red color to the blood? Obviously no beta, it also transport the gases. It helps in the transport of gases. Transport gases. ठीक है बेटा? नेक्स्ट बच्चे, व्हाइट ब्लड सेल. बच्चे, व्हाइट ब्लड सेल का क्या फंक्शन है? व्हाट्स द फंक्शन ऑफ व्हाइट ब्लड सेल? इट विल प्रोटेक्ट यू फ्रॉम द हार्मफुल microorganisms. It will fight bacteria and viruses. It will protect you from diseases. Therefore we call them as beta soldiers of the body. They are soldiers of the body. Why we call them as soldiers of the body? Because they protect you from the diseases, as well as the last cell, that is platelet. But what is platelet doing? So it will protect, it will help you during injury. Let's say I am walking, running, and I fell down. So if I am bleeding beta, that blood is clotted by platelet. It will help in blood clotting. It will help in blood clotting. ठीक है बच्चा? Clear है? All these functions we have already discussed. चलिए बच्चे, let's discuss. एक दो questions करते हैं. Yeah, it's coming here. चलो जी, आंसर करेंगे इस पोल क्वेश्चन को. आंसर इट बेटा, क्विकली आंसर इट. चलो चलो चलो, क्विकली आंसर. Anji, what should be the answer to this question? Amit, what is this name? Ullu gang. Umar, Vishesh, Vineet, Amit. Acha ji, okay. Chalo, answer it beta. Done? A person met with an accident in which two long bones of the hand were dislocated. Bache, bone to bone is connected by ligament. So obviously, which among the following will be the reason? The ligament broke. Option number C. Yes. Only Amit answered. Only Amit has answered. Now Parth is also answering. Parth, I guess you wrote the answer little bit late. That's why the poll didn't take your answer. ठीक है? Maybe some technical error. ठीक है? So the answer should be better ligament break. चलिए बच्चे, answer this question now. चलो इसका आंसर दो. Write down in the chat section beta. Write down in the chat section. Write down your answer. Time over. The simple permanent tissue with the cell walls are thickened with pectin at the corner is collenchyma. Option number A beta. Okay, rightly answered. But Nayak and Amit has only answered and answered it correctly. Very good. Parth again. Why your answer is not getting picked up, Parth? Right answer though. Right answer by Batnayak, Amit as well as Parth. Very good, bache. Very good. ठीक है? चलो again beta, I am giving you one question as homework. Do try it. Intercellular spaces are absent in sclerenchymus tissue. Why? Because they have a cell wall thickening of lignin. We get a crunchy and granular feeling when we chew pear fruit. What should be the answer? Crunchiness is because of sclerenchyma. Branches of a tree move and bend freely. But they are able to bend. Bending. Flexibility is provided by Collenchyma. And but it is difficult to pull out of the husk of coconut tree because of sclerenchyma. Because of sclerenchyma. ठीक है बेटा, क्लियर है? डन? क्लियर? समझ आया? यू विल बी एबल टू डू इट. ठीक है बच्चे, एक छोटा सा ब्रेक विल बी टेकिंग. छोटा सा, विल टेक अ स्मॉल ब्रेक ऑफ 10 minutes and then we'll be back with the last chapter, that is improvement in food resources. बट ये हमारा टाइमर चल नहीं रहा है. सर की मदद लेंगे हम. सर, टाइमर चल ही नहीं रहा है. अच्छा, give us a but now we'll take a small break, then we'll be back with improvement. ठीक है? अच्छा आ गए. ठीक है ठीक है ठीक है. We'll be 10 minutes. ओके जी, see you in 10 minutes guys. Done? फिर 10 minutes बाद स्टार्ट करते हैं. I hope you have took your break, you have drank your water. If you wanted to eat something, you have done that. So we will now continue with the last chapter for class 9 biology, that is improvement in food resources. Guys, shall we begin? Hi Ayush, hi Kiran. So, bache, now it's the time to complete the last chapter for biology. We have completed the cell chapter, we have completed the tissue chapter. Now it's time for the last chapter, that is improvement in food resources. ठीक है जी? Now we'll begin with it. Now, सबसे पहले बेटा, what is food? Food is something which contain nutrients, that is carbohydrate, protein, fats, minerals, and why you are eating the food for the purpose of energy. From where do you get the food? You get your food from plants as well as from animals. But you know beta, since the population is increasing, day by day, there is demand for high food, right? We require more the people, more the individuals, more the population, more is the demand of food. That is, we have to increase the production of the food, but we have to do it in a sustainable manner. That is, we are not disturbing the environment, right? We are taking care of the future generation as well. Yes, but Nayak, why not, beta? Why not? So, bache, what is now crop? So, when the same kind of plant is grown on a large scale at a same place, this is called as crop. Now, beta, crops can be of different types. For example, cereal crops, for example, rice, wheat, maize, oat, barley. And bache, you get carbohydrate, that is sugars from your cereals. Cereals will provide carbohydrates to you. Remember, C for carbohydrate and C for cereals, right? So cereals provide carbohydrate. Then we have fruits and vegetables like mango, apple, cucumber, onion. And what is fruits and vegetables providing you? Vitamin and minerals. So fruits and vegetables provide you vitamins and minerals. Vitamin and minerals. Pulses, P for protein, P for pulses, that is, pulses provide you beta protein. Pulses provide you with protein. Example can be gram, pea, bean, arhat, soya bean. And lastly, beta, oil seed groups. The name suggests it will provide you oil. It will provide oil, beta, oil, fat. Mustard, groundnut, sunflower and castor are example of oil seeds crops. Ab bache ji, crops can be divided on the basis of the crop seasons as well. What is that? For example, bache, different plants require different climatic conditions to grow. That is, they require different type of temperature, different type of photo period. Photo means light and period means duration. So duration of the sunlight also influence the germination process as well as the fluorescence. So this thing, that is photo period, the duration of sunlight, is also influencing the growth of the plant, right? So based on the basis of the seasons, we have two types of crop, kharif crop and rabi crop. Kharif crop is also called as monsoon crop, beta, because we are going to grow it in the monsoon season. But if we talk about the rabi crops are winter crops. Remember that. Rabi crops are winter crops. So remember, kharif crops, they are sown in the month of June but harvested in the month of September. On the other hand, rabi crops are sown in the month of October and harvested in the month of March. Some examples are mentioned of kharif and rabi crops. ठीक है जी. Hi Naruto B edits. Hi Ji, hi, hello. Okay, that was about the different types of the crop. Now beta, we are obviously improving the variety of the crop. We are improving the yield of the crop, right? And how we are doing that? We are doing that by 3 steps, that is crop variety improvement, crop production management and crop protection management. Variety, that is, we are taking a good variety of the crop, that is, it should be drought resistant, it should be cold resistant, right? It should not catch disease easily, it should give you high yield. That is, we are increasing the variety, we are improving the variety of the crops, right? So this we can do with the help of hybridization. That is, we can take two plants which are dissimilar. Let's say one is having high yield and one is disease resistant. We take two plants and we make a cross between them so as to produce a hybrid plant having characteristics of both. ठीक है? So we are taking two plants, that is one having high yield, let's say one be disease resistant, and we are making a cross between them. So the hybrid which will be produced, it will be better disease resistant as well as it will be having high yield. So a hybrid is produced by the process of hybridization. But it is of three types: intervarietal, interspecific, intergeneric. So intervarietal beta between the two species. Intervarietal will be between two species. Intervarietal is between two varieties of a crop. Interspecific is between two species, and intergeneric will be between two genuses. ठीक है? Mendel pea plant cross, Amit Singh, that is in class 10th, उसको अभी हम नहीं करेंगे, right? It's in heredity chapter of class 10th. Hi Vinod and Pragati. Hi, good evening everyone. चलिए जी. Now genetic modification, बच्चे, we are incorporating a desirable gene so as to have desirable characteristics. That is your gene modification. And lastly, beta, for what factors you are improving the variety? How you are doing that? We are doing that. How we are improving the variety? I am telling you that now. We are increasing the yield, right? We are improving the quality as in we want in pulses crop the protein quality should be high. In oil seed crops we want the oil quality should be high. Very first thing. Last is biotic and abiotic resistance. That is biotic factors, that is maybe the diseases, the pest, they do not harm my crop. And abiotic means non-living factors like temperature, moisture, they do not harm the crops. ठीक है? Change in maturity duration. Maturity duration is the duration between the sowing and the harvesting time, and obviously that should be uniform so as to minimize the loss as well as to increase the economic. Tell the top 5 subjects for class 12th. Beta, we are not talking about class 12th here, we are taking class 9th, improvement in food resources chapter. ठीक है? 10th नहीं पढ़ रहे हैं. This chapter is of class 9, that is improvement in food resources, beta. ठीक है? Wider adaptability, that is they should be adapt in different situations, and lastly they should have a desirable characteristic. For example, we want the tallness and branching in the case of the fodder crops, and we want the cereal crops to be dwarf so that they consume less nutrients. ठीक है जी. Lastly, beta, crop production management, that is once they are growing we are taking care of them by nutrient management, irrigation and cropping patterns. अब beta, what you have to discuss in this? Now बच्चे, सबसे पहले manures and fertilizers को we'll have a look at it. Yes, today we are only discussing class 9th, beta. Absolutely. And no, beta, if you are still in this delusion that this chapter is deleted, it is not, beta. It is not. ठीक है बच्चे, we talk about manures are organic substance, we know that. ठीक है, it is not rich in specific nutrients, we know that. It is bulky, therefore it is very difficult to use transport, right? Also beta, it is eco-friendly, it is very cheap, you can prepare it in your factories. But if we talk about the disadvantage, beta, it is bulky, not easy to store, transport. It has less nutrients, that is it is less concentrated, it contains less nutrients, right? They are not easily absorbed by the plant, as I've told you. They are not nutrient specific and hence they are required in large amount. ठीक है बेटा, इतने points clear है. Then we talk about the types of manure, that is the compost and green manure. ठीक है बच्चे, please clear this topic is not at all deleted from your CBSE. ठीक है? If you feel it's deleted, if your school is saying that, you follow whatever your school is saying that. I am teaching for the CBSE students who, in those students in which this chapter will be coming, right? So for the students, this chapter will be coming in their exams. I am teaching them. Okay? If it's not part of your subject, you're from class 10th, 11th, 12th, this is not for you guys. Okay? Chalo. अब बच्चे compost beta, once we are putting the waste in a pit and letting it to form manure, we are leaving it to form manure by the process of decomposition. This process is called as composting. Once we do it with the help of earthworms, we call it as vermicomposting. अगर earthworm की help से कर रहे हैं, vermicomposting. Next we have green manure. Green manure is like बेटा पहले we grow a plant, then we plow it into the soil, and then we grow another plant. This is your green manure, because the plant which we grew first, that will be converted into manure. Since the green plants are converted into manure, we call it as green manure. ठीक है? चलो जी. Fertilizers, beta, you know, they are nutrient specific, they are chemical substances, they are prepared in factories, they are nutrient specific, right? So it is required in beta less amount, right? It is concentrated. We require fertilizers in less amount, but remember, it will cause pollution. It will cause water pollution. It will cause soil pollution. So it is not so good for our environment. ठीक है? चलो जी. So manure difference and fertilizer difference, you all know that manure is a natural substance. It's synthesized in factory. It's a chemical substance. It is having low nutrient content. They have a higher nutrient content. They have humus. Fertilizers do not have humus. Manure is eco-friendly. It's not causing pollution. But yes, fertilizers, they do cause pollution. And also we can say manures are very bulky, they are easy to difficult to transport and use, but on the other hand, fertilizers are very light, they are not as such bulky, so they are easy to use, easy to transport, and easy to store. ठीक है? चलो. But therefore, since fertilizers can be very issue, it's a very problematic for us, right? It can cause issue to us. Why it's causing issue to us? Because it is causing pollution. Therefore, we are coming with the organic farming, where we are using less chemicals or maybe no chemicals while doing our farming. That is, we are using biofertilizers as well as biopesticides. Biopesticide, for example, at home your mothers use neem leaves or turmeric while storing the grains. What do? They act like a pesticide. They kill the pests, they kill the insects. And biofertilizers, we are using green algae, blue-green algae, cyanobacteria as our fertilizer, that is to provide nutrients, to provide nitrogen to the soil. Amit beta, to say good things about you, ab अच्छे से first you study very nicely, then I'll say good things about you. ठीक है? चलो. But now we talk about cropping patterns. There are 3 types of cropping patterns: mixed cropping, intercropping, and crop rotation. But mixed cropping is we are taking 2 or more crops and we are taking the seeds of those 2 crops and we are mixing those seeds and then randomly sowing them. And now we have taken 2 or 3 crops, we have mixed the seeds of those crops and we are randomly sowing them, therefore mixed cropping. Intercropping is once we are taken 2 or 3 seeds, 3 types of crop seeds, and then we are placing them in rows, right? We are placing them in rows. Let's say in this row I have grown maybe soya bean, है ना? One row is of soya bean, then next row is of maize, okay? Next row is of maize. Then second, third row will be of soya bean. So once we are growing crops, 2 or 3 crops, but in rows, in rows in definite pattern, then we call it as intercropping beta. And what are the advantages of these two crops? Again, there is no risk of complete crop failure. It will increase the yield, as well as we can say the variety of products can be harvested. Also, we can say pest infestation kam ho jayega. Pest will attack less because they will rarely find the same crop nearby. Okay? Similar will be there in the intercropping, but also we can say intercropping is a better method of mixed cropping, because in mixed cropping there is issue of harvesting which is resolved during intercropping. ठीक है जी? But see, this is a online class. Beta, if you want to go to washroom, please go. Do not ask me. Okay, go. Hello. Hi everyone. Good afternoon. Chaliye ji bache. So mixed cropping, intercropping, a difference you already know. I am moving ahead. Bache, irrigation. Irrigation beta is supplying of water to the crops. But why do we require to supply water to the crops? What do we get from this water? But now I have to ask a question from you, and I am giving you as homework. So do write down in the comment section what is the importance of irrigation. I'll give you one example. For example, if we provide water, we'll get hydrogen, we'll get oxygen. So you have to write down in the comment section what are the importance of irrigation. ठीक है? चलें आगे. चलो. But rain-fed agriculture, but what is happening nowadays, that majorly in India, the agriculture is dependent on the rains for the purpose of water. That is, from the rain, the plants are going to get their water. That is rain-fed agriculture. So if proper rain is coming, then the growth will be good. But if drought is there, that is, rain is not appropriate, the growth will be poor, right? This is simply rain-fed agriculture. Next, bache, irrigation system. From where do we get the sources? What are the sources of water? From where do we get the water? From the wells, canals, river system and tanks. Lastly, beta, crop protection management. We are protecting our crops. From what we are protecting our crops? We are protecting our crops from the pest. What type of pest they are? Either they're going to cut the root, stem and leaves, that is, they're of chewing type, or they can be of sucking insect, that is, they will suck the cell sap from the plant, or beta, they can be borer insect, that is, they will make a hole in the plant parts, right? They will make a hole in the plant parts. ठीक है? अब बच्चे 20 क्लियर, चुपचाप बैठ के पढ़ लो, है ना? पेपर लीक हो रहा है, that's good for you. You are getting great questions from us. You are able to write your answers properly. Your board exams will be starting in 5 days, not even 5 days, because today is 10th and on 15th, I guess your board exam is started of English, right? You should be focusing on your exams. Borer means the insects which are going to bore a hole, make a hole in the plant parts. Let's say in the stem, they will make a hole. Okay. Next, bache, how we can control these insects pests? For example, insecticide. Bache, side means to kill. Side means to kill. So insecticide which kill the insect. Fungicide which kill the fungus. And bache, herbicide which kills the herbs. Right? Clear hai? Whatever side means to kill, and whatever word is written before it, we're going to kill that thing. Insecticide kill the insect, fungicide kills the fungus. ठीक है जी? For example, weedicide kills the weeds. Leishmania's organism which causes kala azar beta. हाँ बच्चे, weeds क्या होते हैं? What are weeds? Weeds are unwanted plants, undesired plants, uncultivated plants that you have not grown, and obviously beta, you have to remove those weeds, and the removal of the weeds is called as weeding, है ना beta? The removal of weeds is called as weeding. The weeds removal is called as weeding. Remember this. Okay. Some of the examples of the weeds are mentioned here. For example, xanthium, parthenium, cyprinus rotundus. And bache, why do you remove the weeds? Because they can be harmful. They can compete with the main crops for the nutrients, for the space, for the water. So they're going to compete with the main crop and hence will affect the growth of the main crop, and therefore we are supposed to remove them. Okay, ji? And how we can prevent it? Prevention we can do by various cropping methods which we have seen, the intercropping or the crop protection. Also proper seed bed preparation, timely sowing of the crops can be used to prevent the weeds. Bache, if you don't know which chapter is this, I don't think you can study, है ना? आप पता ही नहीं है कौन सा chapter चल रहा है, so आप नहीं पढ़ सकते, है ना? This is improvement in food resources class 9. If you don't know it, that is you are not in class 9. That is this class is not for you, है ना जी? And if you really want to study, if you are not even a part of this class, then please study with honesty, है ना? Do not disturb the class. ठीक है? चलो. But pathogens, what are pathogen? Disease causing microorganisms are called as pathogens, and they can be transmitted via the soil, via the water, via the air. ठीक है जी? Now, because once we are storing our grains, we have to make sure we are protecting them from the insects, rodents, fungus, mites, bacteria, that is from the biotic factors. Also, we are protecting them from abiotic factor, non-living factor, that is temperature and moisture. You will be like, ma'am, why? If they get infected, then what will happen? But remember, their color will change, the size will decrease, the weight will be decreasing, the marketability will be decreasing. So, all of these things will be affected. ठीक है जी? Therefore, how we can prevent this? We can prevent this by proper drying them, proper cleaning the grains before storing. And once we are storing, then also we have to take care that is they are not infected by any pest or any pathogens. ठीक है? अच्छा जी. Last topic पे हम आ गए हैं for today's class, that is animal husbandry. That is we are taking care of animals. Taking care, that is we are taking care of their diet, taking care that they are not catching any diseases, right? We are taking care that we are protecting them with giving them a proper shelter, giving them proper food to eat, right? So that is we are taking care of the animals so that we can get something from them. Now what we can get from the animals, बच्चे, सबसे पहला cattle farming. बच्चे, we are raising the cattle for obviously milk, है ना बेटा? कैटल से क्या मिलता है? मिल्क. एंड द एनिमल, द कैटल्स which gives us milk, they are called as milch animals or dairy animals. ठीक है? If they give us milk, they are called as milch animals or dairy animals. Or also बेटा they can be used for the farm work, for the labor purpose. So those are called as draught animals. ठीक है? So there are two types of cattle which we can see here. That is the cow as well as buffalo. Scientific name of cow is Bos indicus. Remember, scientific name of buffalo is Bos bubalis. अब बच्चे indigenous breed, that is the local breed. What is the characteristic of local breed? बेटा, that they will not catch the disease easily. But the exotic breed, that is foreign breed, they will be producing more milk. So why don't we do one thing, that we make a hybrid that is having characteristic of both, that is having a longer lactation period as well as they are excellent resistance to the diseases. But this is the table of the different indigenous breeds of cows and buffalo. Do remember it, the question can be asked. ठीक है? Done? बच्चे, yes, this is the last topic beta. ठीक है? So as I've told you, the milk production depends on the lactation period, that is the period of production from the birth of the canal, right? What's the duration of the milk production after the birth of the canal? oh sorry, not canal but the calf. I'm saying canal, calf. ठीक है? After the baby has born, what's the duration of the milk production? Simple. ठीक है? अब बच्चे, how we are taking care of them? We are cleaning them properly with the brushes. We are removing the dust, dirt. We are giving them proper shelter. We are giving them proper food, as well as we are taking care of the health of the cattle. Health of the cattle. Next thing, बच्चे, is poultry farming. बच्चे, poultry farming is we are raising the birds for two purposes, for the egg and for the meat. If we are using the bird for the egg, they are called as layer. Egg laying bird is called as layer, whereas we are using them for the purpose of meat, we call them as broiler. We are using them for the purpose of meat, we call them as broiler, but if we are using them for the egg purpose, we call them as layer. ठीक है जी, clear है? Done? Ma'am, I am in 8th age records. This is for class 9th beta. For class 9th. ठीक है? चलो, चलें आगे. Shall we move ahead बेटा? चलो. So बच्चे, again, Indian breeds is example is Asil, or on the other hand the foreign breeds is Leghorn. Again, बच्चे, the new varieties with new desirable characters include, beta, what are the characteristics? We are increasing the number as well as the quality of the chick. We are getting the dwarf boiler parent, that is dwarf means small heighted parent, right? Next, that is they should be having an adaptation to the high temperature. But this class will only be communicated in English, not Hindi and other languages. I'm sorry, no Bengali, no Hindi, nothing. ठीक है जी. Last बच्चे, how we are taking care of them? We are giving them proper shelter. The shelter should have proper temperature as well as proper hygiene. It should not be dirty. Second thing, we are giving them proper food. That food should be beta protein rich and having some fat also. Also, it will be included with vitamins. Vitamins include vitamin A and vitamin K. ठीक है? Okay. Next, we move to the poultry diseases. That is, we are protecting our poultry birds from the diseases as well, that is from the viral diseases as well as bacterial diseases, and we can prevent the diseases. We can prevent that these diseases are not going to infect our poultry birds with the help of vaccines. Vaccination. ठीक है जी. Lastly, बच्चे, fish production. We are catching fishes because fishes give us a lot of protein, and it is considered as a cheap source of animal protein, right? How we obtain the fish? By capture fishing and culture fishery. And what's the source of the fish? The sea water and the fresh water. ठीक है जी. And yes, from the marine water we can catch our fishes as well as with Nayak, I'm only using English. I'm not even using any other language, beta. ठीक है? चलो. Okay. All right. So we are coming back to it, bache, and now how we can catch those fishes? We can catch those fishes with the help of fishing nets. We can catch the fish using fishing nets, and those fishing nets will be attached on the fishing board. Let's say this is the fishing board, and there will be a fishing net attached to the fishing boat. And how we can catch a group of fish? We can catch group of fishes with the help of echo sounders as well as satellites. With the help of echo sounders as well as satellites. ठीक है बच्चे? And yes, inland fisheries, fresh water, brackish water. You know fresh water. What is fresh water? And what is marine water? Marine water is, beta, you are asking everything. Ma'am, class 10th, class 10th, class 10th, class 10th, class 10th, bache will come up with a marathon for class 10th also very, very soon. But this class is specifically devoted to class 9 students. That too only English medium, because for the students who don't know Hindi, this class is dedicated only and only for those students, not for class 8th, not for class 10th. ठीक है, चलो बच्चे, composite fish culture is where we are growing different types of fishes in a single pond. In a single pond, we are growing different types of fishes. We are taking care of different types of fishes. What's the benefit of it? We are taking the fishes in such a way that these fishes are not competing among themselves. There is no competition for food among themselves. That is, if one fish is surface feeder, one fish will be bottom feeder, right? For example, surface feeder example, catless. Middle zone of the pond will be eaten by the rohas. Bottom feeders will be mrigel and common carps, and the fish which feeds on the weeds is grass carps. So we are taking different fishes which have different food habits in such a way that food of all the pond will be utilized. Food of all the pond will be utilized. ठीक है जी? Done इतना. Shall we move ahead, beta? Okay, let's move ahead, beta. Next, बच्चे, integrated fish culture. Integrated fish culture where we are doing a combination of rice crop along with growing the fishes. We are growing, could you see fishes here, beta? छोटे fishes. So we are growing rice crops along with the fishes. Therefore, the word integrated fish culture. Aditya, what's the doubt? लिखो तो. What's your doubt? Be clear, the chapter is about to end in 10 minutes, right? We'll cover our class of today. We'll wrap up today in 10 minutes. Okay? So, bache, where we are combining the rice crops along with the fish culture, this is called as integrated fish culture. That is, we are doing the two things together. And lastly, beta, beekeeping. Beekeeping, simply we are rearing our bees for the purpose of honey, right? We are getting honey from the bees. Chalo ji. Okay. Now again, beta, indigenous breeds includes Apis cerana indica, which is Italian bee. Not Italian bee. Italian bee, beta, is Apis mellifera. Please remove it, है ना? Correct करेंगे इसको. This is not Italian bee. Italian bee is, beta, Apis mellifera. This is your Italian bee. Let's correct it. ठीक है बच्चे? So what are the indigenous breed? That is the local breed. So the local breed includes Apis cerana indica, Apis dorsata, as well as Apis florae. But if we talk about, beta, exotic breed, the foreign breed called as Italian bee, that is Apis mellifera. Now what was so special about Apis mellifera? That is, it is having high yield of honey. It gives high honey collection capacity. It will sting you less, but it can still protect itself from the enemies. It will sting less, but it can still protect itself from the enemies. Also, it will stay in a beehive for a longer duration. It will stay in a beehive for a longer duration. Very, very important. ठीक है? चलिए guys, please focus here. So remember why we are choosing Apis mellifera. All right. And lastly, beta, yes, we are taking care of the bees in a apiary where we are taking care of them so that the honey can be collecting for our purpose. Bee goes to the flower, they collect the nectar and then ultimately make the honey. ठीक है जी? ठीक है? चलो guys. But these are the 3 questions. Though I have given you the answer, but I want you to try them. Okay? I'll hide the answer. I'll hide the answer because I really want you guys to try this question. Okay? I'm giving you these questions as homework. Do try down these questions. Therefore, I'm hiding the answer. So 1, 2, and 3 questions are homework to you. Though I've given you the answer, but don't use them until and unless you have written down the answer by yourself. ठीक है जी? So बच्चे, that was all for today. ठीक है? In today's class we covered cell, tissue as well as improvement in food resources. I have given you total, I guess, 5 homework, 5 questions as homework, which is not a great deal. It's a very, very simple, easy peasy thing which you can do very easily. ठीक है? No, user XYZ, you cannot use chat GPT to answer it. मैंने स्कूल वाली मैम के, आई डोंट नो विद बेटा आशीष, आई एम सॉरी, आई कांट हेल्प यू विद इट. इफ आपने स्कूल मैम के आंसर नहीं लिखे तो लिखे. ओके बट नायक, फाइन. ठीक है? That's it then, beta. That was all about biology. Now chemistry ma'am Rachita ma'am will come and she will cover the chemistry part. Okay? Physics is done, biology is done. Now you guys will start with your chemistry part. Okay? Physics, bio done. Now you'll start with chemistry part. Alright guys, thank you so much for your time. Keep learning, keep shining. Bye bye. Shall see you soon. Take care.
Hello people, welcome to the session. I am Rachita Sarjeev and I take your chemistry session on a very prestigious platform of Physics Wala. I hope some mast honge, so mast honge. Do let me know in the chat box if I am clearly audible and visible to you all. Come on guys, quickly do let me know if I am clearly audible and visible to you all. Hi, good evening, Bethany Ghosh. Oh, that's so sweet. Hi, from Kolkata. Hi, good evening, NDA aspirants Sachin Sharma. भाई कहाँ से लिखते हो तुम लोग? Oh, thank you so much, Bethnik. Appreciate that. Thank you. So, Well, guys, so as you already have seen sections of bio and physics, now it's time to solve some chemical locha together. So we will be doing the entire revision of all the chapters starting from matter in our surrounding, is matter around us is pure, atoms and molecules, structure of atoms. Not only that, we will also be doing some practice questions. In between, I will be giving you the important topics. Those are the topics from where mostly questions are asked. I will be giving you the marking of those important topics as well. So keep your pen and paper handy and keep your Josh on the top. So before we begin with the session, quickly let me know, how's the Josh, man? How's the Josh? Kya boli public? Come on. How's the Josh? Is it high? Is it still high? Because I know you guys are studying a lot, your exams are coming, you're loaded with so many revisions, practice papers, but still I want you to be with high energy. In between, I will be definitely giving you 2 Kit Kat breaks, and where you can do all your personal business, have your snacks, do whatever you want to do. So yeah, we'll be taking little breaks in between, so don't worry. Chapter 2, oh, that's so sweet. Good. I hope everything went well. Nice, nice. Good to hear that. Okay, Ji. So we will be covering all 4 chapters as discussed and practice questions. So practice questions will be done at the end. So after entire revision, it would be easier for you to solve questions and relate with each and every concept. So let's begin with our very first chapter, matter in our surrounding. Okay, I'm from Jaipur, Rajasthan, but I take all your sessions from Bangalore. Tell you. Let's begin. So we will be discussing everything from the scratch. Basics will be covered, but in between I will be asking you questions as well. So please be very attentive, because I will be I really want you to be proactively answering me the things. That is a best revision one can get. So as we learn about matter in our surrounding, wherever you are sitting, there are a lot of matters you're surrounded with, whether it's your pen, whether it's your table, or it's you yourself. Other than that, you have air which you breathe in, laptop, and whatnot. So you are surrounded with matter. Anything which occupies space and have mass is called as matter. So this pen is a matter. It occupies space and has some mass to it. So that's matter. Alright guys, now as we're talking about matter, but what matters are made up of? Matters are made up of chotu particles called as atoms. So yes, atoms are the building block of matter. Now, as we're talking about characteristics of particles of matter, they are continuously moving. Continuously moving bole to what we call it as cool. All right. So, continuous moving bole to simple term में kinetic energy, right? It's a very important term from where you usually get questions. So, kinetic energy से you get reasoning questions like how come diffusion takes place, how you get the smell of hot food rather than cold food to a certain distance, how you are getting a smell of incense stick. So a lot of reasoning questions are connected from this particular characteristic, which is the continuous movement called as kinetic energy. Now moving on, space between particles. So every matter will have space between them. Depending on matter to matter, space might vary. Like if we talk about solids, there would be a negligible space. But guys, please understand this. You cannot write no space kind of thing, because there is nothing 100%. You will going to write negligible space, not no space between particles. So in solid, it's a negligible space. In liquid, space will going to increase, and in gases, spaces would be highest. Now, because spaces are more, definitely there would be a difference in force of attraction. So if more space is there, force of attraction would be least. If there would be very less space between particles, then the force of attraction between particles would be strongest. So moving on to the third point, that means they attract each other. Attraction could be very less or attraction could be too much, that depending from matter to matter. So these three are very, very important characteristics, or I would say the fundamental characteristics of matter. Now, looking at the examples here, diffusion is where you get questions from reasoning question. Diffusion se aata hai. Not only that, guys, diffusion ka definition they ask, or they can also ask you this in MCQ question. So be ready with the definition of diffusion. Understand this particular term. Diffusion bole to intermixing of particles. Intermixing bole to, can you please explain me in very, very simple terms? Intermixing of particles bole to, like it's about 5. Something must be cooking in your kitchen. Tell me, what is cooking in your kitchen? What kind of smell you are getting right now from your kitchen? Let's see. क्या बन रहा है तुम लोगों की kitchen में? Come on. Yeah, you will get. Yes, Petnik, you will get. Come on. Oh, that's so sweet of you. Solid boss, come on. Diffusion. What's cooking in your kitchen? Nothing. Okay. So I think in office I'm getting a very nice fragrance of coffee and tea. So how am I getting coffee and tea ka khushbu? In fact, in some of the kitchens, it must be Maggie, right? If Maggie is cooking, you get that fragrance so easily. But how is that so? So particles of the food gets into the air, diffuse with the particles of air. Why? Because particles of air are very far apart from each other. So they are quite welcoming. So other particles will intermix into each other. They travel to your nose and that's how you get a fragrance. Now imagine you are just moving out from Pizza Hut, or you're just passing by Domino's or a very nice restaurant from where you are getting a nice khushbu of paneer tikka or maybe butter paneer masala, right? So that's how you get it, and that's diffusion. But diffusion is happening because of the kinetic energy. So kinetic energy is high only if temperature is high. So with the increase in temperature, kinetic energy would going to increase. Temperature increase karte hi particles will have a to and fro movement. They will start randomly moving, and so kinetic energy increases. Once kinetic energy increases, the random motion of particles will going to increase. So motion will going to increase, and that results into diffusion. So diffusion will happen only if there would be a movement of particles, right? So that's how we do it. Particles of matter are continuously moving. If ink is dissolved into water, potassium permanganate dissolved into water, and food or incense stick, so everything is dependent upon diffusion. Hi Shivam. I don't remember, yaar. It's been long back. It's something in 90s. For sure. You're most welcome, Bethnik. Most welcome. Okay, Ji. Moving on to the next one, they have spaces between them, and how we can explain that by giving an example. Now, let's say we have added some ink into water. So, ink will be dissolved into water. How come? Because particles of water will going to give the space of ink to get into that. So if there are spaces between particles which is higher, definitely they'll be able to fit into that space very, very easily, and dissolution rates will going to increase. Now if I say honey in water or ink in water, which will dissolve faster? Come on, that's a simple question. Very, very basic practical question. If I put some ink into water, and in another glass if I put honey into water, which will going to dissolve faster? Ink? Definitely it's ink. Why? Why ink will dissolve faster rather than honey? Honey will dissolve, that's okay, but that will going to take time. Rate of diffusion would be little higher, right? Rates would be slower, I would say. Why ink will dissolve faster? Now here comes another concept, and that's density. So guys, to dissolve into something or to get into the spaces of other particle also depends upon density. Yes, so density, if it is higher, that will going to take time to dissolve. If density is lower, density bole to thickness. Honey is more denser than ink. So honey would take more time to dissolve into water as compared to ink to get dissolved into water. So density also plays a huge factor in getting into the spaces and diffuse or dissolve. Moving on to the next property, next characteristic, and that is they attract each other. So yahan se you usually get some examples to put them into increasing or decreasing order. Now, one of that would be honey, right? That's a very basic question. It's also given in your NCRT. Wood ho gaya, then it would be air, है ना, या फिर exhaust. So if I ask you to put that into increasing order of force of attraction, then how will you put that? Increasing order of force of attraction. For which one, Aditya? Which one? Density wala. So agar aap ek cube lete ho, if you take a sugar cube or you take just sugar dust, then which will dissolve faster? That's another example. ठीक है जी? Okay. So which would be having the highest force of attraction? Highest force of attraction. Highest force of attraction. Hi, Rabi Fashion. See guys, so now as questions are asked in this part would be an increasing and decreasing order. The basic mistake that you guys do is to put an order. So I'll take you back to grade first standard में क्या पढ़ के आए थे? If you put this arrow, that means we are representing increasing order. And if you're putting this sign, that means you're writing decreasing order. Open crocodile mouth. Have you learned this way? Open crocodile mouth from left to right would be increasing order. And if you're putting a tail or a closed crocodile mouth from left to right, that would going to represent decreasing order. So my question to you is to put this in an increasing order. Okay, Betnik. Yeah, it will be coming soon. 10th wala would be coming soon. Come on, come on, come on. Increasing order में क्या लगाओगे? सबसे ज़्यादा would be wood, right? Because particles are too close to each other. So force of attraction would be highest. Because of that, wood is solid. So wood would be having the highest force of attraction, and then it would be honey. And lastly, it would be air. Is that clear to all of you? That's how you will be putting them in the increasing order of force of attraction. Now, if I want to ask you about decreasing order, in that case, air would come here. It would be different sign then it would be honey, and then it would be wood. Correct. Absolutely right, Bethany. But please remember the signs that you're using, because that's where commonly you guys make mistake. So please take care of those signs. Chali. Now, as we are already talking about the characteristics of states of matter, you all are aware about 3 basic states of matter, which is solid, liquid, and gases. And these 3 are usually focused in your exams. Solid, liquid, gas. Solid ko we write it as S, liquid will be mentioned as L, and G would be small g would represent gaseous state. So, as we all know, solid ka particles would be too close to each other. Very close to each other, having a negligible space, whereas liquid ka particles would be little far apart, and gases would be like long distance relationship. So as of long distance relationship, force of attraction would be very less. And if you are having a friend who lives just next to your house, who's your neighbor, that's like solid. You will have a solid relationship with them because you will be meeting with them every day. Force of attraction would be high. It's not like gases which have a long distance relationship. All right, guys, moving on. This is where question comes into picture. Now, they can either ask you directly to give a differentiation between solid, liquids and gases, 3 marks, right? 3 marker question, easily they can come up with. And that would be a straight question to differentiate between solid, liquids or gases. Or else they can ask you reasoning questions from force of attraction, reasoning question from the volume part, reasoning question from like for example rubber band. Rubber band is actually solid. Then how come it can be stretched? How will you answer that? Is rubber band solid? Is rubber band solid? Yes. Why? Why it is solid even though you can stretch it? So these kind of simple questions can be asked in your paper depending from this particular table. Yes, but it is solid. But question is why it is solid? Mostly English. Okay, please, team pay, please. Sure, Vanshika, I will definitely pass on this. I will definitely pass on. Okay, so why it is solid? As we stretch rubber band too much, and if we leave that force, it will come back to its original state. So as it comes back to its original form, that's why we consider them as solid. Solid question, boss. Bethany, question was why rubber band is solid even though you can stretch it. Because in solids, compressibility is least. That's what you have learned. Particles are too close to each other, the compressibility would be least. Then why you consider rubber band as solid? So the answer to that is you can stretch rubber band. Once you leave that force, that comes back to its original shape. So that's your keyword. You have to mention that statement. It comes back to its original form. Therefore, it is considered to be as solid. So let's go through this table quickly. Solids ka fixed volume. Obviously, if we take this as an example, it is having a fixed volume. Volume cannot be changed. Shape will always be fixed. Whereas if we talk about liquids, that is also having fixed volume, but gases ka volume is not fixed. Shape for the solids would be fixed. For liquids, it will not be fixed because if I put it into a different container, that will going to take the shape of the container, and same goes with the gases. Intermolecular spaces. So because particles of solid are too close to each other, space between them would be least. Gases ke andar space would be more, and maximum space would be there in gases. So as we're talking about space, let's talk about force of attraction because these two are interrelated to each other. Because particles are close to each other, force of attraction would be higher. Particles are little far from each other, force of attraction would be less. And if particles are too far from each other, then interparticle force of attraction would be least. Moving on to the movement of molecules. Obviously, if I ask you to stand very close to each other, you can maximum do a to and fro movement. You cannot move around, right? So that's solid. Kinetic energy would be least in solids, but as you get little space, you can little bit move. That's liquid. In case of gases, it would be a solid movement. Why? Because particles have large space between them. So they can run around, they can have a gala time, they can randomly move around. So those are gases. Hi, May, good evening. Not compressibility, Bethany. We will be talking about stretchability in rubber bands. Fluidity. Obviously, solids cannot flow. They are quite rigid. Rigid bole to akdu. Those who does not want to bend even after external forces applied, such are called as solids and they are rigid. Whereas if we talk about liquids and gases, they can flow. And that's why we say river flow, right? Or air flow. So both gases and liquids can flow. On the basis of compressibility, it is directly connected with the intermolecular spaces and force of attraction. So compressibility would be least in case of solids because I cannot compress it. In any case, I cannot compress it. If I compress too much, I would breaking this up, which I'm not going to do that. So in case of liquids, they can be compressed. So Holi is very nearby. How many of you like Holi as a festival? That comes with a lot of practice. That's so sweet. I don't know. Come on. Come on, guys. Jaldi se batao. Quick, quick, quick. Anyone loves Holi here? Is anyone's favorite festival Holi? And I know it always falls in between exam. I hate that thing. Yeah. So what we do in Holi, we make water balloons, and inside water balloons, we try to put some colors which does not go off very, very easily, right? So obviously that can be compressed. Water balloons can be compressed, whereas gaseous balloons can be compressed even more. So if you go to birthday parties nowadays, they have a very fancy decoration where they compress balloons, they make different beautiful shapes out of gaseous balloons. How is that so? Because of the compressibility. So gases are highly compressible as compared to liquids, and solids are least compressible because of the interparticle spaces. Okay, moving on to diffusion. Solids show a least diffusion, I would say. Then slight diffusion would be in liquids, and gases would be highly diffusible. Along with that, try to always give some examples along with the diagram. So if this question comes for 3 marks, let's say they ask you directly to differentiate between solid, liquids and gases for 3 marks, give 3 points. Example would be separate. Please don't add example as your 3rd point. That's not correct. It will not be acceptable. 3 marks bole to you have to write solid 3 points. Then give example along with diagram. And that's how you will get your full marks. Don't give them any space to lose or to cut your marks. Give your best, give your 100%. Gulal, you play with good. Okay. Nice. Yeah, I know nowadays we are more aware about not wasting water. I get it. Okay, Ji. Moving on to interconversion of state of matter. Can solid be converted into liquid or liquids be converted into water? Give me one example which is there at your home. Give me one simple example of interconversion of state of matter which you can visibly find it at your own place, in your home, in your kitchen. Hi, Yaksha. Hello. Come on. Yeah, simple eda. Eyes, Bethnik. High five. Good job, huh? Good. Yeah. Yes, that is also acceptable. Ice. So water can be converted into ice, and water can also be converted into a gaseous state. So what is it? Is it a physical change or a chemical change? Let's see if you can find this out. It's a physical change or a chemical change. So water in a liquid state, that if we start with ice, water in a solid state converts into liquid state and then it's converted into gaseous state. Is this a physical change or a chemical change? Oh, okay. My name is Rachita Sachdeva. Physical change. Absolutely right. Absolutely. Hats off. How come it's a physical change, not a chemical change? Why we consider it as a physical change? Because no new substance is formed here. Water was there in solid state, water is there in liquid state, and water is there in gaseous state. Water is still water. H2O is still H2O, no matter what physical state it has been turned into. So H2O is H2O, chemical composition remains same, and that's why it is considered to be as a physical change, not a chemical change. Or if I ask you one more question, fermentation of grapes, कोई सीधा बच्चा नहीं है. Fermentation of grapes. What is it? Physical change or a chemical change? Yes, it is reversible change as well. That's right. Fermentation of grapes. That turns into alcohol. Yeah, that turns into wine. Wine is alcohol. Now go and ask your parents, Mummy, Papa, can I have wine? See their reaction. And if you ask them, Mummy, Papa, can I have grapes? See their reaction. Right? It would be a chemical change. Now, if you ask them to consume wine, they'll give you a flying chappal. Dur se chappal urta hua aayega. But if you ask them, can I have grapes? They would be very happy. Arey wow, my bacha needs to eat fruits. My bacha wants to be healthy, right? So that kind of a reaction change will give you an idea about a chemical change, boss. So it's definitely a chemical change. Grapes are fruits. It has a different properties. But once it turns into wine, it has entirely different properties. So such kind of change would be called as chemical change. Okay? First chapter, Piyush. First chapter. All right. Moving on to the further part of interconversion of state of matter. So as solid would be converted into liquid, that would be called as melting point, right? So if ice converts into liquid water, we will call it as melting of ice. And if liquid turns into gaseous state, that would be called as boiling. But does it happen at a particular temperature? Yes. Melting happens at a very particular temperature depending upon the substance. So substance to substance temperature varies. So as you get a lot of questions related to conversion, Kelvin to degree Celsius to Kelvin is a very basic question that you get in your paper. Please give me the example in the chat box. Give me the formula to convert degree Celsius into Kelvin or Kelvin into degree Celsius. Come on. Give me the formula. Come on. Cool. All right. Yeah, Rahul, I am. Come on. Just a simple formula to determine Kelvin from degree Celsius or degree Celsius to Kelvin. Okay, Parth, is that correct? That's right. Formula. Celsius is equals to Kelvin plus 273. Piyush, chotu sa difference hai. There is a little mistake that side. Little chotu mistake. So it would be Kelvin equals to degree Celsius plus 273. That is correct. And please do not forget to put degree before Celsius, but there would be no degree in front of Kelvin. That is something which is important. If you put degree in front of Kelvin, you will straight away get 0. Okay? So please remember this presentation. Kelvin does not have degree in front of it, but Celsius do have degree. Now, melting is also called as fusion. Remember the alternative names because questions are usually asked on the basis of the alternative names. Melting is known by 3rd grade also. Melting would be even known by 4th grader. But fusion is an alternative term of melting which you should be knowing because in your paper they usually ask you questions related to that. Like latent heat of fusion. You don't say latent heat of melting, right? So we use latent heat of fusion. Fusion bole to melting, conversion of solid to liquid state at a particular temperature, which is its melting point. Based upon that, let's move on to latent heat. What does latent means? Aviral, smelting is a part of grade 10. We are dealing with grade 9. I will be soon taking your grade 10 marathon. Then I will be discussing this. Cool? ठीक है अविरल? All right. आशीर्वाद लेने आया. Okay, Avinash. तथास्तु. God bless you. Do well. चलिए, moving on to latent heat. Latent बोले तो hidden. Latent means hidden. And what's hidden? It's the heat which is hidden. But how come? How does that work actually? So it's magic. Let me show you. So let's say we have a container filled with ice. Okay? And in that we have placed a thermometer. Thermometer states as minus 5 degrees Celsius. So the temperature of ice comes out to be minus 5 degrees Celsius, and we are heating this container. Okay? Heating is done continuously without break. We are heating this container. So what will happen eventually? As we are heating it, temperature increases. Temperature increases, so that should be shown on the thermometer. Obviously. Okay, so as we are heating it, temperature reaches to 0 degrees Celsius. That's fair enough. But problem is, at 0 degrees Celsius, it got constant. There is no rise in temperature on the thermometer, but we are heating the system. That's weird, guys. That's weird. As we are heating it, 0 degree become constant. It's not increasing, but at this point of time, solid is converting into liquid state, and that's when we call it as melting point of ice. Melting point of ice would be 0 degrees Celsius, because at this point, solid is converting into liquid. It's a continuous tense. Solid is converting into liquid state. That's melting point of ice, which is 0 degrees Celsius. Now, once conversion has taken place completely, once it's converted into liquid, temperature would again start to increase. But where is latent heat gone? See, the heat which is not used up in increasing the temperature on thermometer will be hidden into the system, consumed in overcoming the force of attraction. So solid ka force of attraction was strong, right? So that hidden heat in the system, which we call it as latent heat, will be consumed in overcoming that force of attraction and go far apart. Those particles will overcome and go far apart from each other. This helps in the conversion of state of matter from solid to liquid, and this is called as latent heat of fusion. I hope that's clear to all of you. Yeah, solid clear, boss. Piyush ji, tell me exactly where you are having a problem. I'll repeat for you. Come on. Solid, cool. Now, once it turns into liquid state completely, temperature starts rising up and reaches to 100 degrees Celsius. Now, problem is, again temperature got constant. Oh God, it's so weird. We are heating the system and still temperature becomes constant on the thermometer. Where is the rest of heat going? So, rest of the heat will be hidden in the system, used to convert liquid to vapor state, and that's when we call it as latent heat of what? Latent heat of dash. Why there is no rise in temperature and melting? So that's Piyush, latent heat gets hidden in the system, which is consumed in converting these states. And how they are consumed? By overcoming, by breaking that force of attraction and turning from one state into another. I'm repeating the same thing, Piyush, here in the boiling point also. So now this is called as latent heat of vaporization. What is called as latent heat of vaporization? So as temperature is not increasing on the thermometer, the hidden heat in the system will be consumed to overcome the force of attraction and turn into vapor state. Liquid be turned into vapor state. And what is the boiling point then? Boiling point of water would then be 100 degrees Celsius. So what is the boiling point of water? 100 degrees Celsius. What would be the melting point of ice? 0 degrees Celsius. That should be on your tips. Cool? Cool. Okay. Now, looking at the most important, very important graph. Now, usually in board exams, you get one of the question related to this graph, and sometimes they'll give you this graph in the question and give you respective questions related to the graph. It's also given to you in the back exercise of your NCRT. Please take a look. It's super important question. It's very important. Very important. Okay? So looking at this particular graph, it states that it starts from -5. As we are heating it, it's between temperature and heat. So temperature rises, it reaches to a certain point. It reaches to a certain point where it becomes constant, 0 degrees Celsius. That's called as melting. Now, once it starts melting, it converts into liquid state from solid to liquid. It again starts increasing with the temperature and reaches to a point which is again constant, 100 degrees Celsius, which is called as latent heat of vaporization. And then again, it will be increasing the temperature after the conversion from liquid to gases. I hope that's clear. Cool, 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 cool. Yes. That's so nice of you. Baitnik, that's so nice of you. So please remember, this particular graph is super duper important. Super duper important. Piyush Babu, this is actually our English channel. So I am extremely sorry that I won't be able to explain you in Hindi entirely. I'm sorry. I hope that's clear, boss. Okay, so as we've already discussed about types of latent heat, one is called as latent heat of fusion, other is called as latent heat of vaporization. Sometimes they ask you direct definition. Secondly, they will ask you questions related to the graph. Thirdly, they ask you questions in assertion reason part. They ask you an assertion reason. They can ask you about the definition of latent heat of vaporization or latent heat of fusion. And thirdly, the most important one, graphical questions from this part. I hope I made myself very, very clear. What type of questions can be asked from this particular part? Note it down. In fact, you have given so many class tests. You have given so many tests in your school related to this chapter. You know that what type of questions can appear in your paper as well. Give me a thumbs up in chat box if you all are on same page. Solid, clear, boss? Give me a thumbs up if it's clear till here. Yep. Come on, people. Kya boldi public? Yes, solid. Okay. All right, boss. On that positive note, let's start with the interconversion of state of matter based upon two conditions. What are the two conditions required to convert one state into another? Let's talk about it. Two conditions which are required to convert one state into another is temperature and pressure, right? Temperature helps to convert solid to liquid, liquid to gas, and coming back from gas to liquid, liquid to solid. In fact, solids can directly be converted into gaseous state, or gaseous state can directly be converted into solid state. So all of this can be done independently by the help of temperature. Pressure also plays a very crucial role here. Pressure can also help to convert one state into another, but please remember, pressure cannot work independently. Temperature can work independently to convert the states, but pressure requires the help of temperature. So with the help of temperature, pressure can actually work to convert from one state into another, whether it's solid to liquid or liquid to gas or vice versa. So let's take a look here. That's a very common term you all are learning since your childhood, and that's sublimation. What is sublimation? Sublimation bole to conversion from solid to gaseous state without turning into liquid state. So a direct conversion from solid to gas without converting into liquid state, it's called as sublimation. And reverse of sublimation If it's converting from gaseous to solid without converting into liquid state is called as deposition. So these two terms are opposite to each other. Sublimation ka opposite would be deposition. In some of the books, it's written as desublimation, which is not technically correct. So please don't write desublimation. Try to mention deposition. I can give you one very clear example for that. I wish that you get a chance to perform this in your laboratory as well, because it's so nice to watch an experiment like this. Let me tell you this. Okay, we have ammonium chloride. Ammonium chloride is a white color salt. Ammonium chloride is one of the sublimable solid which is white in color. So what we do, if we put this into a watch glass and we heat this, okay, and cover this watch glass with inverted funnel, and this funnel will be blocked with the cotton. Now, as we are heating ammonium chloride present in it, which is originally in solid state, because it's a sublimable solid, it does not convert into liquid state. It directly converts into gaseous state. So, gaseous state of ammonium chloride would be formed. But the problem is, there is no space for gas to escape. Why? Because we have blocked it with a cotton bud. So what will happen? It will going to reverse it again. So once we heated it, solid convert into liquid state, but as it cools down, as does not get a space to go out, it will start cooling down, and once it cools down, it will start depositing onto the surface of this funnel. And you know what, guys? They create a very thin, colorless needles. Yeah, very sharp, colorless needles will start depositing onto the surface of the funnel. And that's treat to watch. That is so beautiful. I wish you get a chance to see this experiment, to do this experiment in laboratory. So please ask your teachers to show this one to you. It's really nice. So that's how sublimation actually work. Now give me 3 examples of sublimable solid. Chemical locha? Yes. Come on, give me 3 examples of sublimable solid. One is ammonium chloride, done and dusted. Next. Come on. Yes, it can be, Piyush, it can be. How can gases be liquefied? That is based upon the pressure. Pressure maintained along with the temperature. I'll come to that later. Camphor, yes, but chotu sa mistake is in the spelling. Camphor is one sublimable solid. Then what else? Iodine. Iodine are purple color crystals which are again sublimable solid. Naphthalene balls are also sublimable along with the ammonium chloride. Yeah? Cool. Alright guys, let's solve some more chemical locha. Now, as we are talking about conversion from gas to liquid, Piyush, you have asked me a question that can we actually liquefy gases? Yes, we can do. So I have given you 2 points. There are 2 ways to interconvert one state into another. One is temperature and other is pressure. So pressure plays a crucial role here. Now, if you've seen LPG cylinders in your kitchen, that is liquid petroleum gas. Gas and liquid, 2 states are present in one. Liquid petroleum gas, that's LPG cylinders. So those are being filled at a very high pressure and low temperature. So if we are increasing the pressure, if pressure is increased, temperature needs to be decreased. So this is how pressure will going to work. Pressure cannot work independently. We have to take help of temperature. We have to maintain temperature as well along with the pressure to convert from one state into another. That's how we can liquefy gases. So those cylinders are packed at very high pressure and at low temperature. That's how they will be converting gases to liquid and vice versa. Okay, I hope that is clear, Piyush. Clear, boss? Okay, so as we are now talking about change of pressure, there is another very common example that has been asked in your paper is about dry ice or solid carbon dioxide. How many of you been to marriages, to shadis where it's very fancy? Bride and groom is entering and there is lot of dry ice flowing like a fairy tale wedding. Have you seen such kind of weddings, or maybe seen in movies? Yeah. Oh, is it so? Check. Hello. Is it clear? Bethany, now it's clear. Yeah, you have seen. I have also seen such weddings in pictures, also in reality, also. So, that kind of wedding is actually created by using dry ice. Not only that, nowadays there is a very fancy way to give you ice creams. Yeah, in restaurants, dry ice is also used as a way of presentation. But that is not good for your health. It is quite dangerous. Little bit of dry ice inside you can burn your gut, because that is at a very very low temperature that your body cannot resist. So please stay away from that dry ice. Do not touch it with your bare hand, and do not even try to eat it. It's a very very dangerous to you. So now, talking about dry ice or solid carbon dioxide, why it is called as solid carbon dioxide, or why it is called as dry ice? That could be one question for 2 marks. Why we call solid carbon dioxide as dry ice? Why we call solid carbon dioxide as dry ice? Come on. The reason here is because it is one of the sublimable substance. Sublimable substance bole to solid or gaseous. Let's say carbon dioxide is originally in a gaseous state, right? To convert it into solid state, we have to increase the pressure. Extreme pressure needs to be increased and temperature needs to be decreased extremely. That converts directly into solid state without converting into liquid state. So as there is no liquid state, it's dry. There is no rocket science in this. It's a simple one. Because there is no liquid state in this particular stage, so we will call it as dry ice. That's it. That's the only reason. So this can be converted, solid carbon dioxide can be converted into gaseous state by decreasing the pressure and increasing the temperature. Okay, so the one which is used in shadis, in marriages, they bring it into a container. So dry ice is brought into the container. Once it is opened, pressure is released. Pressure will going to decrease. Environmental temperature, because of that, temperature will increase, and that would again convert into gaseous state. So that fairy tale wedding that you see is because of the solid carbon dioxide converts into gaseous state. Cool hai boss? Cool, 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 cool. I hope that concept is now clear. So this is where again your question comes in your paper. That's the very, very common diagram you all have seen in your NCRTs. Not only that, there is a question in the back exercise of your NCRT. Now, how questions are asked, they will give you this in a form of ABCD, kind of a fill in the blanks, and you have to fill out the conversions here. So, if liquid convert into gaseous state, what it is called as? It should actually be called as vaporization, not evaporation. Evaporation is different, vaporization is different. Vaporization is actually also called it as boiling. Okay? Gases to liquid state is called condensation, and solid to gas directly it's called sublimation. Gas to solid is directly called as deposition, and so on. Please remember the alternative names also, like melting is called as fusion, right? Freezing is also called as solidification. So please remember the alternative names for the conversion from one state into another depending upon the temperature. Yeah, so Petnik, vaporization is boiling. Boiling is vaporization, but evaporation is entirely different. Now, it could be very, very confusing. I will come to that topic soon. Under evaporation, I'll explain you this part. So what happens is evaporation is also conversion from liquid to vapor state. And in boiling, or which we also प्यार से call it as vaporization, is same conversion of liquid to vapor state. But condition for conversion is entirely different. In case of evaporation, it starts from the surface. So it's a surface phenomena. Boiling or vaporization is a bulk phenomena. Okay? Evaporation takes place at any temperature below boiling point. So like for example, if you have a glass of water in front of you, or I have a bottle in front of me filled with water, evaporation is going on. We cannot see that because it's a very slow and a continuous process, but it's going on. It goes below boiling point of water at any temperature. Whereas in boiling or in vaporization, we require a particular temperature. And that's when we call it as boiling point, depending from material to material. If we are using water to boil, if you are boiling something else, that boiling point might vary. Solid clear, boss? Now, evaporation is a continuous process. Boiling is not a continuous process. I hope this is clear. So, there is a slight difference, thin line difference between evaporation and vaporization. So, you cannot use these terms vaguely because there is actually a difference. Now, another part from where you get questions are the factors which affect rate of evaporation. Rate bole to boss, speed. Speed of evaporation. How will you learn that? There is a simple trick to learn these factors, and that's what? What is what? What is a simple term which helps you to remember these factors. W say bole to wind speed. Yeah, H means humidity. A bole to surface area or area, and T means temperature. So these are the four factors which affects rate of evaporation. Evaporation takes place from the surface. It starts from the surface. So we call it as a surface phenomena. Right? Yes, absolutely. Absolutely, Betnik. So using what? These are the four factors. So as temperature increases, rate of evaporation increases. Surface area increases, rate of evaporation increases. Wind speed increases, rate of evaporation increases. But in case of humidity, it works inversely proportional to each other. So if humidity increases, rate of evaporation decreases. What is humidity? What is humidity? Humidity bole to the content of water moisture present in our environment. Like for example, Chennai, right? Anyone from Chennai? Anyone from Goa here? I think Kolkata also have lot of humidity. So as humidity increases, drying up clothes become harder, right? You don't get to dry your clothes very easily. Okay, Vetnik, I didn't knew that about Kolkata that much, but yeah. Chennai is a very, very humid place, and to dry up clothes is hard. Why? Because the moisture content in air is too much that as rate of evaporation will going to decrease drastically with the increase in humidity. Lot of loo. Oh, okay. So it's winters there or it's summer. All right. यहाँ तक किसी को कोई doubt, कोई शक? कोई doubt, कोई शक? Now, another set of questions that can be asked from evaporation part is about how or give reason if we pour acetone on the skin, will it cause cooling? So, evaporation causes cooling. Yes, absolutely. How evaporation causes cooling? Let's talk about it. Let's talk about it. Okay? So how does evaporation causes cooling? It completely depends upon the latent heat. Now, how many of you have used acetone or nail paint remover? No judgments. Any one of you have ever used nail paint removers? Humidity in Hindi, Mohit, we call it as umas, where we have a lot of chip, we have a lot of sweat during summer season. That's humidity, when air has a lot of content of moisture in it. That's humidity. It's just started, Bethnik. It's a marathon, boss. So you will stay with me till the end. Hi, Moksh. Hello. Come on. Have you ever used nail paint remover or acetone? So now if you ever pour acetone on your skin feels cooler. Why? Why it feels cooler? Because as soon as acetone gets on your skin, that takes away the latent heat of your body, the extra heat of your body, and that makes it feel cooler. Or I give you another example. Let's say you are sweated, you're completely sweating, and air comes. You feel cooler, right? That blow of a wind that makes you feel cooler. How is that so? So the sweat on your body will going to vaporize, and that takes away the latent heat or the extra heat of your body that makes you feel cooler. And that's the same scenario happens on the earthen pot. Why water remains cooler inside the earthen pot? Or why the roof becomes cooler if you sprinkle some water? These are the questions which are commonly asked in your paper. So please be ready with the answers for such questions. I am not sure, Bethnik. Okay, boss. I hope that's clear to all of you. So why we wear cotton clothes in summer? Because it's soothing, or because it's airy, or because it's porous. So we wear summer clothes we wear cotton clothes in summer because cotton is quite porous and it absorbs your sweat. So as your body is exposed to the outer environment, and it takes away the latent heat of your body, that makes it feel very cooler, and that makes you feel comfortable as well. Okay, boss. I hope yahan tak everything is clear, sorted. Yes, Betnik. Absolutely, that's correct. Hats off. Good. Hi, Kailash. Hi. Clear hai, boss? Koi shak, koi doubt, any questions? Feel free to ask. Hi, Vinod. Hello, Ji. Chale, do you want a break or we can continue? Just sip some water, take some energy, have some milk. Yes, Radhika, please. I'm glad, Bethany. Yes, Radhika. Chotu Kit Kat break. All right. So I'll give you 1 minute, and after 1 minute, we'll resume the class, okay? 1 minute break, more than enough. We have just started. We'll be moving on to the next chapter now. So quickly go, have something to eat and come back. During your class break, entertainment, nothing is required. Vinod, we are done with the first chapter, matter in our surrounding, and now we'll be moving on to our next chapter, which is matter around us is pure. Ha, why not, Bethany? Buttering, huh? Okay. All right, come on. I'm waiting. Next chapter, Radhika second bache is matter around us is pure. Oh, that's so sweet of you, Bethnik. Yeah, we don't. Let's wait for people to come. Yeah. All right. Let's move on to our next chapter, that is matter around us is pure? Is matter around us is pure? I don't think so. I don't think so now. Okay. So, as we're talking about is matter around us is pure, we are not actually talking about the adulteration that is happening. Like, for example, this ghee is adulterated, so it's not pure. No, we are not talking about that. We're actually talking about elements, compounds, mixtures, right? So, in terms of scientists, adulteration is not something purity that they are talking about. They're talking about on a different tangent altogether. So let's take a look here. We all have learnt about physical states of matter. Based upon the physical property, we have seen that there are three states of matter: solid, liquid, and gases. But based upon chemical composition, matter is classified into two types. One, we call it as pure substance, and other we call it as mixture. Now, what are pure substance? What are mixtures? I will going to explain you this in a very simple language. So understand the concept, and based upon that, you can write it in your exams in your own language. Pure substance means the one which is made up of single type, or I would say one kind of substance, which are made up of one kind of elements. That means it's a pure substance. When we talk about mixture, there would be two or more elements or molecules that will be combined together physically, and there would be no change in the physical or chemical composition. That's when we call them as mixture. So we will going to deal with them one by one. Mixtures are further of two types: homogeneous and heterogeneous mixtures. That's where question comes for 2 marks. And what is the difference between elements and compounds? Are elements further divided into something? What's the difference between compounds and mixture is another 2 mark. Very important question, frequently asked in your paper. Difference between compounds and mixture. So we will be dealing with each and everything in the upcoming part. So let's talk about pure substance. Pure substance which consists of single type of substance, maybe element or compound. For example, I have a bottle filled with water. So that means that bottle has only water in it. Water bole to H2O, 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 H2O. Millions of H2O compounds would be there, or millions of H2O molecules would be there. So that's a pure substance for me because it is consuming only one type of particle, and that's H2O. Whereas if I talk about H2O plus NaCl, now let's say I have a container mixed with NaCl with water. It's not a pure substance anymore because we have two compounds here combined together. So it is not a pure substance, it is a mixture for me. But a container filled only with water, that is a pure substance. And if I say I have a rod of iron, so that is made up of iron purely, and there would be million of iron elements in that. So that is also a pure substance with me, for me. So that means elements and compounds are pure substances. Until and unless that compound is not mixed with anything else, it's a pure substance. So pure substance include elements. Elements bole to metals, non-metals, metalloids. Whether I talk about oxygen, chlorine, fluorine, bromine, iodine, sulfur, phosphorus, nitrogen, calcium, iron, gold, copper, aluminium, etc., they are all pure substance. They are all elements including metals, non-metal, metalloid. Compounds like sugar, that is C12H22O11. So what is the formula of sugar? Sugar is C12H22O11. So it is made up of this compound as a whole. It's a pure substance. Whereas if I talk about glucose, glucose has a formula of C6H12O6. So entire glucose is made up of millions of this formula. So that means it is also a pure substance. Water is a pure substance having formula H2O and so on. Is that clear? Yeah, yes. Yes, Radhika, I now remember. Come on, clear है boss? यहाँ तक everything is super duper clear. Now, as we talk about mixture, mixture is a substance which consists of two or more pure substance. Like for example, we mix milk with cereals. Cereals is a different thing, milk is a different thing, but once we mix them together, that will be called as mixtures. Mixture is a mixture of two or more pure substance. God's it really true? Yes, yes, that thing. That's the formula for sugar. It's true. Okay. Now, next important part where question lands up, compound and mixture ka difference or pure substance and mixture ka difference. So, pure substance made up of single type of substance, mixtures are made up of two or more pure substance without changing chemical property. I'll give you one very simple relatable example. How many of you love to eat namkeen, mixture namkeen, Haldiram mixture namkeen? Anyone? Me? Anyone out there who loves to eat namkeen? Yeah? That's so nice. Come on. Namkeen means it's a savory. It's a savory which you eat with chai, with tea. It's a mix of so many things. That's namkeen. Haldiram packets, if you've seen, which has peanuts in them, which has some small chips in them. It's a mix of so many things. Hi, Vansh. No, not bhujia. I'm talking about mixture namkeen, mixture savory. So there are a lot of things added into it, but even though they are mixed together, you will not going to feel like their taste has changed or their properties have changed. So if I like peanuts out of it, I will pick up peanuts and can eat it. So it can be separated very easily. Hand picking can be done. So separation of mixtures is easy, whereas in case of pure substance, they cannot be separated so easily by physical means. So that's another difference between pure substance and mixture. I'll give you one more example. Fruit mixture. Fruit mixture. A salad. I would say a fruit salad. So it is mixed of so many fruits like guava, oranges, grape, apple, strawberry, and so on and on and on. Now let's say I don't like apple. Let's say. So I will just pick apple, keep it out, right? Or I will bribe my brother to do my work and I'll give you apples and so on, right? That's something we all do. So that is again a mixture. So we mix a lot of fruits together, but every fruit retain its own property. So there will be no changing of chemical property that will happen in a mixture. Even though we are mixing them, their original property would be retained. Guava when mixed with grapes has guava ka properties. Grapes will have grapes ka properties. And we can separate them very easily, even something we don't want out of it. Pure substance has its own definite property, whereas mixtures ka property of the original components will remain same. There would be no change in the properties even after we mix them. That's mixtures. Okay, I do always bribe my brother to, okay, I'll do your homework, I'll do all your files, just eat this or drink that glass of milk and so on and on. I'm not giving you any ideas, okay? Don't take those ideas from me. Vansh Rachita Sachdeva Bache. Okay, now as we're talking about mixtures, there are two types of mixtures, homogeneous, heterogeneous. I'll give you two examples, find it out which is homo and which is hetero. Okay? Oil in water, sand in water, which is homo, which is hetero. Come on. Oil in water, sand in water, which is homo, which is hetero. Which is heterogeneous mixture, which is homogeneous mixture. Oil and water, sand and water. Betnik, Radhika, you both say sand and water is heterogeneous. Hi, Utkarsh. Come on. What about oil and water? Is oil and water completely mixed into each other? Oil and water is homogeneous. Oh, but no. No. Soil and water, soil, no. Sand in, I'm saying sand and water. Both are heterogeneous. Da, hey, Mataji. Guys, sand in water, oil in water, they will be layered up. They will be layered up. They will not mix. There would be no uniform composition. No uniform composition. Can be separated. Can be separated. Shows Tyndall effect. Shows Tyndall effect. Particle size is greater than 1000 nanometer. OMG, guys, they both are heterogeneous mixture. They both are heterogeneous mixture. I was just trying to confuse you and you just fall in the trap. Okay, guys, you cannot be made that fool very easily. You just fall into my trap. Oh, okay. Both are hetero. Yes, they both are hetero, Betnik. That's right. All right, so now let's look into the difference of heterogeneous and homogeneous. Homogeneous bole to when they form a uniform composition throughout and particles are not visible. Ink dissolved into water, salt dissolved into water, sugar dissolved into water. You cannot identify that. Now, if I give you two glasses, sugar with water and salt with water, you have to taste it to identify that because those particles will not be visible that easily. So those are solutions. Solutions are homogeneous. Homogeneous are solutions. So they will have uniform composition. Particles are not visible, cannot be separated by filtration. Now imagine you are sitting and separating salt from water. See, if you're doing that, your parents would think that you're wasting your time, you're doing nothing. And because particles are completely dissolved, you cannot separate that. And please don't even try that at home because your parents would think you've gone mad. Don't do that. Then stable, they are stable. How come they are stable? How come they are defined stable? Because even you keep them undisturbed, particles will not settle down at the bottom. So they are quite stable. Good, very good decision, Betnik. Path of beam of light is not visible. That means it will not show any Tyndall effect. There would be no scattering of light. So that means there would be no Tyndall effect in case of homogeneous mixture. Whereas if we talk about examples, sugar in water, salt in water, lemonade, tea, these are all examples of homogeneous mixture. Now, if we talk about hetero, it's all opposite. Non-uniform composition, you can see the layers from your naked eyes. Sand into water, chalk into water, right? Oil into water, they are all heterogeneous mixture. Cereals into milk is also one of the heterogeneous mixture. Salad, fruit salad, vegetable salad, they are also examples of heterogeneous mixture. They can be separated by filtration, mostly unstable. Once you keep them, they will settle down at the bottom. Path of beam of light is visible. That means what? That means they were going to show you Tyndall effect. And these are the examples here. Cool? Cool? It's okay. That's okay. So I hope that's clear. These are the examples and I have no intention to make your mouth water. So I'm so sorry. These are the examples of homogeneous and heterogeneous mixtures, both. Okay? Now you can have your food once I'll give you a chotu sa break. Now, as we were talking about homogeneous mixtures, homogeneous are nothing but they are true solutions. True solutions are homogeneous, homogeneous are true solutions, and their examples will also be common. Ink in water, tea, lemonade, and so on, they are all considered to be as true solutions. Now, how solutions are made? That's another question. Assertion, reason mein they can ask you in MCQ. So, solutions are made up of two major components, solute and solvent. Now, can you please easily tell me what is solute, what is solvent in one line? Come on, just one line. Hi, Doug. In one line, what is a difference between solute and solvent? Solute and solvent. What is solute? What is solvent? Oh, nice, Surya. Then it's a very good time for you to revise. Ekdam fati revision. Solute is water, no Surya. So, solvent is a medium in which solute gets mixed. Or in simple words, Surya, just do the opposite. Solvent is the one which is present in larger quantity. I would say the one which is present in larger quantity, larger amount is solvent. Solute is the one which is present in chotu quantity, smaller amount, that would be your solute. Sugar in water. Sugar would be your solute and water would be solvent. Ink in water. Ink would be your solute, water would be solvent. And if I ask you one example, chalo, you will tell me, in tincture of iodine, that has already been asked in your previous year papers. Tincture of iodine, tell me the solute and solvent. Come on. Which gets mixed in a solvent? That's right, Betnik. That's okay, Surya. Tincture of iodine, solute and solvent. What is the solute here and what is the solvent here? Tincture of iodine. What is tincture of iodine? It is a substance which is used in making or healing anything. Yeah, if you have any scratch or something, so we put tincture of iodine that helps to heal, and it's one of the substance which helps to disinfect. Solute is iodine and solvent is water. No, actually solute is iodine, but solvent is not water, it is something else. Solvent is ethanol. Yes, it is alcohol. It is alcohol. Actually, I'll give you one simple relatable example. If you've seen movies where hero used alcohol, if he got any cut on the body, they'll open the bottle, pour alcohol on that. Have you seen this? Yeah, I have seen so many cheesy movies like that. So why they use alcohol? Why they use alcohol? Because it helps to heal. You've not seen that, Surya. There are so many movies out there where they use alcohol to put it on their scratches or anywhere they got cut. Yeah. So that is one of the disinfecting agent, I would say. So alcohol is used as a solvent here in tincture of iodine. It's an antiseptic basically. Alcohol helps as an antiseptic and iodine would be added up in a very small amount and that's your solute. That's tincture of iodine. So this is very important example usually asked in your paper. Please keep in mind about solutes and solvents. They really have asked this in your previous year questions as well. Okay, so now talking as we have already done with true solutions, now we are coming up with suspension and colloids. So in exams, they do ask you to differentiate between true solution, suspension and colloid for 3 to 4 marks. So be ready with those pointers along with the examples. It should be on your tips. Suspension. Give me simple example. Not me alone, Dark. It's a full team. So we are done already with physics and bio, and now I'm here for you. Come on, it's a teamwork. It's a teamwork. Come Come on, guys. Kya bolti public? So give me few examples of suspension. Chalk in water, yeah. Sand in water where particles are clearly visible, layers are clearly visible. Once you keep them undisturbed, particles are clearly seen and they will settle down at the bottom. Particle size would be greater than 1000 nanometer. That's when we call them as suspension. They are heterogeneous mixture. Particles are seen with naked eye, separated by filtration, simple filtration technique. They will settle down as they are unstable and they were going to scatter the beam of light. That means they were going to show the Tyndall effect. Okay? And as we talk about colloids have a different case. They are in the middle of solutions and suspensions. So how we define colloids? Colloids have a particle size of 1 to 1000 nanometer. They looks to be homogeneous, but they are actually heterogeneous, like milk. Looking at a glass of milk, we cannot find the layers in that. Looking at blood, we cannot see RBCs, WBCs, and platelets in them. That means they look homogeneous, they look uniform, but they are actually heterogeneous. They make a fool out of you because human eye cannot distinguish particles below 1 nanometer, right? So between 1 to 1000, you're not able to determine the particle size separately. So there is a method called as centrifugation which helps you to layer up or separate the particles in a colloidal solution. That's the way we can separate it. Like, I'll show you the picture. This is a centrifugating machine used in hospitals to separate blood particles. So blood has RBCs, WBCs, platelets. They use this machine that rotates really fast and that helps to differentiate the elements in that based upon density. So the one which is heavier settles down, one which is lighter be on the middle, and the lightest one would be layered up on the top. And that's how they do the further test. If they want to test RBCs, they will just take that portion. If they want to check your platelets, they will take that particular portion and so on. That's how the testing part works. And if you are taking chemistry and dealing with it in your college life also, you will be using this machine on your own. Yes, that's magic. Alright, milk is again a colloidal solution. It will show you Tyndall effect. That will going to scatter the beam of light, but particles won't be visible on its own. They cannot be separated by filtration, cannot be seen by naked eyes. They are heterogeneous but looks homogeneous. Do not settle down even if you keep them undisturbed. If you keep milk glass for 1 hour, that will not going to separate. Milk and water and cream and ice cream will not be separated on its own. They were going to show you Tyndall effect. They were going to scatter the beam of light. Yahan tak kisi ko koi shak, koi doubt? Any doubt still here? Or all good? Cool. Yes, absolutely, you can see that. Have you ever observed a ray of sunlight coming in your room and you see the particles in front of that? Yeah, we see it as a dust particles in the air. Sun ray is entering in your room, scattered in your entire room. A beauty. Have you ever observed this? Like this? Or this? Where light is crossing the canopy of trees, scattering. How that scattering happens, how that Tyndall effect happens, because of the particle size. So in case of suspension and colloids, particle size are big enough to scatter the light. So here also dew particles helps to scatter the light. And same goes in other cases also. Because of the larger particle size, light hits those particles and scatter. So in case of suspension and colloids only, they are able to show the Tyndall effect. Hi Puniji, this is actually English channel, Bitse. Yes, absolutely, I'll give you after this. Okay. So another question that comes into picture, what is the difference between saturated and unsaturated? Now there are numericals also which comes from this particular chapter. Be ready with the numericals. I will give you one numerical today to solve. So that won't be hard in your paper. That would be completely formula based. So remember the formulas, apply that, done and dusted, right? So now what is saturated solution, what is unsaturated solution, and what is solubility? Solubility, say you get question in your assertion reason, MCQ. Okay? Now saturated. I'm saturated, yaar. I cannot take any more. You might have heard this term in English. Saturated. Man, I'm so saturated. Please don't talk to me. Right? Saturated bole to I am done. Now I cannot take more. Same goes with saturated solutions when no more solute can be dissolved in it at any temperature. Not any temperature, at room temperature. So that's when we call it as saturated solution. Like for example, if I have a container filled with water and I've added 1 spoon of sugar, it will be dissolved. If I will add 2 spoons of sugar, it will dissolve. Now, if I add 3rd spoon of sugar, it will start settling at the bottom. Now, at this point, it would be called a saturated solution. No more solute can be dissolved in it. That's saturated. But till the time it is dissolving, it is unsaturated. So, the time at which solute can be dissolved easily in a given solvent, that would be called as unsaturated solution. That can dissolve some more of a solute at a given temperature is called unsaturated. Clear, boss? Solid. Why Tyndall effect? Because of the particle size. Because of a particle size. Okay? Okay. Now it's numerical time. Yes, chemistry also have some numericals. Okay, ji? It's not like only physics have numericals. So in chemistry, after removing your mole concept, this is the only part which is left where we can ask you numericals. I don't like why they remove mole concept. I really don't like that. But okay, you guys are in your luck that mole concepts have been removed completely. So now let's move on to the numerical part by the concentration of solution. Concentration of solution bole to kya? Let me ask you one question here. I have a beaker filled with water, okay? And I have added 1 spoon sugar in that. I have another beaker filled with same amount of water. Let's say 1000 ml of water in this beaker. Another beaker also have 1000 ml. First beaker, second beaker. And here I have added 3 spoons of sugar. Which will be more sugary, or I would say which would be more concentrated? First beaker or second beaker? Which would be more concentrated? It's general. Sanjana, it's general. Neither organic nor inorganic. That would be divided in grade 11 and 10th also some part. Which is more concentrated? Second beaker, Bethnik? Are you sure? Hi, Surya. So, second beaker is more concentrated, more sugary. How did you decide that? How did you decide that this is more concentrated or this is more sugary? How? On the basis of the solute, right? On the basis of amount of solute, you have decided that second beaker is more sugary, or I would say second beaker is more concentrated. So concentration of a solution is decided by the amount of solute which is added in a given solution, right? So this is the definition. Let's take a look. Concentration of a solution is the amount of solute present in the given amount of solvent or solution. And that's what we are doing it in the formula also. Concentration of a solution is equal to how much amount of solute you have added into amount of solution. So amount of solute divided by amount of solution. Now amount could be in form of mass, right, in form of grams, or it could be in form of volume like ml, liter, right? So amount could be in any form. Depending upon that, we have two formulas: mass by mass percentage and mass by volume percentage. There is third, that is volume by volume percentage. Now, what formula to be used depending upon the question? You should understand from the given part in the question that which formula needs to be applied. So let's try one question here. Let's try this question, guys, and tell me which formula needs to be applied. In question, they've already given you, but if it's not given, then how will you identify? You have to answer this in 3 steps. First step would be what is given in the question. Okay? Second step, what you will be writing is the formula that you will be using. Third, you will be substituting the values and solve. Find the final answer, put it into a block and write answer. That's how you are going to present your answers in your paper. Not only in grade 9 but in higher grades also, this is the same pattern which works. First is what is given in the question. A solution contains 60 grams of NaCl and 400 grams of water. 60 grams of NaCl, chotu quantity, will be your solute. Bigger quantity would be your solvent, right? Because solution is made up of solute and solvent only. Calculate the concentration in terms of mass and mass. How come you have decided mass by mass? By looking at the units. Both are given in grams, so we will be using mass by mass percentage. So what is given in the question? Let's write it down. Mass of NaCl, which is solute, is given as 60 grams. Mass of water, which is your solvent, is given as 400 grams. Formula: mass by mass percentage is equal to mass of solute divided by mass of solution into 100. Percentage here, so we'll multiply with 100. Yes, absolutely. Yep. Give me the final answer, Betnik. Try to solve it and give me the final answer. Okay, so now next step would be substituting. We have to calculate mass by mass percentage. What is the mass of solute? Already given in the question. 60 divided by mass of solution. Please don't make this mistake. It's the silliest mistake that children do. Rather than writing the mass of solution, they just mention the mass of solvent. Solvent plus solute will be a mix of solute. That will going to create you the solution. So it's 60 plus 400 into 100. That means 60 divided by 460 into 100. And that would give you dash percentage. Is that clear to you all? Yep. Solid, clear, boss? Find the answer and do let me know in the chat box. That's how you will be solving it. And once you got your answer, put it into a box and write answer to it. Follow these steps. Why I'm saying this? Because your checking is done on the stepwise basis. By chance you made any calculation mistake, so your teacher should have a scope to give you marks somewhere. So they will give you marks for the steps if your answer is incorrect. Is that clear? Yeah. Final one. Give me the one with decimals. No, Bethany, 15 would not be the answer. Come on, yaar. Yeah, chalo. Let's take a chotu break, है ना? And we'll be back in 2 minutes. 2 minutes का break लेते हैं. Let's see if I have timer. किधर है भाई? Chalo. 2 minutes starting now. All right, guys, we are now back with a bang. I hope you all are energized again, have eaten something, drank something, went to do your personal business. 13.04, Bethnik. It's 13.04. I hope you're getting the same answer. Yeah? Getting the same answer? All right, guys. So, how's the Josh? How's the Josh? Now we are moving on to our last two chapters, atoms and molecules and structure of atoms. So, before we begin with that, let me give you a real picture here that these two chapters are quite important if it comes to your grade 10 as well. Now it's no time when you all will be moving on to grade 10. All borders will be there. So you should know that what are the chapters who are directly connected with your grade 10. So the concepts, the foundation of last two chapters of your chemistry are connected with your grade 10. So to remember 1 to 20 ka atomic number, to know what are neutrons, protons, electrons, how these numbers work, valency, valence electrons, how to make formulas, these are the most important part that will be highly useful in your grade 10, especially if I come to valencies, if I come to the charges, ions and formula making. Without this, you won't be able to solve many questions, many questions of your grade 10. So keep this foundation quite strong. Today also I will help you with some tricks and tips to remember the valencies, to remember the atomic masses. So yes, I'll be giving you some tricks today. Chali, Josh is high but little low. Arey, why low, yeah? Why low? See, you have a chance to just finish up your entire syllabus in one go. Like chemistry is done after this. You have to just read it before your paper. Energy should be like high, man. Should be very high. All right, guys, drink something and back from the back. Let's start with atoms and molecules with hi Josh. Let's solve some chemical lota together. Chak de fatte. Oh, that's so nice of you, Bethnik. Then to bhai thoda low banta hai, but still I would request to keep your Josh high and keep your pen and paper handy. Drink something, have something in between. All right, G. So as we're talking about atoms, we have already seen that atoms are the building block of every matter. Anything which you're surrounded with is a matter which has space, which occupies space and have mass. They consist of atoms, chotu atom. You know what? A single piece of paper has a millions of atoms stacked to it. Just imagine a paper, thin paper, one paper, millions of atoms stacked together. That's amazing. That is so strange yet amazing. So the building block of all matter are atoms, in which are so small, unimaginably small. You cannot see them with your naked eyes, definitely. So millions of atoms stacked together to layer up one paper, one single piece of paper. Now, this is something which is quite important. This conversion can be asked in your paper in your 1 marker. 1 nanometer is equals to 10 to the power minus 9 meter. Don't forget that this particular conversion not only be used in your grade 9, but it's also used in your grade 11th and 12th. Not 10th, but 11th and 12th also has a usage of this conversion. So yeah, that's important. Chalo. So now moving on to further part, atoms. How do they actually look, or I would say how we represent them on paper? So coming back to our a person who actually started talking about atoms, and that was none other than Mr. Dalton ji. It all started way back in some century. Maharshi Karnaji came with a word called as Parmanu, the smallest particle that comes from a matter, right? That was called Parmanu. Later on, Democritus Eusebius gave a term called as atom. And after that, for 2000 years, no one talk about atoms anymore. Guys, we are living because of atoms. This whole universe is existing because of atoms. And for 2000 years, this was completely ignored. Then later on, our own hero comes into picture, Mr. Newton, and not only he introduced atoms to us, but he also introduced some of the symbols for atoms, which were quite strange. Like, who will remember these symbols for atoms, da? How can we remember that hydrogen looks with a circle and a dot? Phosphorus looks like a P structure. Like how? Even Dayton-ji might have forgotten after making these structures or the symbols for atoms. They're not at all reliable. We cannot use them into a reaction. They are not feasible at all. And because Dayton-ji tried to give some symbols, because he was so overconfident at that time, because after 2000 years Dayton-ji came up with the atoms ka theory and he became quite famous. Then he thought, yeah, why not, I'll give the symbol for atoms also. But everything does not goes successfully. So symbols for atom was unsuccessful business for Mr. Dayton-ji. Later on, Berzelius saved us. Literally, Berzelius saved us by stating that, boss, Dayton-ji, these symbols are not reliable and we cannot use and remember them for the longer run. So we have to simplify this and let's give the symbols for atoms on the basis of their names. Like if we use first letter and the second letter, based upon that, there were certain rules which have been made by Berzelius. Like if we are writing the name or a symbol for an atom, first letter has to be a capital letter followed up with a small letter, right? So that gives us a very simplified way of writing these symbols and we can remember it for a long time. Not only that, we are using Berzelius methods till date. So yes, thanks to him, he made this so simple for us. Now the names were derived from the place where they have been originated. Any element which has been originated in that particular place, name was given based upon that. So that's how we used to do in the previous time. Now Ayupak came in the picture later. Ayupak is what? Mummy Papa of chemistry. What is Mummy Papa of chemistry? Without their permission, nothing can go universally. Now also. So anything which needs to go out universally based upon chemistry, that has to be approved by Ayupak. And that is none other than International Union of Pure and Applied Chemistry. So they were the ones who now approves the names, symbols and units in everything about chemistry. So they also approved Berzelius' ideas and told that while writing the symbol, first letter should be in the uppercase, capital letter, followed with the second letter which has to be the lowercase. Now some of these symbols have been derived from the Latin names, some of them has been derived from the German names and some have been derived from the English names. So let's take a look. Hydrogen का first letter H is a symbol. Cobalt के लिए capital C small o. Capital C capital O is a different substance altogether. It is carbonyl or carbon monoxide. But what we are dealing with is one element, that's cobalt. It's a metal. Then aluminium. First letter capital, second letter has to be small. Then other examples, iron. Iron comes from ferrum, which is its Latin name. Sodium comes from natrium, which is its Latin name. Potassium K comes from calcium, which is its Latin name, and so on. I hope that's clear. Yes, John Dalton was a person. Parmanu is a term given to the smallest atom by Maharshi Karnad, and it was done in 17th century. So yeah. That time, atom was not a term coined. Atom was coined later by Mr. Democritus, who was a German person. And Parmanu was a term coined by Maharshi Karnad. If you've seen movie Parmanu, there is a movie called as Parmanu. It's a John Abrahams movie. Watch it. That's based upon atom bomb. That's a very, very good movie. Right? Please solve the numerical at the end of the... Betsy, we have already solved, Betsy. We have other questions to solve. Okay. Moving on to the first 20 symbols that should be on your tips, not only for your grade 9 guys, but trust me, without this, your grade 10 would be also very difficult. So please make this foundation as strong as you can. This is very important, but I will definitely help you to remember this with a simple trick. Hi, hello. I have already made a video on this, but by any chance, if you have not seen this, this is where you can learn. Hi, hello. Listen. BBC News on Friday night. Naughty monkey always sings. Please stop clowning around. K potassium, C calcium, kitchen cabinet. Yeah, easy way to remember. Hi, H, hello, that's hydrogen. He for helium, Li, listen, ka lithium, and so on. So, hi, hello, listen, BBC News on Friday night. Naughty, Na for sodium, monkey, Mg, always, aluminium, sing, please stop clowning around kitchen cabinet. So, that's good, Aditya, that's good for you. That will help you in later run. But first 20 is compulsory in 10th also, and obviously in 9th. Now, as we are talking about the atoms, what about their masses? We are always saying that atoms are very chotu, they are so small. Now we have these symbols for atoms also. We know how to find out the symbols, but what about their masses? Masses of atoms are very, very small. So each atom has a very extremely small mass, so that's why we are going to read about the relative or the average atomic mass, which is AMU. It was given by Dayton. So after one failure of the symbol of atoms, Dayton ji again come up with the idea, which was extremely great idea. Dayton ji told that atoms ka mass is so small that figures are in decimals, which is hard to learn, so difficult to use in your numericals, so difficult to remember also. So why not to make them very easy? So he came up with a brilliant idea of why not using average atomic masses, which is AMU, later called as U, which is called as unified mass. That helps to learn the atomic masses in whole number, and usage of those atomic masses would also be very, very easy. So yes, that's when we come up with atomic mass unit. Now, atomic mass unit initially started with different atoms like oxygen. Earlier, oxygen was kept as the reference element. So, oxygen ka atomic mass is 16 AMU. So, earlier, the other masses of atoms were calculated based upon the reference element, which is oxygen. So, earlier the atomic mass unit was 1/16th the mass of the atom naturally occurring oxygen as a unit. But there were certain reasons to take oxygen as a reference element, because oxygen react with large number of elements. Not only that, it was providing almost the correct masses for most of the elements. But later on, it got discarded. Later in 1961, universally acceptance were given to carbon-12 isotope. So carbon-12 having mass 12 was kept as a reference element. Based upon that, masses of other elements were calculated, and that is when it was called as AMU is equal to 1/12 the mass of the carbon-12 isotope. And then we came up with these atomic masses, which is in whole number, easier to learn, easier to use in your numericals. So these are the masses which you have to learn. Hydrogen ka mass is 1U, or you can also write it as 1 AMU. 1 AMU. One of the same thing. Then carbon ka mass is 12, nitrogen 14, oxygen 16, potassium 19, and so on. Obviously, it's hard to learn. sometimes in paper, it is given to you in the question. Like for example, if they are asking you to calculate the molecular masses, most of the time in grade 9, they will be giving you the masses of every atom. But let's say if they have not given you the atomic masses, then how will you remember? For that, let me help you out. I'm sorry, Miss Khan, but it's an English channel. Yeah. Okay, Ji. So trick to find the atomic masses of elements. I know it's so hard to learn. Sodium ka mass is 23, hydrogen is chalo fir bhi simple 1, then carbon is 12 and so on. Now to learn that, you should remember the atomic mass, atomic number, right? Atomic number should be in your mind. So if atomic number is even, or if atomic number is odd. Now you all know what is even and odd. I'm sure you all know what is even and odd, right? If atomic number is even, in that case, to calculate atomic mass, you will going to multiply atomic number with 2 plus 1. Let's see. Like for example, magnesium ka, it's 12. है ना? Sorry, into 2. Just 2. ठीक है? Atomic number is 12, which is even number, right? To calculate atomic mass, we just have to do 12 into 2, which is 24, and 24 would be the mass of magnesium. Voila, done and dusted. So if atomic number is even, mass would be calculated by just multiplying atomic number with 2. But in case of atomic number is odd, in that case, atomic mass will be calculated by multiplying atomic number with 2 plus 1. Like for example, sodium. Sodium has atomic number 11. 11 is the odd number. So now if I multiply this atomic number with 2 plus 1, that gives me 22 plus 1, which is 23. And 23 is a mass of sodium. Clear, boss? There are some exceptions here like helium. We have nitrogen also as an exception, right? So there are few exceptions which you have to learn directly, but most of the masses can be calculated like this from 1 to 20. Okay, Ji. You can go back, Betnik. You can go in the session anytime back and solve it. I hope yahan tak everything is clear, all sorted. Cool. It's an easier way to remember the masses, but most of the time masses are given to you in the question, so don't worry that much. All right. Now, how atoms exist? We all know that atoms are so small, but how they actually exist in nature? Obviously, atoms, there are very few atoms which exist independently in nature. We call them as noble elements. Noble bole to like helium, neon, argon, krypton, xenon. They are the ones which exist independently, but most of the other atoms needs to survive either by making molecules or either by making ions, right? Either by gaining or losing electrons or either by combining with some other element and create molecule. So there are various ways by which atoms can exist, but there are few atoms which exist independently and we call them as noble gases. Noble gases or inert gases, that means they do not react, love to stay single, are not ready to get mingled, are noble gases. Helium, neon, argon, krypton, xenon. Okay? These atoms exist independently, whereas others needs to survive by either creating themselves into molecules or turning themselves into ions. Now, what is the difference between molecules and ions? Let's take a look here. Now, molecules are of two types: molecules of element, molecules of compound. Molecules of compound are pure colorless compounds, and molecules of elements are just elements where two elements combine together and they survive in nature. Like for example, hydrogen combined together to form hydrogen gas H2, right? Similarly, if we talk about chlorine combined together to form chlorine gas. Then we have bromine surviving in Br2 form, oxygen, O2, ozone, O3, sulfur, S8, phosphorus, P4, and so on. So they will combine together to exist and they are called as molecules or molecules of elements. Now some of them are monoatomic. Monoatomic, diatomic, polyatomic, what is that? That's atomicity. Atomicity is the total number of atoms contributing in a molecule. Like phosphorus exists only when 4 phosphorus atoms combine together. So that means it's tetraatomic, or we also call it as polyatomic. Poly bole to many. Similarly, sulfur does not exist as S. No. As an atom or a single atom, it will not exist. It will exist if it's going to bond with other 7, create 8 atoms ka structure. That is how it exists in nature. So it's octatomic or polyatomic. Oxygen does not exist as just O. Oxygen exists as O2, which is a gas. Oxygen also exists in a form of ozone if there are 3 atoms of oxygen combined together. So that's triatomic. O2 is diatomic. I hope that's clear. Okay, all right, Bethany. By the end, just remind me. Fine, so atomicity also you should know. Metals are usually monatomic. Rest you should know the atomicity. This is where your questions lands up in your MCQ part. Question do come from atomicity. Now, molecules of compound is where different molecules combine together in a specific proportion. That's a key word here. Remember, in a specific or a definite proportion is a key term here. Different molecules combine together, like for example, hydrogen and oxygen combine to form water, which is a compound or a molecule of compound. Carbon, hydrogen, C12H22O11. Different elements combine together and that results into a compound, and that's called a sugar. But that has to be in a specific proportion. Water will be H2O only. It will not be HO or HO2. That has a specific formula. It will be that only. So it will be definite. It will be fixed. Now similarly, carbon dioxide is CO2. It cannot be changed. So elements will combine here in a fixed proportion. That's when we call them as molecule of compounds. I hope that's clear to you guys. Yeah, ammonia, methane, water, sugar, glucose, H2SO4, which is sulfuric acid, hydrochloric acid, n number. There are hundreds and thousands of compounds, I would say millions of compounds available in nature. So they are all present in a fixed proportion. Now talking about ions. Ions are again one of the part where atoms try to exist. Ions, how many types of ions you've learned? 2. Can you please name them? What are the ions you guys have learned? Ions are what? Charges. In physics also you've learned 2 charges, plus, minus. Here charges are plus, minus. Ions would be plus, minus. Cations and anions, likhita, absolutely right. High five. Anions bole to negatively charged particles. Cations bole to positively charged ions. Now, let me make this very simple for you. All non-metals will be creating negatively charged ions, anions. Whereas, all metals will going to create positively charged ions, which we call them as cations. Anyone who ever got confused to remember the name of cations and anions, let me help you out. Cations, right? Cat has pos. Pos say positive. Yeah, so if you remember one smartly, you will be remembering the other one. So if you just try to remember one part, other will always be sorted for you. So cations is positive. Therefore, anions will always be negative. And trust me guys, I've seen children in grade 10 who are still confused with positive and negative cations and anions. And you will be using this term more frequently in grade 10. So many places where 5-marker question also comes from cations and anions part. So this has to be very, very clear. Fine. So mostly non-metals would be negatively charged. Why? Because they love to gain electrons. And positive would be formed because they love to lose electrons, and that's how we get positive charge on the metal. Like sodium is a metal having plus charge, calcium is a metal having 2 plus charge, aluminium is a metal having 3 plus charge, right? Non-metals, if we talk about chloride, -1, oxygen 2 minus, nitride 3 minus, and so on. So all of these are non-metals which will always having a negative charge on them. That means they would be anions. Now this is a table which has to be again on your tips, that helps you to create formulas. In formula making, they will not give you these ions. You should remember this. What is the difference between nitrate, nitrite, nitride? Anyone? Come on, quickly. What is the difference between nitrate, nitrite, nitride? Come on, anyone? Nitrate ion, NO3, 1 minus. Nitride ion, NO2, 1 minus. Nitride ion, N3 minus. What is the difference in the name? 8, ide. That's it. And with this small difference, there is a difference in the ions. And because there is a difference in the formula of ions, there would be definitely a difference in the formulas also. So you should have a clear idea about these formulas along with the name. Sulfate. What is sulfate? SO4, 2 minus. N2, N3, N. No. AG records, no. Yeah. Sorry, I didn't get it. The heat formula of heat. Okay, AJ. That's okay, Bache. Yeah. So for formula making, you should know about these ions. Now, ions are also further divided into simple ions and polyatomic ions. Now, what are simple ions? Simple ions bole to when single atom is having a charge on them, whether positive or negative. That's different story. So single atom with a charge, single atom with a charge, single atom with a charge. So these are simple ions or monatomic ions. Whereas if there are group of atoms having a charge on them, we call them as polyatomic ions. Bethnik, let's finish this and then we'll go back. Okay. So यहाँ पे polyatomic बोले तो group of atoms like ammonium. There are different atoms with a charge on them. Group of atom having a common charge on them. That's ammonium. Carbonate, CO3 2 minus. So that is also polyatomic ion. So while you were making formulas, these ions will make a difference because rules will going to change whether you are using simple ions or polyatomic ions. Oh, that's so nice, AJ. But yeah, good try. So based on that, let's see how to write chemical formula. We practice few also. Chemical formulas के लिए first thing that you have to remember are the valencies or charges must be balanced. They should always balance and come out to be 0. Next, always we write metals first and non-metals later. बोले तो positive वाला first and that followed up with the negative charge. Like for example, NaCl. It is made from Na plus 1, Cl1 minus. We have never seen formula like ClNa. That does not exist because formula making has certain rules which defines that metal comes first, non-metal comes later. Positive charge should be placed first and then we will going to place the negative charges. Now, if there is a usage of polyatomic ion in the formula, then we will make sure we enclose that into bracket. Let's do that. Let's try some. Here, this is what you want, Bethnik. And this is already given in your NCERT book, Bethnik. You don't have to take the picture. Okay. Let's try this. Give me the answers in the chat box. Give me the answer in the chat box. Come on. Sodium oxide. How will you make the formula? First rule, we will put the charges first, Na plus 1. Oxide is O2 minus. Now, to write a formula, you have to follow crisscross method. So this number without charge will go down on the opposite side. That will give you Na2O1. 1 is never shown by default. We don't show 1. So your final answer would be Na2O. That's the final formula of sodium oxide, which is Na2O. That's right, Bethanic. That's right. AJ, there's a chotu mistake there, but yeah, good try. Moving on to aluminium chloride. Aluminium is Al3 plus, chloride is 1 minus. After crisscrossing, that gives you AlCl3. AlCl3. And calcium carbonate. Calcium carbonate. I want you to answer. I'm not feeding you everything now. Come on. But Nick, due to mistake, calcium carbonate. You know what? Eggshell. Eggshell has calcium carbonate. Formula of eggshell is calcium carbonate. Formula of marble, chalk that we use in schools, that is also calcium carbonate. CaCO3, voila, very good. So calcium is Ca2 plus, carbonate is a polyatomic ion, CO32 minus. We'll put that into bracket. Make sure that you always enclose a polyatomic ion in bracket. Now bring this number here. Bring this number here. That gives you Ca2, CO3 whole 2. Now, as you have same numbers here, we don't have to show anything. That would be crossed. So that gives you CaCO3, and that is the perfect formula of calcium chloride. Wallah, fata fati. Very good. It's okay. Just try not to make mistake, hai na? Baad mein. Good. So that's your final answer. Okay, molecular mass, from this part you get 2 marker questions. Most of the time they'll give you some formulas and they'll ask you to calculate the molecular masses. Now for 3 mark question, they'll ask you to create a formula and then calculate the molecular masses. So they can ask you in various form. For example, if I tell you to make a formula of ammonia, what is the formula of ammonia? Calculate its molecular mass. So you should know what is the formula of ammonia. Ammonia is NH3. What is a molecular mass? Mass of all the atoms will be summed up. Nitrogen ka mass, what will that be? Remember, you've already learned the atomic masses. Nitrogen ka atomic mass is 14U. Hydrogen ka atomic mass is 1U. So there is one atom of nitrogen. That would be 14 plus how many atoms of hydrogen are there? 3. If one atom of hydrogen ka mass is 1, then 3 atoms ka would be 3 into 1. So that would be 14 plus 3. That gives you 17. 17 U. Cool. Yes, Prateek ji. Absolutely hats off. Sum of all the atomic masses. Perfect. Now, water atomic mass, how we calculated? Water, H2O. Formula has to be spot on. Formula, if it's wrong, then everything will go wrong. Hydrogen atomic mass 1U. Oxygen atomic mass 16U. 2 atoms of hydrogen, so that would be 1 into 2 plus 1 atom of oxygen, that would be 16. So 2 plus 16, that gives you 18U. Now in the same manner, we will be also calculating formula unit mass. But there is a slight difference here. Formula unit masses are used for calculating only for ionic compounds. That's the only difference. So they have just given a fancy name. Rather than calling it as a molecular mass, they're just calling them as formula mass unit. Why? Because ionic compounds are also called as formula units. Okay? That's the only thing. They have given a fancy name, but calculation will remain same. So NaCl, sodium has a mass of 23, chlorine has a mass of 35.5. So how will you do that? NaCl ka mass would be, formula unit mass would be 1 atom of sodium having mass 23 plus 1 atom of chlorine having 35.5. Total would be 23 plus 35.5, which is 58.5. Impressive. 58.5 AMU. That's your perfect answer. Good. Oh, there is one more chapter with Nick. One more chapter. Cool? I hope that is clear. हाँ? फ्रेंड ने बोला तूने तो बोला था कि कुछ नहीं पढ़ के आएगा, but इतने मार्क्स कैसे? Any one of you who does that? Any one of you ever did that? That you always tell your friends, I've not read anything, I've not done anything for the entire year. I don't know how will I pass. And once you pass, you just pass with the flying colors. Have you ever did that? Actually, AJ, I also did that. I always tell my friends, I've not studied anything. I don't know anything. But once I start writing, I write everything in top. Yes. Relatable. Yeah, Sikandar. No, never. I think you're a very good boy. Good. I too was the very naughty in my school. Okay. And afterwards you get good marks, your friends would be like, you too told that you have not studied and now you're a topper. I'm not going to talk to you. And there would be a big fight. Yeah, same. Backbenchers do that. They don't tell, they don't reveal anything, but people will think that they don't know anything. But once exam comes, they are the ones who do the best paper, who write the best papers. Gaddari. Yeah, please, Rao, please. Okay, alright guys, on that positive note, let's move on to structure of atoms, which would be our very last chapter. Okay, ready to go? Ready to rock and roll? Yeah? Syllabus, let's begin. Now again, structure of atoms is important. Mostly questions are asked from Rutherford. They will ask you the conclusion, they'll ask you the limitations of Rutherford from nucleus, valencies, valence electrons. Again, that's the hot questions of your paper. To calculate the valencies, to calculate the valence electrons, and lastly, electronic configuration. On the top, on the list of important topics, electronic configuration is on the top. So they'll give you some compounds, they'll ask you the electronic configuration, they'll ask you the valencies and valence electrons. So everything would be asked in one question. From structure of atoms, you usually get questions for around 3 to 4 marks, yeah, sometimes 5 marks also, but they are mainly focused to 3 to 4 marks. So please be prepared, you get a lot of questions from this chapter. Yeah, so Betnik, NaCl is a compound, right, with sodium element and Cl. So to calculate the mass, it's calculated in the same way as molecular mass. We just name it differently and call it as formula mass. So sodium ka mass, atomic mass is 23U. We should know that. Chlorine ka atomic mass, we should remember that, 35.5. One atom of sodium is there, so mass 23. Atomic mass of chlorine, there is only one atom, 35.5. We have just added them together and we'll get the formula mass unit. Okay, Betnik? I hope that's clear. Okay. Now moving on to the charged particles. Let me tell you this, guys. The discovery of each subatomic particle was done in a very different era, I would say. Neutrons were discovered last because finding neutrons by scientists was the hardest part. Why? Neutrons were neutral, having very less mass. So defining neutrons in a structure was the difficult part, but later in 1932. That was too late. 1932, neutrons were discovered by Mr. Chadwick. So overall, atom has 3 subatomic particles, that is electrons, protons and neutrons. According to Dalton G, atoms are not divided. They are the smallest particle which cannot be divided further. But he got wrong. He was proven wrong once subatomic particles were discovered. Electrons represented by E negative, plural by E negative S. Protons P positive and neutrons with N 0 or not on the head. So that's how we represent electrons, protons and neutrons. Discovery of subatomic particles, you should remember the names of scientists. That's very, very important. So electrons were discovered by Mr. J.J. Thomson. That is a negatively charged particle. Protons were discovered, which are the positively charged particles discovered by Goldstein. And in 1932, Mr. Chadwick discovered neutrons. So please do remember the discovery, how they were discovered, and what are the name of scientists who have discovered. Years are not important in chemistry. No one will going to focus on the years of discovery in this particular grade. So don't worry about that. Okay. Now, once these were discovered, once subatomic particles were discovered, Thomson come into picture. Everyone was thinking about how atoms actually look like. So they all tried to create the structure. They all tried to imagine the structure of atoms. So when Thomson started his work, neutrons were not much discovered, or the part of neutron was actually missed in his theory. Why I'm saying theory? Because Thomson did not do any experiment. He was a big foodie. I think Thomson was a big foodie because he compared the structure of atom with a Christmas pudding. Who do that, man? Who do that? So Thomson's model of an atom was also called as a plum pudding model as well. So what he thought in his mind, that plum pudding has plums in between, raisins in between. So overall atom also look like that. It's a spherical structure with a negative charge embedded in them. Just like raisins are embedded in an entire that pudding. Similarly, atom is also something like that, which is spherical. Negative is embedded in it and it's an entire positive circle, positive sphere. That's how he imagined atoms. But within this complete theory, one thing was absolutely correct. Thomson told that the magnitude of negative and positive charge is equal. That means the number of negative and positive is equal. And that makes atoms as neutral. So atoms are always neutral. Please remember that. Atoms are always neutral, and he was perfectly correct on this particular part. Hi Anoop. Yes. Clear boss? Chal. Now as Thomson did not get good reviews, but he was the first person to come up with the structure of atoms, so he was appreciated a lot. Later on, Rutherford did proper experimentation and he came up with a solid data and told Thomson, boss, tusse na ho paega. I will give you the structure of atom because I have did the proper experimentation. But let me tell you this, guys. Rutherford model of an atom created something which was accidental. So it was an accidental discovery which has been done by Rutherford. I hope so that every person become or do such kind of accidents which make them very famous. So Rutherford discovered nucleus, which was not something he was looking for. It discovered by accident, which created him as one of the major and the famous person of the entire chemist industry. He was a damn famous person then. Okay, coming back to Rutherford, it was also called as alpha particle scattering experiment. This guy started this experiment to search the position of electrons. That was the truth. He started this whole thing to find out that where electrons are positioned in the entire structure. By doing this experiment, he actually used a gold foil because he was a rich scientist. Just kidding. So he used a gold foil, and as well as he used alpha particles. Now, what are alpha particles? And as is another question which comes in your paper. Alpha particles are nothing but they are helium ions, helium 2 plus, with 4 unit of mass. These are alpha particles, extremely important questions for your exams. Now, these are positively charged. Now, what he did, he thrown some of the alpha particles towards gold foil, and he observed that most of them went straight, some of them got deflected, few got deflected, and one of the few rebounded back to 180 degree. Now, after looking at this, which was quite strange according to him, he concluded few things, and conclusion was, because most of the part of an atom is empty, so there is no restriction for alpha particles, so they went straight. Most of them went straight because it was the empty ground. Some of them got deflected because, according to him, he thought there is some repulsion going on, man. Positive repel each other. So I am throwing a positive charge onto the gold foil. There has to be some positive in the atom which is repelling the alpha particles. So then, because of the few deflections, he concluded that there is a positive charge in the center of an atom occupying a smaller portion, very small volume, somewhere in the center, because few got deflected. And one got rebounded back, maybe because one in few thousands directly hit onto that positive charge and repelled hard, and that's why they came back, rebounded back. So from this entire conclusion, he came up with the discovery of nucleus, and that was a dhamaka in that proper entire industry, because that was the accidental discovery. He found nucleus which consists the entire mass of an atom, which is in the center of an atom, positively charged. So atom has a center which is nucleus, positively charged, right? So he then gave a nuclear model, and he also told that nucleus ka size is extremely small as compared to the size of the entire atom. Like, imagine a cricket stadium, and there is a ball placed in the center of the stadium. Imagine, just imagine. That's how he was trying to compare. Size of nucleus is so small as compared to size of the atom. Size of that ball is so small as compared to the size of that entire stadium. That's what the comparison was. So size is very, very small for the nucleus, and the entire mass of an atom will be resided in the center of an atom, which is in the nucleus. So whole atom cum mass will be decided by the total number of protons and neutrons present in the center of an atom, which is nucleus. Protons and neutrons together called as, tell me in the chat box. Hi Abhinav. That was sweet, Sikandar. Come on. Neutrons and protons collectively called as. Very, I would say, lazy term. When you don't want to call neutrons and protons separately, there is a one collective term for that. Ah, no, Betnik. Neutrons and protons collectively called as nucleon. They are collectively called as nucleon. Okay? So neutrons plus protons together called as nucleon. Okay, coming back, correct, that's right. Now coming back to the limitations of Rutherford, see, even legends make mistake. So he did absolutely great. He did proper experimentation, came out with the good results, nucleus got discovered, everything was going good. But, this legend also made one mistake. That mistake was highlighted. And the mistake was, Rutherford thought that electrons which are revolving around nucleus will be tired and fall inside nucleus after some time. Rutherford ji, if atoms start busting up, how will we survive? We are made up of atoms. If atoms will be destroyed, how you are surviving, how we are surviving, and how this entire universe will survive. Atoms are stable, everyone knew that. But giving this statement has done everything wrong. So, according to him, electrons while revolving lose their energy and fall inside the nucleus, which is not correct. And that became one of the biggest limitation of Mr. Rutherford's Rutherford's experiment, not theory, experiment. All right. That leads to another hero. Bohr told that Rutherford, you could not explain the stability of an atom, da. So I will come and tell you that how atoms are stable. Bohr did a lot of work and he came up with a proper explanation that atoms are stable because electrons don't fall inside the nucleus, sir. In atoms, electron revolves in a discrete orbit. So he came as a hero, told that in atoms, electrons revolve in a special orbit, in a discrete orbit. They don't jump just like that, or they don't fall inside the nucleus just like that. So while revolving in their own orbit, they don't lose energy, they don't gain energy. Nothing will going to happen if they are revolving in their own orbit. That orbits are being named differently as K element shells, which are also called as energy levels or shells or orbits. They are also numbered as 1, 2, 3, 4 from inside to outside, from nucleus till outside. 1, 2, 3, 4, KLMN. And according to him, electrons can lose or gain energy only if they are jumping from one orbit to another. That's the only time when electrons will vary in their energy, if they are jumping from one level to another. Is that clear to all of you? Which is good now. Students do wonders, and Bohna, if you do wonders, I would be very, very grateful. Yeah, proud of you. Last one, Bethany. Last chapter. Okay. Now, as we're talking about electrons, we all now were very clear that electrons revolve in the orbits, right? Nucleus is in the center, where protons and neutrons reside. Entire mass of an atom stays in the nucleus. That means mass of an atom is a total of protons and neutrons. Everything was clear. But how electrons were distributed, that was a question till that time. Bohr and Bury, two friends, come up with a rule, or we call it as a scheme, called as Bohr-Bury rule or Bohr-Bury scheme, who gave electronic configuration. Electron configuration is the distribution of electrons in different orbits. So, how electrons are distributed? There are certain rules for that. What are the rules? Let's see. Number one rule, to find out the maximum occupancy of the shell, how many electrons can be maximum accommodated in one shell, will be calculated by a simple formula called as 2n square, where n bole to orbit number, which number of orbit we are talking about, whether it's 1, 2, 3 or 4 or so on. Now if it's k shell, bole n is equals to 1, using 2n square, only or maximum 2 electrons can be accommodated. In L shell, maximum 8, in M shell 18, in N shell 32. But have you seen this literally? When you are writing the electronic configuration, you have never wrote 18 or you've never used 32. But yes, this will be justified in grade 11th and 12th, because right now you are dealing only with shells. Once you go to grade 11, you will be dealing with subshells, and that's something which is not in picture in grade 9. Okay, in grade 11th, you will be learning about subshells. There you will be understanding these numbers, justification of these numbers will be given in grade 11th. Is that clear to all of you? Hi Nitin, good evening. Now the maximum number of electrons that can be filled in the outermost shell is 8. As we are dealing with shell, we have a rule that outermost shell will be filled with 8 electrons. Octet needs to be complete to be stable. Now it has to be filled in the organized manner. Until and unless first shell is filled, you cannot jump on to the next one. Next shell is filled, then you can move on to the next one, and so on. So you have to fill the previous rooms to get on to the next room or the next orbit. So let's take a look on few of the electronic configuration. Hydrogen, atomic number 1. Atomic number is equal to number of electrons, it is equal to number of protons. But please pay attention here. That's another very important question of your exams. Not only this, if you are thinking of giving Olympiad also, that's a common question to ask. One only element with shunya neutrons, 0 neutrons, and that is none other than hydrogen. Hydrogen is the only element with 0 neutrons in them, in the nucleus. So that is one important question. Okay, so number of atomic number, which is represented by Z, number of protons and number of electrons are always equal in an atom. And to distribute that electron, we have shells. So in K shell, 1 electron would be distributed. Helium, K pass, there are 2 electrons. 2 electrons will be distributed in K shell. Then we have lithium, 3 electrons. Now 2 has already been filled up, 1 will be then added up to the next shell. So organized manner needs to be maintained until and unless your next shell is completely filled by 8 electrons, you won't be moving into the next shell. Now after this, you have sodium with 11 electrons, and to distribute 11 electrons, 2 plus 8 plus 1, 11. K shell filled with 2, the next 8, and the rest of that would be then distributed to the next one. So as you've seen the electronic configuration, it's easier for you to identify the valency and valence electrons. Now what are valence electrons? In simple words, can you define that? Come on. Nitin, chemical loads out. What are valence electrons? Valence electrons means the one which is present in the outermost shell. Now looking at sodium, atomic number is 11, electronic configuration is 281. The one which is present on the outer side of the shell or the outermost electron will be your valence electron. Right? So how many valence electrons are there in sodium? 1. How many valence electrons are there in magnesium? Let's see. So magnesium's atomic number is 12. Electronic configuration would be 282. Outermost shell has 2 electrons. So therefore valence electron in magnesium would be 2, and so on. This is how you will be calculating the valence electrons. Now to calculate valency, what will you do? So let me make this easy on you guys. To calculate valency, first thing you should know atomic number. Once you know atomic number, you should know how to write electronic configuration. Once you know the electronic configuration, you know how to write or how to find valence electrons. And once you have valence electrons, it's easier to calculate valency. So to reach valency, you have to pass these steps. I'll give you a simple example. Okay, Bethany, just give me a few minutes. Magnesium. Okay, let's take an example of magnesium here. Atomic number 12, electronic configuration 282, outermost shell में 2 electrons, so valence electron is 2, and therefore its valency will also be 2. Now let's take chlorine. Atomic number 17, electronic configuration 287. Outermost shell has 7 electrons, बोले तो valence electrons are 7. Valency is 1. How? How we have calculated this? So valency is based upon the combining capacity. Magnesium can lose these 2 electrons and become stable. So losing 2 electrons become its valency. Chlorine needs only 1 electron to attain octet configuration. That its valency. How many electrons can be lost or gained to attain a stable configuration? That's valency. That's combining capacity. Now I have a trick to calculate the valency. Let's talk about it. Simple trick hai. Nothing much fancy here. If valence electrons are 1, 2, 3, then valency would be equal to valence electron. How to calculate valency? If your valence electrons are either 1, 2 or 3, then your valency would be equal to valence electrons. Like for example, calcium, atomic number 20, electronic configuration 288, 2, 8, 16, 17, 18, 19, 20. Yeah. So outermost shell is 2 electrons. So its valency will also be 2. Similarly, if I take sodium, atomic number 11, electronic configuration 281, valence electron is 1. So its valency will also be 1. So if valence electron is either 2, 1 or 3, 1, 2 or 3, then their valency would be equal to their valence electrons. Cool. Now, similarly, if valence electrons is 5, 6, 7 or 8, in that case, valency would be equal to 8 minus valence electrons. Let me give you a few examples here. Chlorine, 7 valence electrons. If valence electron is 5, 6, 7 or 8, then valency would be calculated as 8 minus valence electron, 8 minus 7, which is 1. So your valency is calculated like this, 8 minus 7. 8 minus valence electron, if it's 5, 6, 7 or 8. Is that clear to all of you? Solid? Hi Sakshi. Yes, correct, Betning. Bilkul theek hai. Number of electrons gained, accepted or shed by an atom of an element. That's right. That's right, Sikatar. Good. Very, very good. So on that note, let's move further, but let's take 1 minute break. Yeah. We are on the last topics, atomic number, mass number, isotopes, isobars. Okay. That's it, and then we'll be done. And no, not done. Few questions are left. So you will be solving few questions to practice what you have learned. Along with that, I will also give you some tips how to write the answers in your paper. That will help. That will help a lot. So, yep. Let's take 1 minute break. More than enough. Kit Kat break. Alright guys, let's begin. Let's come back with a bang. 1 minute, Maggie. Bhai, 5 minute bhi nahi banti. Okay. Alright, so let's begin with the high josh, with a bang. I hope you all have done all your businesses, drank something, came back from washroom. Somebody took a washroom break. Chale, let's start. Atomic number, mass number. That's something they will ask you in the questions, like they'll give you the idea about this is the element with atomic number so and so. Find out the element, find out its valency and valence electrons. So such kind of 2-marker questions can be asked, but you should know what is the atomic number, because sometimes they twist the question. Without saying atomic number, they'll give you the number of protons and they'll ask you other details. So atomic number is nothing but it's the number of protons present in the nucleus. So as we discussed before also, atomic number of protons and electrons are equal in an atom. They are absolutely equal. So if I tell you atomic number for sodium is 11, so its protons will also be 11 as well as its electrons will also be 11. Magnesium ka proton, if it's 12, its atomic number would be 12, its electron will be 12. If I say that hydrogen electron is 1, so proton would be 1 and atomic number will also be 1. So in an atom, all of these variables are completely equal to each other. Now how to represent it? We have already seen so many times. So if I want to write the atomic number of sodium, I'll be writing it at the bottom. Or we call it a subscript, and its mass will be written on the head. We call it as superscript. Now to make it more clear, you can also mention it on the opposite side. It is also completely acceptable, completely correct. Fine? Okay. Now, as we're talking about masses, mass number or the mass of an atom, that is decided completely from the nucleus part. So, as we discussed before in Rutherford's theory, complete mass of an atom stays inside the nucleus. And who stays in the nucleus? Protons and neutrons. That means who is deciding the mass of atom? Protons and neutrons. So, total number of protons and neutrons ka sum would give you the entire mass of the atom, and that means nucleons are giving you the mass of an atom. For example, carbon ka mass is 12, but carbon ka atomic number is what? 6. So how we found 12 here? So if atomic number is 6, that means its protons are 6. So neutrons has to be 6 to calculate the mass. So I have a formula for you. Atomic mass is equal to total number of protons plus neutrons. Calculate the neutrons for hydrogen. Hydrogen के लिए neutron calculate करो if its atomic number is 1 and its mass is 1. Chalo, let me give you. Atomic number for hydrogen is 1 and mass is also 1. Sakshi, mass number is the total number of protons and neutrons present in the nucleus. Protons and neutrons are together called as nucleons. So the nucleus part is deciding the entire mass of the atom. Clear hai boss? Yes, Sakshi? Yes, Aditya. Sure, Aditya. Come on, tell me how many neutrons are there. Mass is given to you, which is 1. Now we already discussed atomic number protons and neutrons, atomic number protons and electrons are equal in an atom. So if Z, atomic number for hydrogen is 1, therefore protons is also 1, so that is also 1 plus neutron. So now simple calculation was neutron is equal to 1 minus 1, which is 0, and that's shunya. Preetham, hats off, very good. Very nice. So it is 0 neutrons present in hydrogen. Clear hai boss? Now if I say carbon ka atomic number is 6, hai na? And neutrons are also 6. Calculate the mass. So mass is what? Protons plus neutrons. Proton is nothing but its atomic number and electrons in an atom. So what is given to you is atomic number, which is equal to number of protons only, that's 6. So A is equals to protons plus neutrons. That means 6 plus 6, that gives you 12. So that gives you the mass of carbon, which is 12U. That's how you get questions in your paper. That's how you get questions in your paper. That's absolutely right, Bethnik. And this one is most commonly asked. Okay. On that note, moving on to our last topic, which is isotopes and isobars, and then we have some practice questions coming up. What are isotopes? What are isobars? Most mistaken topic, I would say, places where you get confused very, very easily. Isotopes. Isotopes bole to, where atomic number would be same. Hydrogen 1, hydrogen 1, hydrogen 1. Masses could be different, 1, 2, 3. So hydrogen has 3 isotopes. Another question, how many isotopes are there in hydrogen? Name them. And what's the formula? Write the or calculate the number of neutrons. So here hydrogen has 3 isotopes called as protium, denoted by capital P, deuterium denoted by capital D, and tritium denoted by capital T. They will have different neutrons because of same atomic number, because of same valence electrons and electronic configuration. Their chemical properties would be same, identical chemical properties would be there, but physical properties will be different, right? Number of neutrons will be different. As you calculate, number of neutrons for this would be 0. Number of neutrons for deuterium would be 1. Number of neutrons for tritium would be 2. So in isotopes, number of neutrons will change. Number of or mass number will differ, but atomic number would be same. If atomic number is same, element would be same, right? So hydrogen has atomic number 1. That's like a fingerprint. So for every person, fingerprints is the identity. You and me cannot have same fingerprint. Similarly, different elements cannot have same atomic number. Remember this, atomic number works like the identity for an element. It's like a fingerprint for an element. So if element is same, atomic number would be same. Or atomic number is same, that means element would be same. Clear, boss? Yes, Aditya. I have correct, Doc. Thank you. All right, see, Aditya, mass 2 into atomic number, not mass, 2 into atomic number. That is the trick which we discussed today to calculate the masses. Atomic mass equals to 2 into atomic number if you are calculating the masses for even atomic number. Right? We did that. You can go back and check it out later. Okay, and isobars would be completely ulta, where masses would be same, but atomic number would be different, like calcium. Calcium and I would say argon, yeah, 40-40, but 20 is the atomic number and 18 is the atomic number. So atomic number is different, so element would be different. Fingerprints are different, so elements would be different, but masses are same. So if elements are different, their chemical properties will be different, but their physical properties will be same. So chemical properties will differ, elements will be different, number of electrons will be different, because atomic number, if it's different, so there would be a different electrons also. So यहाँ तक सब कुछ clear है boss? कोई शक, कोई doubt? Yes, Aditya, and even numbers of atomic number. Yes, Preetham, you're full energized to solve the questions, huh? Okay, we'll be just quickly solving the questions. Okay. So I'll be giving you a timeless pulse. ठीक है ना? Easier. Each question should take less than 15 minutes to solve. Which one, Betnik? Solid? Okay, cool. Betnik, if you're asking for that numerical, I'll just show you quickly. Wait. Here is the numerical that you were asking, right? 60 by 60 plus 400. Solute divided by solute plus solvent. That's your solution in 200. So 60 divided by 460 into 100, that gives you 13.04. ठीक है बेतनिक? चल. Now it's time for us to move on to our practice questions. Be ready. We'll be going quick. And I don't think so you need more time to solve the questions. Just hardly less than 15 minutes and you'll be done. Alright guys, let's begin. Let's begin. Come on. Yeah. Which of the following solutions scatter light? Colloidal, suspension, both A and B, and none of the above. Your time starts now. Let's see if you are correct. And try to please give your answers here on the poll. If it's working for you, please try to give the answers on poll. A, B, C, D. A, B, C, D, E, F, G, H, I. Infinity, think again. Add 3, add 2, add 1, times up. So it would be option C, definitely. Very, very nice. Colloidal and suspension both will scatter light, guys. Both are heterogeneous. दोनों ही heterogeneous है. So if both are heterogeneous, both has the ability to scatter light. Tyndall effect will be shown by both A and B. So option C is your fatty answer. Good, Bednik. Very well done. Sakshi, Preetham. Well done. Moving on to our next question. Oh, this is already done. Done before. We are not spending time on this. We have already completed this. Symbol of iron is IR, I, Fe, Fe, and none of these. Chalo, bujhate ja rahe. And your time starts now. Sakshi leaderboard by the end, bache. We have few questions and after that leaderboard will come. फाइनल लीडरबोर्ड देखेंगे एक बार में. And 3, and 2, and 1, times up. It's C, which is Fe. Kya baat hai? Very good. I'm really impressed. All of you have given the right answer. Just tap your back. You did good. Fe is the right answer. Brilliant, brilliant, guys. Next question. Atomicity of chlorine and argon is. Now I'll see. What is the atomicity of chlorine and argon? Diatomic, monatomic, monatomic, di, mono, mono, di, di. And your time starts now. देखे जरा देखे कि आंसर क्या है, कैसी बेकरारी है, ये कैसा नशा है, तुमसे दिल लगाने की सजा है. Come on, people. Add 3, add 2, add 1, times up. Chlorine, what is the formula of chlorine that you have seen? Cl2 and argon is one of those inert element. I told you, loves to stay single, never ready to get mingled. Inert gas always stays in its atomic form independently. Monatomic, Cl2 and Ar, di and mono. Option A is your fatty answer. Ouch. Option C is not right. Sorry. It's option A. Please remember that. Betnik, Infinity and Aditya. Very well done. Next question on your screen. Molecular mass of water. It's very simple. 18G, 8G, 18U, 34G. And your time starts in 3, 2, 1, go. Hi, Rudra. Molecular mass of water is. Ouch. Don't make silly mistake. Don't make silly mistake. And 3, and 2, and 1. Time's up. Those who have marked option A, that's a silly mistake. question have not asked you to give gram molecular mass. They have just asked you molecular mass. If they have asked in a question about molecular mass, your unit has to be MU or UDA. It's 18U, not 18G. 18G only if they ask you about gram molecular mass. Samajla? That is incorrect. So that makes option C as the answer. Oh, oh. That's a common mistake everyone did. It's C. That's right, Sikandar. It's C. Chalo, koi baat nahi. I think you've learned something today in question. If they give you gram molecular mass, gram formula mass, then only pick that gram wala unit. Otherwise, pick U wala unit. Next, what is the molecular formula of calcium hydroxide? Molecular formula, correct formula of calcium hydroxide. Your time starts in 3, 2, 1, go. It's okay. It's okay, Ridhipratap. It happens sometimes. CaOH2, CaOH whole 2, Ca2OH or CaH2. Polyatomic. Remember the rule for polyatomic as well. And 3, and 2, and 1. Voila, time's up. So, calcium as an ion has a 2 plus charge. Hydroxide is a polyatomic ion with 1 minus. We have to put it into bracket. Crisscross, that gives you CaOH whole 2. That's the correct formula. That's option B. Okay, not bad, but still, silly mistake. Please enclose it into a bracket if it's a polyatomic ion. So, Sikandar, good job. Aditya, Rudra, Sakshi, hats off to your performance. Shall we? Next, neutron is chargeless and massless. Chargeless and has a mass. Has mass, has charge and mass, has charge and massless. Chalo, find it out. Let's see if you can do this or not. 3, 2, 1, go. हाँ देखे जरा किसमें कितना है दम. Come on, chargeless and massless. Is it true or not? Chargeless and has a mass. 3, 2, 1, and time's up. Voila, chak de fate. So neutron has a neutral mass but has same mass as proton. That means have mass 1U, if you remember, have mass 1U, same as protons. So it is chargeless and has mass. Option B is your fatty answer. Good. Good, Preetham, Sakshi, Infinity, Realm, Sikandar, Betnik, and Mohana. Brilliant, guys. Till now, everything is going good. Let's move on to my next question. Okay, as you see, neon with atomic number 10, but different masses as 20 and 22 are given to you. So, are they considered to be as isotopes, isobars, isotones, or both A and B? Shuru kare. 3, 2, 1, go. Solid practice है boss. Few questions and at least you get to know what type of question comes in your paper. What concepts are very important that you need to keep in mind. If you are giving any wrong answers, at least work on that and clarify that topic one more time. 3, 2, 1, and time's up. Same atomic number, same element, similar chemical properties, different physical properties. That is none other than isotopes. So, let's see if you have given the right answer. And that's it. Out. Guys, you are getting confused between isotopes and isobars. So, let me help you here. To clarify this and to not confuse between two, trust me, this works. Be a smart player here, smart learner. Learn one thing. Isotopes, learn that. Leave isobars. Once you learn isotopes, isobars are opposite only. Examples yaad kar lo, isobars ki, that's it. Learn isotopes, isobars will automatically be done for you. Clear hai? Just focus on one thing, other one is opposite, automatically be done for you. So in that case, confusion would be way less for you. That's a smart thing to do. Try it out. So yes, it's Pritham Infinity, and I think some of you only gave the right answer here. How many electrons does sodium ion has in its outermost shell? Sodium ion, Na plus, has in its outermost shell 10, 11, 18, 8. And your time starts now. Hi Bethnik, yes sir. Which one, Bitchy? Earlier wala. Just give me a minute. After this we'll do. So Bethnik, I told that to remember both isotopes and isobars, it's better you learn isotopes or isobars, whichever feels comfortable to you. So confusion would be way less. Okay, learn just one. Other one is already opposite. Okay, and 3, 2, 1. Voila, time's up. Chaliye ji. Now, as we talk about sodium, atomic number 11, electronic configuration 281, outermost shell has 1 electron. But in terms of sodium ion, Na plus is an ion which loves to lose electrons. So this 1 electron will be lost and it forms 2, 8. So outermost shell is now having 8 electrons. Octet is now complete. Ions are always stable, then its parent element. Parent atoms, ions are always stable. 1 electron in its outermost shell, but ions, in that case, we have 8. So yes, D is the right answer. Hey, Mama Ji. Guys, why? Why? Outermost shell, how many electrons? Not atomic number. Na plus 1, not sodium atom. Okay, guys, that was a silly mistake. Okay, chalo, never mind. It's okay. Next time, be careful because they will going to twist the question. They will definitely twist the question and you have to be very careful while you're solving it. Okay, Ji, next question. Atomic number of an element during chemical reaction increases, remain constant, decreasing, or maybe A or C. Use your brains here. You might have not read this concept directly, but whatever you have learned will be summed up in this. Physical change, chemical change, atomic number. Let's see if you can find it out. And time starts now. Atomic number of an element during chemical reaction. Will it going to remain constant, increases, decreases, or both A and C? देखे जरा देखे कि आंसर क्या है साक्षी. Careful. And 3, 2, 1, time's up. See, atomic number are like fingerprints. If I get my hair cut or if I keep it long, will my fingerprint changes? No, it will not change. Even if I or you take a makeover, our fingerprints or atomic number will remain constant. So even after a chemical reaction, atomic number will never change. It will remain constant. That makes option B as your fatty answer. That's how we do it. Good. Very good. Very proud of you all. So, Sikandar Infinity, Sakshi, Pritham, and Bethnik. Hats off to your performance. Good. Chale, guys. It's time for us to move to the end of our session. So, बहुत ही उम्दा performance. The very good performance that have been given by you guys. So, by clap. On that note, final leaderboard is on screen. ओ तेरे बेहतरीन छा गए भाई, क्या बात है. हाँ, very nice. Infinity, Pritham, Sakshi, Aditya, Sikandar, Amit, LF Studio, Mohana Rudra, Nirmal Art and Crafts. क्या नाम है, क्या बात है, Vidyasagar Abdul. Okay, Ji. So that was the very good performance that has been given by you all. Try to rectify the mistakes you did. I know some silly mistakes in a mass that you made. Please don't do that. It's not something which is good after reading a lot of things. So read the question properly. That's the only problem, that you don't read the questions properly. Half of the problem will be resolved if you look to each and every detail of the question given. So we have covered all chapters along with the practice questions and numerical as well, formulas along with it, and there is a ritual of my session that I always give you homework. So please finish this homework. It's very simple. You have to find out the correct formula for calcium fluoride. It was lovely meeting you all. Have a beautiful time. This is the leaderboard, those who want to check out. Thank you, Sakshi. Yes, that's your leaderboard. Alright guys, that was it from my side. This is me, Rashida Sachdeva, signing off. Take care, stay safe, stay happy always. Phir milenge chalte in some other session. Till then, all the best. Keep reading, keep revising. So in today's session, some of you are sitting since morning. So hats off to that dedication. I am really appreciating the efforts you all have taken today. So yeah, it will be worth it. So if you want to revise the entire syllabus, you can just go through this video and I'm sure you will be done with the important topics and questions. So I don't have one, Betnik. I don't have one. Thank you. Bye-bye. Take care. Good night. Have a nice sound sleep. Wake up next morning and study hard. Bye. By name. Abda Kareem, my name only. Rachita Sachdeva. Thank you. Bye-bye. Take care.